I'm Sean Connery, and when I'm on the internet, I listen to Slay Radio. Christ almighty!
You can come in, Yuri. Hey.
There we go. Oh,
Hey. How's it going?
Hello, hello.
Hello.
Can you hear me?
Day number.
Yes, Chris. Day number 2. Hey, let's do a proper good morning. You know,
Okay.
good morning, bonjour, buenos dias, bon dia, good morgen, buongiorno. What else? Hey, Polish.
Hey, dzień dobry.
There we go.
Oh, ni hao. I can say in Chinese
ni hao,
as well.
No, not ni hao.
All right,
What
right.
is it? Jiao Shang Hao. I don't think we're going to have too many people from China, but please do let yourself be known if you are.
All right. So good morning. Day 2 of CRX. Today we've got Kris Sekula with us. And Kris is going to talk about what? Tell me, Yuri, what we can talk about.
I think he's going to talk about the Slim PLA. I can't believe. So these PLAs, so the PLA, so the Commodore 64 machine notoriously for working very well until it doesn't. And if it doesn't, the by far number one product that will fail is the PLA. Yeah, it was created by Moss. It started off real good with a Synetics type of component, later taken on by Philips, but then MOS started making them themselves, and they just had a rough life, and they typically fail. Thanks to our great community, we now have a GAL PLA type of solution, very cheap solution, super reliable, very compatible as well. And a great solution to put together. Now, our friend Kris here thought, well, looking at this design, perhaps I can make this even more interesting, and that's where the journey begins.
Correct. Yes. So, thank
Kris,
you for
do you
that.
want to quickly just introduce yourself? Do a little bit of that.
Yeah. So, for those who who haven't met me yet before, my name is Kris Sekula. I'm known from a very small YouTube channel called My Geeky Hobby, where I present, amongst other things, sometimes stuff around Commodore, but I'm into all sorts of tinkering. So any geeky project that I can come up with, that's me. And I try to put up videos, but like everyone else who's got a day job, busy family life, it's not my priority. But every now and then, a project comes that I just can't resist from trying to either publish it or share it with others. So the Slim PLA idea is exactly that. So as Yuri introduced the project, the PLA is the chip inside the Commodore that has tendency to fail. And when it fails, we need to replace it. And for a long time, it was hard to get a decent replacement. But at some point, an open source project showed up. Let me just share my screen. So this is the original PLA 20v8 project that was published a couple of years ago. And it is a decent replacement for the PLA chip. This project has been very successful. Today, if you type in PLA 20v8 on Google, you'll see lots of eBay listings. I mean, those things are available and known to be very well working. So that was not a problem. The problem for me was a little bit different problem. So hopefully you can see my C64. Just confirm that you guys can see it.
Yeah, let me go switch
Yep,
this actually.
yep, absolutely.
Yeah. All right.
So there you go.
What you see here is the original PLA chip. I have, those two actually are dead chips that I had to replace. And I've got here the original PLA 20v8 project. So that's how it normally looks like. My one, the example that I'm showing you here has got the sockets installed, but quite often it comes without the sockets. And if you're lucky and the seller, or if you source the correct pins, like those ones here, the very thin ones, that will go into a standard socket without ruining the socket. So that's the original PLA project. You insert it into your C64. And for most of us, that's it. End of story. Yeah, you're happy that you've got a working C64 again. But for me, the thing that bothered me the most is the looks of it. I'm a bit of a OCD person, so you know, I had it in the C64, but every time I looked at this poor C64, I'm like, this thing is so ugly. You know, what can we do to improve the looks of it a little bit so that it's not this double wide, I call it fat PLA. And that's where the idea of a slim PLA came up. You know, what can we do to improve the looks of it? So let me just show you my solution, and then I can go a little bit deeper, and we can cover a little bit more information about the solution. So that's my my version of the PLA. So it uses the original project. So it uses the same schematic. It uses the same files for the gals. It's everything is exactly the same. The only thing that I've modified, or the only thing that I've introduced, is, you know, compacting the whole thing into this single width solution. Now, you're gonna obviously ask, you know, what happened to the second gal? You know, you only have one here at the top. So it looks nice, but is it the same thing? Well, so magically, if we turn this thing around, we can see that the second chip is at the bottom of this PCB. So for those of you who have done some soldering or have done some designing, you know, you will straight away think, hang on, what's going on? How was he able to put two chips this way? You know, if we look closely, the moment you install one of those chips, the pads for the other chip on the other side of this PCB are hidden. So how am I supposed to solder this thing? So I knew that this is going to be the tricky part. So I decided to, you know, fully document and kind of created a video of how, you know, how to assemble this thing yourself. Yeah. So that's what we're going to show you today a little bit. So I'm going to go a little bit into the details how you can make one of those for yourself. But let's just install it and show you how nice this thing looks in a C64. So this is you know, this is the difference in the looks between you know, the original project and this slimmed down version of the PLA.
This is awesome. It looks totally stock, and I see that the PCB even has the little notch in it as well.
Yeah, thanks for noticing that. You know, I really like the you know, I really like to do that to actually make it look almost like the real chip. So I mean, it's not really that much different from the original chip size wise, if you think about it. Yeah, so you know, you might not even straight away notice that this is a replacement chip when you first look at it. The label on the top also hides the actual GAL writing. So all in all, this thing looks almost stock. Okay, so how can you get one, or how can you build yourself one of those slim PLAs? So let's go into here. So in the Discord channel, I put some of the links, but I've got two pieces of information for you. So on PCBWay, I shared the PCBs, so you can order some PCBs for yourself. As you can see, 17 people already ordered. But on PCBWay, I also have a sort of step-by-step guide of how you can build one of those slim PLAs. Somewhere in that guide, I mean, the guide is pretty detailed, and I mean, if you decide to build those slim PLAs for yourself, please read the you know, read the description, because there are a couple of nuggets of information that are critical when building one of those things. What I also did is I recorded a video, and I put it on my YouTube channel for this slim PLA. Again, this has some tips and tricks. One thing that I've noticed, and I mean, I literally stopped the video at this point. I use the famous Mini Pro very cheap programmer to program the GALs. And like the first batch of my slim PLAs was having problems. I just couldn't figure out why it's not working. And what turns up was happening is the GUI of the Mini Pro. I'm using version 6.85 in this case. What was happening is when I was switching files from programming the left chip to programming the right chip, the GUI doesn't actually take the file correctly. So it looks like it's loading it, but it's not actually populating it into the buffer. It must be some kind of bug in the software. So I had to pretty much close the software and reopen it to correctly open the file. So this
Kris,
is kind of...
Say that again. Say that again. So you found that if you switch...
Yeah, so I'll try to show you this live. Let me see if maybe if we can... I mean, I don't think anything has changed since the time I was doing it, but... So imagine, let me just... I don't know how visible you can see my screen clearly. Yeah. So let's imagine I'm opening one of the files. So I'm going to program the right-hand side gal first.
Yeah.
I'm opening the right-hand side gal. Everything is here. You scroll down. You can see the code is there in the buffer.
Right.
Okay. So let's say you program a device. Blah blah blah. I don't have any device in the. I don't actually have a chip inside the programmer. Yeah. I'm surprised. Yeah, okay, it's going to verify and it's going to say it's failed. Now I'm going to load up the second file. And as you can see, nothing has changed. The buffer is empty.
Zero.
See, this is just zeros there.
Yeah.
So, I haven't noticed it the first time I did that. Yeah. So, but if I close the program and open it again, and load up the left-hand side file, that's fine. The file is fine and, it's all working.
There's some frustration for you, huh?
Oh my goodness. Well, I think I just resolved a batch of 50 that didn't work.
That could be. That could be. Yeah, I mean, it took me a while to understand what's going on. But yeah, I just noticed that when I was loading the second file, it just, the buffer was just empty.
Interesting. Oh, I learned something extra.
That's a good tip for sure.
Yeah.
Okay, so like I said, the instructions are there, step-by-step instructions of how to build it. But let me show you a couple of steps of, progressively getting us to a point where we have a working Slim PLA. So let's see. So starting with the PCBs, obviously, when you get your PCBs, those will be nice blank PCBs. They are pretty clearly marked. You've got the left gal on one side and the right gal on the other side. The right gal goes to the bottom of the PCB. So the marking on the PCB says where is the bottom of the PCB. So this is the bottom, this is the top. And if you go through the instructions, one of the things that I'll ask you to do first is the left-hand side gal. Make sure you mark them so that you know which one is your right and which one is your left. The left-hand side gal, we are trimming the leads on one side of the chip. Everyone is now shouting to the screen saying, "Oh, Kris, don't touch it. You're going to electrostatically ruin this chip." I'll take the risk this time. Okay, so that's our left-hand side gal. We're going to prepare it like this. We're going to trim it, and I'm showing you some tips how to trim it, and we're going to put it to the side. And then what we're doing is we're taking the right-hand side gal, and we're simply soldering it to the bottom of the PCB. Yeah, make sure you follow the orientation. So the top pin 1 is where where the pin 1 would be on the chip itself. And this chip, the right-hand side chip, goes to the bottom of the PCB. We solder it, so we solder both sides, and that's in. Okay, so that's the first step. The second step is to actually solder partially the top gal. So the gal which is marked the left. Remember, we cut or where's my gal that I trimmed? So that's the gal that I trimmed. Okay. So this has long leads and short leads. The long leads will go on the left-hand side and the short leads will go on the right-hand side. So that's our sandwich. Remember that the leads on the right-hand side are hidden underneath the the chip that is already soldered. We only have access to the leads on the other side. Okay, so that's
Chris, when you started that other gallon, did you trim all the leads first?
I did, yeah. And I mean, I'm skipping a little bit here. It's all kind of described in both in the video and in the step-by-step instruction. But I did trim. I did trim the leads after soldering. Very good point. I mean, if you don't trim them, at least the ones underneath the chip, they will be in your way. So yeah, I do trim them. So that's the next step. So getting the top gal soldered on one side. So we're literally just going to solder this left-hand side here. So that's the second step. And the third step, where's my gal? Sorry, I've got the chips here somewhere in various stages of completeness. I just lost the one that I wanted to show you. Give me a second. So whilst I'm trying to find them, any questions so far? Does it all make sense?
No, I think it makes sense. It's pretty simple.
Yeah, I think the board shows left and right. I'm turning my head sideways to confirm if that's the case, because it's easy to swap them around, and it's important to know how they work. It won't work.
Correct. So I decided to stick to the original markings as per the original project. I don't want to confuse people, so I would rather people follow the actual original naming and everything that was originally in the project. So the project originally has a left and the right gal. So I stick to the same on this PCB. The only difference for me is the left gal is at the top of the PCB and the right gal is at the bottom of the PCB.
Right.
But the naming of the gals, right, left, it all stays exactly true to the original project.
Right. Okay? That's very helpful.
Okay, so obviously I don't want to waste too much time here going through the whole soldering process. I just want to show you the crucial part of the soldering when you have to solder the pins that are hidden. Okay, so we'll focus on that. So according to my instructions, once you solder this side of the chip, I recommend the next stage or the next thing of solder or next stage of soldering is the headers. Okay, so at this point you should have the bottom chip soldered both sides, the top chip soldered only on one side, and at this stage you would be soldering the actual pin headers. A quick note on the pin headers: make sure you source the ones with a very thin leads or thin legs.
I think they call them round or machined.
Machine tools.
Is that okay? So let me just show you for comparison what people sometimes attempt to use. This is the standard headers or pin headers. Those are too thick.
For Pete's sake, please don't use those.
Please don't use them because you can insert them into your socket only once. That socket is just going to be ruined afterwards. So you really want to have, and I think in the article that I shared, I have some AliExpress sources. I mean, I just buy always a batch of those from AliExpress. I use them for various projects, so those are good, decent quality pin headers. Okay, those pin headers, again, notice that they have two sides. They have the shorter side and they have the long side. The long side is what is ultimately going to go into, into other sockets, and the short side is what goes into the PCB. So I would normally just solder the headers at this stage. So I have one that is pretty much almost complete. So this one here, we at the point where we've got the bottom gal soldered. We have one side, so we have this side of the top gal soldered as well. We have the headers soldered. So the only thing that we don't have soldered is the stuff on the right hand side in here. So the stuff that is hidden under this other chip. So that's the only thing that we're missing from the soldering point of view. So what I'll do now is I'll show you how how to solder this part. I'm going to use my very sophisticated tool to hold this thing in place. I have a socket that I'm going to just attach this stuff in here and secure it. Let me see if I can zoom it in a bit. So that you can actually see a little bit better what I'm doing. Is that visible?
Yeah, totally.
Yeah, that's
All
good.
right. So as you can see, let me get something pointy. As you can see, this holes here, those are not soldered. So all this stuff in here is at this point not soldered. Now, if you have a decent quality soldering iron, you probably don't need anything else. I normally, when I do those slim PLAs, I put a little bit of flux into, on those legs here. I mainly do it because sometimes when I source those, I mean, those gals, I normally don't get them new, or I don't have them new anymore. So quite often they come. Sorry, my flux thing has just gone. Bring it up a little bit. So what I was trying to say is that the gals that I source are not new. So sometimes they've been stored in all sorts of conditions. So they might be a little bit oxidized. So I put a little bit of flux into those holes just to ease or to help the flow of the solder into those areas. Of course, it helps to have a decent soldering iron, and probably this is not a project for you first in your life soldering experience.
No, nor using the iron that you used for the plumbing job the other day.
Yes, yeah. So the assumption is that you do have a little bit of experience. You've done some soldering before, and you kind of know a little bit what you're doing. I'm sort of doing it under the camera, so I might not be the expert here this time. But if you press the soldering iron and let the solder flow, it sort of naturally wants to go into the PCB. And don't know how visible it is.
Yeah, we can see it well. Kris, I wonder if using a little bit of Captain tape on the right-hand side might help to maybe not bridge as easily to the.
Like I said, I'll be honest with you, doing it under the camera is kind of a little bit more tricky. But when I do it in real life, it takes me a couple of seconds to do. But right now with the delay of the camera, and I don't want to stick my head right underneath because you're going to see how bold I am. But that's pretty much it. And I'll try to clean it afterwards, so you will see that all of this should be nicely flown.
Yeah, I think you brought up a good point. If you're gonna, so first of all, the GAL PLA solution is a fantastic solution. It's 100% compatible. I saw a video the other day of someone that bought poor chips and then said, well, the GAL files are the issue or whatever. That's all nonsense. If you got the right chips, this is 100% good solution. You can run Ghostbusters, yes. You can run the cartridge, yes. You can run it on PAL, yes. NTSC, yes. Zaxxon runs, yes. Everything else that you throw at it. Maybe make the original version with the side-by-sides first.
Yeah.
So you kind of have confirmed working, and then get, a beautiful version like this, which obviously is a much more advanced soldering skill required to get to a result like this.
So after cleaning, look, I mean, like I said, I probably haven't done my best soldering job here because I was doing it under camera and, with a little bit of delay. But as you can see, this doesn't look bad. So the solder, it will wick in. It will pretty much flow where it needs to flow. And this is a valid, valid solution and a valid way of soldering this thing. And that's pretty much it. I mean, as you can see, it probably, like I said, it probably is not recommended as your first soldering soldering job, and maybe if you don't have a decent soldering iron, it will be a little bit trickier. But that's pretty much the process of creating a slim PLA.
I love it. I want to. Did you speak at all to Daniel Montione that made the original solution here and said, "Hey, you should perhaps link this one here or join the PCB there"? You know, he's been so gracious creating this for the community, and you've been so gracious creating it again open source in a next iteration for someone that wants a more pleasing aesthetics, if you will.
Yeah, no, I haven't spoken to him, but Adrian Black from Adrian's Digital Basement.
Yeah, he had it on his video. I saw.
He mentioned it, so I'm hoping maybe I can somehow reconnect with the relevant people. But I mean, like I said, all of this stuff is available. The instructions are there how to build yourself one of those slim PLAs. And if you don't like the look of the original one, like I said, full credits to the original author of the project, because he was the one that created it, and I simply just modified the PCB.
Yeah, awesome solution. So
I'll chime in for a second. The reason why it's so compatible is that I looked at the code for this, and I have Commodore's original code for the 81S100, and it's the same. So basically what he ended up doing was splitting the code into two separate pieces, and then making so that the interconnection between the two would be the same as having a single type of PLA.
Yeah.
So that's why it's so compatible. So anybody who argues that it's not compatible, that's not true.
Yeah, it's anybody that experienced that difference and will have had issues with perhaps the PLA files, and that's why there were different PLA versions for the, I think it was the 15 and the 25 nanosecond version. And then of course there's a lot of crap chips. These chips haven't been produced for a while. A lot of them got salvaged from God knows where. So depending on the source that you got, you may get some different output.
Yeah, it's actually a very good point, Yuri. I mean, I literally this morning I was programming maybe 10 of those chips, and at least 3 out of the 10 failed.
Yeah. And that's that's a bit of a risk with some of the old chips that we order from all over the world these days. You're going to have a bit of luck at times, and sometimes you're going to have to do a few tries to get to that. But nothing new in this hobby for that.
So when you've got a PLA that fails in your 64, there's a couple of things that happen to it. Obviously, weird things happen with, like, if you get glitch graphics and stuff. But if you look at the PLA itself, it's not uncommon to see purple gunk coming out of the pens of the PLA. And that's a very telltale sign that it's dead or going to die. So you probably should replace it.
Wow. Okay.
Yeah.
Good tip.
Yeah. I'm still collecting all the dead PLAs. There's several people that are working on test devices
testers,
and all that, and they're super useful for that purpose. So I tend to keep these old chips, and then they'll come in handy for one project or another at some point in time. But it's almost an if, not a when. Sorry, a when, not an if. Sorry, a when, not an if on this. It's from my repair adventures, it definitely is the absolute number one of failed components.
Definitely.
Hey, Kris, cool project, man. Thanks a lot for sharing with us, and thanks a lot for all the other open source projects that you've created and are creating for the community. Obviously, we want to see a lot more of the Commodore stuff because that's the
so we know you've got products, right? So where can we get a hold of your stuff?
I occasionally list stuff on eBay, but like I said, this is not my day job doing those projects. So it's when I'm sitting with friends on a conference call in the evenings on Friday, I sometimes tinker and solder a couple of those. So the slim PLAs are on eBay. My other projects are also on eBay. That's probably where you can find me. And obviously the My Geeky Hobby blog or the YouTube channel.
Okay, that's cool.
Super.
Cool. Great event. Thanks for having me, guys.
Thanks a lot, Kris.
Enjoy the rest of the day.
Thank you. Hey, that's cool. you know, it's my favorite solution for replacing the PLA. I like it better than any of the.
Because it works.
Any of it. It's cheap. It works. It's been super reliable, and I've done hundreds of them.
Yeah,
like literally hundreds. And I hate putting them together, by the way.
So, Yuri, what is the #1 test program for a PLA if to test it to make sure it works?
Well, you got to do a couple of things, but the one that's a sure way to show PLAs consistently bad is unfortunately my favorite game to hate. It's Sajtron. Because that cartridge uses a bank switching that is timing specific to where the PLA will fail very often. So that's a good one, because you may have machines that will actually initially seem to be totally fine.
Yep.
And then you put a Sajtron cartridge in, and all of a sudden it doesn't work. And if you see that, then you know you can almost bet that the PLA is going to be the first thing that you'll want to look at. You know, there's I see people are often share these pictorial guides, and I like them because they kind of give you at least a feeling like, okay, oh, my Commodore 64 is showing a similar issue as this. It's unfortunately not always as helpful in its solutions always, where it says, you know, go and look at this first. You know, you really have a couple of categories. You've got machines that unfortunately got hit by, you know, over voltage for whatever reason, bad power supply or otherwise. They'll have all kinds of crazy outputs, but typically it's the RAM that gets affected, and then the machine already stops working. But the PLA shows random effects when broken all over the place. So it's not a very blank screen. Blank screen is when it doesn't do anything. Okay, you'll start with the PLA. But sometimes you have like a machine that seems to be working quite fine, and then you start actually using it, and then all kinds of weird stuff happens. The Sajtron cartridge is always a
the PLA is really the heart of the entire computer as far as the distribution center goes, because all the logic goes through the PLA that controls everything throughout. So yeah, one little small thing that's bad, you may not even know until that, you know, instance comes up.
Until that gets triggered. Indeed. It's interesting. This is a cool solution. You know, where the unfortunate thing is, not every C64 board, which is quite surprising, actually has its PLA in a socket. Yeah. And of course, when it's not in a socket, you're going to have to desolder that, which, you know, is a little bit more tricky. Again to get that done. But again, this is a great solution. If you do take it out, then put a socket in its place.
For sure. Yeah, never saw
buy yourself a nice socket, at least double wipe socket, and put that in place, you know, in case you ever have to replace again. The other thing that's interesting is some people will switch PLAs between machines, and they work. You know, they may work, but that's more a timing thing than
a timing thing at that point, for sure. Yeah,
it's really that. It's not like, don't use that as a long-term solution.
Yeah.
Anyways, Jim, where are we going? Are we going to do some Kicad?
Yeah, so we're going to reinvent the same wheel that's been invented a few times.
I love that. I love that. Well, as long as we end up with a wheel again, that'd be pretty good. No?
Right, we'll probably be okay. Yeah, so I'm going to do a little, basically it's a class, I guess, on Kicad, because a lot of people use it for creating various projects for the 64. And if you Google Kicad and 64, you're going to find a ton of things that people have made. But there's not been really any great tutorials, I don't think, on Kicad. And I use Kicad pretty much for all the Commodore stuff. And then I use industrial software for the other things that I do in my day job. But I really like Kicad. It's got a lot of great features, and it's kind of fun to use because it's a lot different than a commercial program as far as there's more openness to it. It's more cartoony to me. It's more fun actually to me than a very strict kind of like Cadence or pads or something like this we've used, or Altium. So it's fun. It's a lot of fun to use.
So how if you kind of would now, so because you bring up you use both a commercial product and an open source product right now,
Yeah.
If someone grew up and like stenciling the old way of PCB making, saying, well, I'm gonna now kind of dive into the new world of creating PCBs on a PC. Kicad really has come quite a ways. There's no need really for anybody doing, let's say, non-commercial many multi-layer boards,
right?
Not go with Kicad anymore, is that
right? Oh, I agree. I mean, I can do literally, I think I can do most everything in Kicad that I would do like in Cadence or something like that. The analyzation of PCB traces and noise and things like that, those are things that are built into high-end, high-dollar programs that don't exist with Kicad, which is understandable, really. But you know what? The way that the architecture is of Kicad, you can develop a plugin module for it, and you could actually add some of those features. So it's something that really is very flexible that you could do. There's a lot of nifty plugins already for it. Yeah. So I can see that happening in the future. At some point you can analyze, it's like crosstalk and noise and things like this, and such. We don't need as much in what we're doing here because we're all low frequency stuff, pretty much. When you're going to get into the gigahertz type of boards, then yeah, it's really important for FCC approval and such.
And with regards to the output, because the output, everybody goes PCB way or JLC PCB or maybe one of the other parties. They all accept Gerber files, which is kind of like
Gerber
a standardized model of
it's the industry standard for all the output for data. And that's what it's interesting too. So because Kicad has the ability to output a specific type of Gerber, and so for like naming conventions and such for each one of the layers, and I know JLC PCB and PCBWay both understand those differences. And so what we used to have to do back in early days of doing this online work is that you would have to specify each layer name, what they were. Now it basically imports it, automatically recognizes the layer name by the name of convention it's using, and then pops up and you can take a look at your Gerber, converted Gerber data on screen, like on JLC PCB, I use quite a bit. And so, I mean, from the hobbyist standpoint now, it makes life a lot easier. You could literally just go right from your design to an online source, and you can look at your board just to verify that it looks like, it should look, and then, submit it for production. It's super simple. Or, back in the day when, back in the 80s when I was making Commodore, electronic stuff like Supercard Plus boards and Supercard Amy stuff, that was all hand done, with rub-ons and, everything was done that way. And so we didn't have schematics really that way. We had schematic as a piece of paper. We didn't have a schematic as something you could associate with your design and checking it. So that's one thing that Kicad has. So it's a schematic capture. So basically you're going to draw a schematic, and then you're going to assign for each one of the parts that you want to put on there, what the footprint looks like. And the footprint is the physical holes. If it's a through hole part or an SMT, it'll be the pads for the SMT part. And so when you go from a schematic into your PCB, it magically puts all these little parts in on your PCB, and then it's a mess of stuff. And then when you've added all your traces or your connection lines in your schematic, those become traces on your PCB. But we don't have auto routing on Kicad. That's very easily done. You can do it through a plugin, some exporting nets and stuff. But basically what you're going to get, and you'll see, I'm going to do a demonstration for it today, is you're going to get what's called a rat's nest. And it'll be a whole bunch of trace lines of like, this goes to this goes to this. And so it's your job at that point to route those by hand, one place to another. So today's project is very, very simple. It's simply just a cartridge extender. So we're going to, for 64. So it's a cartridge that plugs into your back of your 64 in the cartridge port, and the circuit board extends out, and then there's a 90-degree connector. And that's it. And then we'll have a reset switch as well. And so we can talk about how we want to design this, because we're going to be designing it in real time here. Do we want to have it so that the reset switch is on the outside of the cartridge connector, or before the cartridge connector, and the cartridge connector sticks out a little bit further? So we'll have to make those design decisions, and we can do that while we're doing our actual layout for the board.
Okay.
You'll be able to see we can move things around anywhere we want to, and then like the rat's nest will change and all that. And then we will go and we'll add the traces. Now, I worked with Kicad for a few years now, and I actually have a whole bunch of macros programmed on my keyboard. And I won't use any of those today, but doing that makes life a lot easier for aligning things. So I'm a real stickler for when you're running a trace between two pads down the center of it.
Yeah,
you really want to make sure it's dead center. You don't want to be next to the pad. And it still works electrically, but from a noise standpoint and for what I do in the day job thing, gigahertz level boards, that never would fly. It doesn't work that way. And like you've got two traces side by side, you got to make sure there's space between them.
Well, I think these are the type of things, if you start doing this and kind of follow along with a tutorial like this, these are good habits that if you start progressing into like more mature or more advanced or faster type of designs, you don't have to think about this anymore because you've already started good habits.
Right. So you've got the capability of having crosstalk when you've got traces on the top and the bottom that might be moving or actually next to each other side by side, like one layer is here, and you might have a phasing issue. I mean, there's all kinds of things that you really don't think about could be a problem. So about 18 years ago, 17 years ago, I designed the longest range 2.4 gigahertz transmission system in the world. And it's still that of today. And it's a little module. It's basically the size of your thumb. And so the front end chip on it is made by a company called RF Access, which got purchased by another company. And I worked with their engineer, and the guy was an old Russian satellite engineer. And so I brought in a prototype board using their front end chip, and I was having a problem with it. And so things that you wouldn't really expect at all to happen, he taught me something about high speed that I didn't even know. And so if you've got an SMT chip, it's like a 3mm by 3mm square. That's a super tiny little chip. That's the front end chip. And it has 5 pins on each side. So it's got basically 4 times 5, so 20 pins in this chip. And you've got the little tiny space between each little pads. You got to remember, this little chip is only 3mm by 3mm. So these little pads are super tiny little thing. And so I wanted to put, there's the 2 power inputs, and I wanted to just put a little jumper between those 2. That little jumper was an antenna.
Right.
And it was a huge, putting 2 vias in it next to each other and connected it, fixed the problem. But simply just a single via with a jumper, that little jumper was enough to create a huge amount of noise interference. So you wouldn't think about things like that would happen, but so I learned from that, basically don't do those kind of things and make sure everything's perfectly straight. And I mean, I've done that for years, but that really enforced it in my head because I could physically see something, that on a scope, on a logic, or a spectrum analyzer, the differences. So thinking about the C64, obviously computer, 30, 40 years old, components on that, many of them may not have been produced for decades. Yeah.
Cartridge connector, obviously a bit of an oddball thing. It's got those little fingers on them. That's, I presume, a lot of that stuff is not, let's say, stand part of the library or something in Kicad.
Right. So with Kicad, they have libraries of parts. So they've got libraries of dip packages, a lot of different things, and then you have the ability to create your own parts. And like you're saying, there's no stock Commodore 64 connector that comes with Kicad. And so you have to create it yourself. And that's what I did for like the ICS 64 motherboard I created the fingers for the cartridge port and the cartridge port connector, or fingers for the user port, and the cartridge port connector, and all those things manually myself. And I had no idea that anybody had made them. I didn't look, I just knew that I've done creation of parts, so it didn't matter to me. And then, so we were talking about this the other day, and you linked to somebody that actually had created all these parts. And
right.
Today, actually.
So, because I've been, I bought this course for Kicad, a really nice course, and I very early on already ran into like, okay, I get what they're trying to do and what they're trying to set me up for here, but what I want to use it for is for all this old stuff. So I started, slowly collecting some of these links because I think, and you and I spoke about that briefly, creating some of these parts is not, you know, is not the fun first thing
No,
to
it
start
is
doing
not a fun
with
part.
KiCad.
It's key.
So being able to use a library of some of these pre-made components is going to help you a lot to skip something that maybe later you may get interested in, but there's no relevance for your initial adventures in KiCad.
Right.
So we're basically using a couple of elements here that have been added to the library, weren't a standard part of KiCad, but are all features that can easily be built upon KiCad, and many people have already done some of the hard work.
Right. And I guess a lot of some people's, because I've seen, you know, a lot of different people making the same parts over and over again.
I bet. So that's
I did
the
a
other
Google yesterday on that. It's like, wow, there's a lot of people doing the same thing. So we're using KiCad. So if you don't have KiCad, you can go to kicad.org and you can download the, they've got it for Windows and Linux and I think Mac as well. And so you can download, install it. And what I'm going to do is I'm going to go share my screen here. And if I can find my screen, here's KiCad. Share screen. Okay, I'm assuming you can see this, right?
Yep. Yep.
Okay, so this is what we get with KiCad loaded up, and I actually made a new project with this in here already. I just made this is a simple CAD. Oh, wait a minute. Oh, simple. I call it simple 90. That's what we're calling it. So this is what you get in the opening screen, and if you double click on the schematic, you're going to have a blank schematic, of course. And if I go back to that window here, I click on the circuit board, it'll open up a blank circuit board. So this is what you start with. So we're starting from scratch. So what you want to do is the libraries that you install, I'll give you a quick tip here. KiCad's a little confusing, and I have to say that pretty much all the circuit board software creation programs are pretty confusing in this regard. They wanted you to basically have your libraries located together, and I don't like doing that. I like making everything individual for every single project that I do. That way it's portable. So if I want to include the libraries for it, for the footprints and stuff, they're all in the same directory as the project, and I can just archive the project and share it. And that's what I'll do for this too. When we're done, we'll share this project. Okay. And so you go into your preferences and you go to manage symbols and libraries. You can see these are all the libraries that come stock with it, or actually the ones that I've installed along with it. But when I go over to the next pull down or the next tab, and it says project specific libraries. Yeah. And I'm going to add a folder. And I made a folder called libraries, which I always call it libraries. And then this is the hackup / commodore.lib, which is that thing I had downloaded that you had linked to. In fact, this is actually in the Discord right now. You can download the library from there. And then I'm going to open it and I'm going to say OK. And this should actually say OK. There it goes. So now that has taken those libraries and entered it into my project. And that's important because when you go to place a part, which you do through here, you can say add symbol, which is actually a part. I can type in C64. Whoops, if I can type. And I can see that the hackup Commodore library is here. And you can see that they have a cassette port, an expansion port, which is a cartridge port, a user port, and then another type of user port, which is more simple. Yeah. So what we're going to use is this one because it has all of the signal names in here, which I like. Yeah. And so I'll just say OK, and that added it to our schematic. Awesome. So that's part of the first part of the schematic. Now, I think the easiest way to build this particular project, because remember, all we're doing is building like a 2.5-inch extension cord, basically, with a 90-degree socket. That's basically what it is we're building, right? And a switch for the reset. That's pretty simple. So what we can do is we're going to call this one, we're going to make this one the connector. So this is the actual 90-degree connector piece, the straight up connector. And then we're going to simply copy this. So it uses all the same regular conventions for PCs and such. You can do Control-C and then Control-V to paste it. And I'm just going to move this over here. And I'm going to call this one fingers.
Yeah.
Because that's what plugs into the cartridge port on the 64.
Yep.
We call them the fingers. That's the name. Okay, so now we've got the connector and we've got the fingers. So let's go over to our circuit board. And in the top here, you've got an option that's called Update PCB with changes made to schematic. And so if you click on that, it'll bring up a requester or a window here, and it tells you what it's going to do. And there's two errors here. You notice that it's highlighted, right? And that is, they cannot, there's no footprint mentioned for them. So there's a footprint is the physical part layout, what it's going to look like. It's like, okay, well, we don't have a footprint. So to do that, we have to go to our part. We're going to do this one first. And we're going to say, just hit the letter E, which is edit, or you can go to the edit pull down menu and say edit. And you'll notice in here that there's a reference, there's a value of what it is, and then there's a footprint. And so we don't have a footprint assigned for this. And so now we need to attach a footprint, except that we don't have any common footprints in here because we don't have a library added yet. So what we need to do is go back to our circuit board software and do the same thing that we did originally. We're going to add a library to it. And I'm just going to add the libraries folder, which has the footprints in it. And now we can go back here and we can go to libraries, which is here. And now we've got
that
fingers.
looks like on.
And this is the cartridge.
Oh, yeah. Excellent. So we found the fingers, we both found the fingers and the connector.
So we're going to just double click on this and say, okay. So we now, if we were to go back to our circuit board software, it's going to only error out on the second one because we've not assigned a footprint yet.
Got it.
So we'll go back to here and we will click on this one and we're going to assign a footprint for this. It's for fingers. And we're going to double click and say, okay. And now when we go to the circuit board, everything's good. We can say update the PCB and look what we got now. We've got a cartridge connector and we got some fingers. And this is great because of the fact that this particular layout is for a cartridge itself. And so it has some things that we're not going to use, but it has things that we are going to use, which is great. So this is the hole in the cartridge that you would screw into if you were building a regular cartridge. And so we don't need that for our project. So we can actually delete that, and we will do that in a little bit, but it's a great start. And so everyone's always excited to see, I know it was the first time this was available, the option to see what the circuit board is going to look like in a rendered state. So if you press Alt-3, and I don't have any idea how they came up with that combination, Alt-3,
okay,
it's going to give you a rendered version of our board. So we can see what it looks like, and you can see this is the holes that are typically in a cartridge.
For the two types of cartridges, most common.
So for the pins that go through, or the screw hole goes through. So we don't want that. So what I'm going to do is I'm going to close this out.
Can I ask you though, with regards to tomorrow's extension in
making a case for this
in the casing, might it not be useful to maybe keep it in?
Well, you could. Except that one thing we're going to be doing, because we know what we're designing.
So the routing might become an issue.
Yes, exactly. So doing the tracing through here. So what we can do, and we will do this a little bit, is that we're going to figure out what kind of a case do we want to put this in, and do we want to keep it as slim as possible? Because one thing about a cartridge for the 64, it's very thin walls on each side here. So you don't see any cartridges ever with screw holes out here because it physically wouldn't fit in the 64. It's not much wider than our cartridge area here. So, and remember last year, we actually designed a case for the 64, for a cartridge case. And that was, if you look at last year's lesson in SolidWorks, that's what we designed, was a typical cartridge case. So we need to figure out how we want to do this. There's a lot of ways you can do it. One way that's really easy for something like this, I would do personally, would be probably put a screw hole here and a screw hole over here on the
Okay,
side.
kind
So
of like
basically-
how you would do standoffs. Even you could double.
Yeah, I would put a hole here, and you may not even
Yeah.
put a screw. We might even on the case just put a pin that pops through. It's plastic.
Yeah.
That
Okay,
just
that
basically
makes
it
sense.
registers the board so it can't move.
Right.
And then we're going to use the clamshell effect to actually hold the board in place. And then we can put screws at the end of it or wherever we want to do it, or locking tabs. There's so many different options you can do. And so the fact that you can do this and do a render, Kicad lets you export this as a step file. The step file you can actually load into SolidWorks. And we are going to have the exact board that we're going to wrap the case around when we're done.
Yeah.
Which is great because there's no mystery about how wide is this board going to be. You're not sitting there with your micrometer trying to figure out your measurements wise.
Right.
And so this is like the holy grail for developers that want to do an enclosure, because we have the actual circuit board and we have the ability to change the board width, height, and stuff if we don't like what we did with the case, or maybe we find we want to add something to the case and we have to tweak the board a little bit. It makes it life a lot easier.
So, but that also, so you bring up a good point though, eh? So because you kind of have to think about the finished product already at this stage, because there may be some mechanical attributes that you can add to the PCB that may or may not be possible for step 2, or may hinder you in this step. Like you said here, hey, if I leave this all in the middle, while mechanically that might be an interesting one, from what I need to do here with all of the lines that I need to pass through, it may not be the smartest solution.
That's true. And what you're going to find a lot of times is that when you're doing your design, you may find something that you like registering this. Like example, there's 2 pins here. You may find that's not adequate to register it. And you find that you break it during the assembly, or you break it to normal use. And you have to change the way that works. That's why we do, prototypes. And, we beat them up to make sure that they're going to work. And so this configuration of having the ability to change your circuit board and then also change your SolidWorks files basically in real time, and then get a prototype made on your 3D printer and then through JLC PCB or something, it makes it very quick. It makes it very affordable for doing development work. And that's one of the reasons why I like using things like this, is it's super quick. Now, like I said before, we're not going to use this. And also, I don't want to use these little lines here as well, because if we go back and take a look at here, you can see that we have these little corners here on our circuit board. And I really don't want that, because I want to be able to make this board any size I want to. And so I'm going to just delete those. Those are super simple. And so if you simply click on the part and you hit E again, everything is E for edit. And when Kicad's very, it's great as far as everything is the same for each type of system using, whether it's for font creation or whatever, it's all the same.
Yeah.
So if you look in here, you're going to see an option that says update library, change the footprint, or edit the footprint, or edit library footprint.
Okay.
What we want to do is edit the footprint. We don't want to edit the library footprint typically. And the reason why you don't want to do that, because that's the one that's the built-in libraries typically, and you don't want to change it forever. We only want to change it for this particular design. And so you use edit footprint, and it opens up the editor. And now you can see here how the part's actually created. So if you're going to create a part, this is what you would do. And so if you select like the A pad, you can hit E again, because everything is E for edit. Then you can change the attributes about that pad. You can make it oval instead of being a round, and you can change the size of the actual copper part as well as the hole itself. So these are all things you can change and how everything looks. So all we want to do really in this one is we want to delete these. I'm just highlighting them, hitting the delete key. And that's it. And then the top here, you can say save. Well, actually, I'm going to do save like this. Save, and then exit out. And then now you can see this is gone. The corners are gone. Yeah. And if you do the Alt-3 to go into the rendered mode, now you can see that they're at the edge of the board like this. Yeah. Which is great, which is what I wanted. So I'm going to do the same thing for this part here. I'm going to go edit the footprint. And I'm simply going to go and delete these and save it. And now we have got, those are gone. So this is basically our entire project, really, right? So we're just building an extension cord of this.
Yeah.
But what we need to do is we need to shape the board to the shape that it needs to be. So ironically, Kicad's smart enough to know that the width of the board can be no less than the width of the largest width, which is what this is here. But we can change this to be however we want to. And to do that, we go to our edge cuts, which is what the board perimeter is called for this. And then we just simply do this. We just draw something around it. And so now you see in yellow, they're edge cuts. And if I go back to here, now you're going to see our board's that shape.
Okay.
So we use the edge cuts to define the shape of our board. So typically what I like doing is try to make this on some even grid so that we can look. And so there's options for setting your grid and your size wise. So we can actually change the grid size to be a much larger grids if you want to. And then
snap it to that grid. Yeah.
Which for track sizes and for via sizes, you can change all of that. There's a lot of work involved in setting up all of your tracks and your vias. And so it's like a little bit more than I would want to explain in a very simple video like this. I would highly recommend you find someone's project that already has everything set up and simply copy it. And you can do that pretty easily by going to a board setup.
Yeah.
And in here, you can say import settings from another board. And then I'm going to say select all, and then I'm going to pick a board file. So I'm going to go to my stuff, and I'm just going to go pick one of my boards. And it's going to, now on the right-hand side of the screen over here, you're going to see all these different layers and such. I get rid of most all that stuff and only need what's important. And so now you're going to see on the right-hand side, I've only got a copper layer for the top. I got 2 internal layers, which I don't need actually. I probably should delete those as well because there's only 2.
And then the bottom layer. So okay, so
and then the silk screen, and the bottom silk screen, top silk screen.
4-layer board, if you will.
The mask.
That you imported.
Yeah. In fact, let me actually import a different board.
If you would have imported like the cartridge from what, a year or 2 ago.
Oh yeah.
The Marco Zarco cartridge.
Yeah, exactly. Well, actually, what else I've got in here I can actually import? That makes more sense. I don't know what that particular cartridge is. I do know that this board is 2-layer. Select all. Okay. Yes, that's what I wanted. Okay. So now we've got a 2-layer board.
Yeah, there we go. Yeah, I see
top
it.
layer, the bottom layer. The F silk screen is the front silk screen. That's the bottom silk screen layer. The masks are the areas of copper that are going to be covered or uncovered. So you can see that each one of these little holes here is going to be uncovered actually, so that you can stick solder to it. Everything else will be covered. You have a user drawings. The margin, I have no idea what it is in this particular program. I've never looked, see what it does, but it's always stays there. You can't get rid of it. The courtyard is the actual area that the part uses. It's the shape of it. So it's the area that the part will occupy. And so in the design rules, when you check your circuit board, you can see that one of the options is overlapping courtyards. So if you've got 2 parts that are too close together, it'll tell you they're too close because you need to separate
because
them.
there's a risk that they physically wouldn't fit.
Yeah. And then there's a fabrication layer, which I always use. And so in this case here, the fab layer is actually where this text is located and where this little finger thing is. So this design is really cool because whoever did this, this hack up thing, they actually made an outline of the cartridge. So this is the actual cartridge and it will be inserted up to this point in the 64. So it tells you where this starts to be external to the 64, which is great for us because we want to be able to figure out where to put this thing in a reference to this.
Right. But that piece that you just selected, so this courtyard that you're on now, would not show up. It's for your design.
Right. So if you take a look on the right-hand side here, you've got all your appearance information. And so these little view things is much like Photoshop and any kind of program. When the eyeball is lit up, then you can see it. So if you turn it off, then you're not going to see that information.
Got it.
So it's really handy when you've got it, when you're doing things like this where you want to know. Let's say, for example, we're trying to position this to be somewhere here.
Yeah.
Well, if we didn't know where this line was, it would be very difficult for us to go, okay, where is this going to be?
Yeah.
We'd have to go.
How deep do we need to distance this?
We have to get our micrometer out and we have to measure it and figure out exactly how far we want it to be from here and there. Yeah. So that's no fun, as you would say. So I'm gonna leave this on here. So again, like I like to do is on this edge cut, which is basically the shape of the board itself. I like to try to put it, or anything else, as some kind of a reference to some kind of center. So if I use this and I go into here, okay, one thing I skipped over here, Kicad caters to everybody as far as where you live and what metric system or US system or whatever you might want to use. So you could do it in inches, you could do it in mils, which is thousandths of an inch, and you can do it in millimeter. I'm in the US, so I don't use anything that's millimeter unless I'm using something for an overseas client. So I use millimeters, or actually mils and inches mostly. And so if you go into E on this part, I can actually set this at some particular space that's an even multiple. Like if I want to do, just say 5,500, and then I'm going to do 4,700. That way I've got a nice reference to an even number. And it makes it a lot easier when you're working with something to be able to go snap it to it and move it. So obviously we couldn't make the cartridge this thin if this connector was going to not fit in here. So you can see we're a little over on here, which is fine. We can have the cartridge connector hang over the edges, and we can have this close as possible to the edge here, so that it fits in our 64. Because we got to make sure that the cartridge will plug in. Because if it doesn't plug in, it's a waste, obviously.
Right. Yeah.
So we're going to just move up to here, and I'm going to just do to this. Now, again, you can set your grid. So that's set, it's really set for high. So I usually set it for 5 mils, or
so you can really be on the edge. Yeah. That,
like the edge like this. And then so you can verify this whole thing by going back, and I do this a lot. I look at the rendered a lot to see how good this looks and how accurate it might be. It's like I want to look at this corner here. Make sure that this corner is okay. And so what we'll end up doing in the final version of this board after in post-production, basically, a very good thing to do for the 64 cartridge port is called chamfering. So we'll actually take a file to the edge of this on the top and the bottom. So we make it a wedge, so it plugs into the slot easier. You don't have to do it, but it's, if you notice, there's probably maybe a third of the cartridges out there that were made that actually do this old school. It just makes it easy to plug into the cartridge slot. And
so that's an interesting thing. So the chamfering is done at the moment you basically set the specs for the PCB fabricator. It's not done here. So the Gerber file doesn't depict the chamfering need. Is that what you're saying? That's correct. And what you want to do is you know how much chamfer you want. And so you're going to account for that in the fingers. So you see there's a little bit of a space between the edge of the finger and the edge of the board. That's to account for that. And so that's kind of based on experience and what angle you want to do. You want to do a 45-degree angle, which is very common, or you want to do a 33-degree angle, whatever you want to be doing. You got to make sure that when the board manufacturer slices this, or you do it in-house, because back in the day, board manufacturers couldn't do it. We actually had a jig set up. You had a jig where you just put them in one by one, and that's and it's a sand block, and this goes and you're done. So that's how we did ours. But we had enough space in here, because if you don't have space, then you're going to be like gouging out the copper. Yeah, you're going to be stripping. It becomes very ugly because you can actually pull the trace, if you will. Yeah, you can peel the trace up. So we want to have a little bit of space here left on purpose, just so you can do that if you want to. If you don't want to do that, it doesn't really matter if you have the space anyway, because it's somewhere in here that the 64 makes contact, and it's it varies between the connectors of how far inside of this area in here that you're actually doing the contact with the connector itself. So
I looked at this, I go, yeah, that's pretty good. That's great. But here's the deal though. I'm pretty good at eyeballing this stuff, but you know, I'm not perfect at this. And so you may have it like this, is where you can see it clearly that it sticks out further one side than the other. So Kicad has amazing capabilities that I hope everyone uses for fixing this kind of a problem. So if you simply click on this part, and then you hold the shift key down, which is pretty common for add, because you can see the cursor turns to the plus symbol, and you click this, actually you can, or Kicad will actually sometimes pull up a requester like this to asking you which one you want to select. And we want to do the footprint itself. If you move the mouse pointer and keep it over the part that you want to use as the reference, and then right click, it pulls up a dialog requester box here. Pop up.
Oh, there, align.
And then so you got all kinds of options in here. I use the align, and then I say, for this case, I'm going to align to horizontal center, and it's going to snap this over to be perfectly in line centered.
Fantastic.
With this part.
So you won't have
centered.
a cartridge connector later that is kind of slightly off because, you know, it looked okay on the screen, but it actually
wasn't. And you're like, oh man. So, and you start noticing that when you start running your traces. Because now the traces have got a little bit of a hook to them because they're not straight anymore. And so this cartridge port, the fingers with this connector, we're going to have perfectly straight traces going to it. Well, except for the second row here, it'll wrap around on one of the two. So what we didn't do though, of course, we didn't figure out where do we want this in reference to this line. So we know that the cart will be inside up to this point. So then we got to look at, okay, so if it's inside the 64 to that point, is that the back of the 64? Does that include the case itself? How far back? So we probably want to leave a little bit of extra room in there. We don't want it actually touching the back of 64 because we have to have some space in there for a cartridge to pop in.
Oh yeah, that's true. Yeah, that.
So we look at, there's a cartridge here. Actually, I'm going to stop sharing my screen real quick to show this because this is kind of important, I think. Okay, so here's a typical cartridge case, and we've got the width of this cartridge. So we're going to be sticking a board into here, like this. And so a typical cartridge, obviously, it simply plugs into here. But we're building this board, so it's going to stick out of here. And then it's going to go up. So we want to have this, that we want to have it here, you know, so that it's here, or do we want to have it out here, here? So these are part of the design decisions that we have to make when we're designing something like the particular product here. How far do you want this to stick out? And so once we know that, we want to stick out, you know, and then so that's going to amount, it's going to matter for what do we want to do about a reset switch? Do we want to put the reset switch on the outside of the board so that's behind the cartridge? Or do we want to put it in front of the cartridge itself? And you got to remember things like, let's see, some great cartridges like this one.
Oh yeah.
Where it's a little bit thicker than the average cartridge. So, but it has, you know, this little recess in here. So you can actually get your finger here. But would it be better to put the reset switch on the outside of the cartridge? Or would it be better to have a right-angled one with a push button on the backside? So these are all the different things you needed to take into consideration when you're designing something. So I don't much care. What do you think? Outside or inside, do you think?
I think probably best, on the outside. Give it. This is a good example. Most people will have a cartridge like Gideon's.
So let's do
and actually Gideon's is a really good example because that bump that sits on the front will force you to put that connector even farther away than the line that you were showing right now, because it basically comes back in. So even that 1 inch distance or whatever that may be that you got there is probably going to be insufficient.
True. So what we're going to do too is that since we don't have a switch in here, we're going to go and we're going to place this apart. And I'm just going to type in Omron because I know Omron makes switches. So if I need to spell everything right today, right? O-M-R-O-N. I think that's in this library. Oh, I switch. There it is. Okay. So I'm going to add this switch which is going to be our reset switch. I'm just going to put it right here. And we know we need to make a footprint for it because we don't have a footprint.
Yep.
And so I'm going to make a footprint. And in the stock libraries for Kicad, there are button through hole switches. And so we need to pick which one we like. And let's just do, let's just do a reference. Actually, we can just do this one. That's fine. Okay, so now we made a footprint. So now we go back to our board and we're going to, again, update the board from the schematic.
Yeah.
And we are now magically going to have a switch. This is a simple standard push button 6mm switch. So we're talking about putting the reset switch out here, right?
Right.
So
probably on the corner, right? It sits on the right-hand side. So we're going to put it on the right-hand side there where you can actually reach it.
So we talked about before this in the video, we were talking about actually making a special cap for this.
Yeah.
And so are we going to be able to see that if the cartridge is in point? Is it important for us to be able to see that or not, you think? So what we're going to do is we're going to take one of my
be able to reach it,
caps,
obviously.
And we were going to make a keycap switch.
Yeah.
For this.
Oh, that's true. So we need enough space. So maybe it needs to be then in the
Do we
front
want to have it here so we can always see it?
Yeah.
Do we care?
Yeah.
Is it an aesthetics thing or is it just a functionality thing where we can
it will be in because we were going to do it with the keycap. So here's the thing, because you and I know, but no one else knows. All of these people that bought the keycap campaign will all have had one extra key, because remember you have that Commodore key, and that Commodore key is either a blank one that you received or it's one with that 64 logo on it. So in either case, you will have one extra key. And what we were thinking, like, rather than making a pendant out of it or other creative use, how about we would create this little cartridge, we would have a reset switch on it, we would make a casing for it, and we would reuse that switch in this casing. That was the thinking. So in that case, indeed, it would need to be in front.
So it's an aesthetics thing at this point. So we need to move this actually out this way. We want to move this switch here, somewhere in the middle here. And again, we'll just do real quick to here. We do an align. And you can do a shift here on all three components then. Sure. Yeah, you can actually do everything together if you want to, like this, and this. And then whatever the last one you've selected is the reference always.
Is the reference. Okay, the last one is the reference. Okay.
Right. And then so now you can see this one snapped. So these are all centered from each other. So we don't know what the distance is here to here. We do know that if we go to Alt 3, now we can kind of see what it would look like for an idea. We're missing the graphic for here. And to do that, you can go into Edit again. And on the top here, there's tabs for features for this particular symbol. And so you can see here is our the pads for this, what it looks like on a 3D model. And there's no 3D model loaded. And so what I always do is I make my own 3D models pretty much. And so lesson, I'm going to go to simple 90 and 3D models. And
there we go. Yeah.
So this is the now. What you have to do is, I'll open this up to make it a little bigger. Make sure it's in the orthographic mode so that the pens look normal. Otherwise, they're going to be three-dimensional looking, which makes it hard to do. I'm going to go to the bottom of the board, and then ideally, what we're going to do is we're going to flip this over and we're going to line all these pens up real quick. And so you just do this because now we know that that's wrong. So I need to do the other direction. There we go. And then I'm going to snap this back to bottom. And then I'm simply going to start doing an offset for this. That's the wrong direction. So I can just fold this down and slide this over.
Yeah.
That's pretty close.
Oh, that's great. Yeah.
This one. So now then you can zoom in, and I will pick a pad. So again, make sure the orthographic view is off, because if you don't, otherwise it does this.
Yeah.
And you see like a three-dimensional view, which you don't want. So I just pick a pad here. And so it's not rocket science for this. It doesn't have to be perfect. It's just basically giving you a representation of what you want to see. 25, so 20, 20, and let's see, 10, wow, 15, 18, 17. Okay, that's close.
Oh, there you go. Yeah.
And this one is going to be, I can't tell which way is which on this one. So 190 to 1, so it's got to increase. So let's do
182 or so.
That's close enough.
Yeah.
Okay, so that's done. So now we've got our
fantastic. Yep.
Yeah, so that's what it looks like. We can see how much hangover there is over the edge from our design and all that. Now, if you wanted to not have it hang over, we could literally just change the shape of the board so that it wraps around this.
Right.
And we may end up doing that. I mean, who knows? Maybe, but things like this are really handy for having registering in your case. So if your plastic can come up and it can lock in this little corner here on each corner, that is a freebie because you don't have to actually design a locking mechanism at that point. That's basically going to register so it can't move left or right. So that's a pretty handy thing to have. Okay, so one thing that would be handy for us to be able to physically see here would be where this actually inserts, at least temporarily. So I like doing this. We go into your silkscreen layer and you select the line, and I'm simply going to just draw a line from here to here. And that's good enough for me. All I want to do is I want to be able to see how much of an area we've got in here for our switch and for this. So we know this is where the 64 meets the back of it into here.
Yeah.
This is all gone basically, and this is where the board starts sticking out. So one thing we need to make sure too, and I know for a fact because I've done a lot of keycaps in my day, is that the keycap will fit in this space over top of this switch. And we're going to make an adapter. So the switch we use is not going to be this particular one. It's one with a taller actuating point.
Yep.
So it's got a stem. So that we'll make an adapter for the regular keycap.
Yeah.
Micro caps for that.
That kind of fits over that stem. You have those stems in like
exactly. It's kind of like the mech boards adapters for it as well. Same kind of idea.
Now, Robin brought up a good point. If you put this in the 128, that sticks especially the D. Remember how that is further recessed. This looks very cramped. It looks like the connector is very close to the switch.
Right.
And
so this is one of those things in your design. You're like, okay, do I want to make this work with a 128 DCR? And you're like, yes, I do. So that's going to make your board a little bit longer. So you may find that when we go back to
the cost of these boards, Jim, when you're designing something like this, and this is all like low volume, someone is making it. If you go to JLC PCB, this board versus this board, you know, even 50% longer, is probably not going to change a dime in the production.
It might be 10 cents if you extend it a half inch or an inch. I mean, the difference. And so this is one of those things that oftentimes we do as developers. We may make 5 versions at the same time.
Yeah.
And make this one that's a little bit longer and this one, and we go pick which one works the best.
Oh, so you go that far. You even produce all of them.
Oh, yeah, I might actually, like in this case here, I would actually probably produce at least two boards with 2 different lengths, just so that I would know that's like, okay, this one's horrible. And then usually what ends up happening here is a lot of times you end up splitting the difference on your final version. So you make a 3rd board. Right. But, you know, that's the cost of developing. That's how you develop things, you know, where things come out to be perfect when you're done. So, okay, so we've got this, let's say this is our kind of our design. We'll just rough this in this way, but we don't have anything connected together. And so in the schematic, in this particular case, what you could do is you could make a connection. You just click on the trace, and we want to have A connected to A. But you can quickly see when we start doing this, it's going to be a mess in your design.
Right.
You can live with wires crossing each other. They're not physically touching, but they're in the design. Then you can do that. I don't like doing that. Almost everything that I do, I'm a huge fan of global labels, or at least a local label. So I use labeling for everything. So I'll do like, this is going to be ground. And so and then I will tie this to this, and then I will copy it because I'm really not a big fan of redoing things over and over again. I'll copy, then I'll put it over to here like this. And then now what you'll see when we go to our circuit board is we're going to see, look, this should be connected to here.
Yeah.
So what does that tell us? Is that one thing we didn't look to see if this was the right direction. So it's rotated the wrong way because these should be straight. If we wanted to flip the cartridge around backwards, we would do it like this. And we can see that obviously immediately it was wrong. So that's bad. So by simply hitting R to rotates your part. So it rotates dead center. Yeah. So it makes it easy at this point. So we know this is going to connect to here. And then so we're going to go into the next one. And again, I copy this and I paste it into here. And then I hit E when highlighting it. And then I know that this particular thing is +5. And the next one is also +5. So in a case like this is really, really rare that we have 2 copies of the same thing. Right. I will just do this entire thing on one side, copy the entire thing and paste it over.
Got it. Yeah.
At one time. It's a lot
easier.
Now,
do you save this with the part though? Or you don't save this with the part? Why?
This is the traces. So the part itself is separate from the traces that you make, the connections. So these are connection points. Okay. So this is going to go to IRQ.
Yeah. So imagine you have 20 parts on the board. This is how you would easily be able to reuse the same labels for all the parts that need to be.
Well, it is instead of having to crisscross things. So like if you wanted to have, this go to here, and that's really where it went. That makes sense to do something like that. But when you've got all these things that have to go over top of each other, it's a mess. And what you could do is flip this part like around like this, and then tie these together here like this, and then do local labels or global labels on each side. You could do it that way as well. So you can see this is a ground A and ground A. I flipped the part with X, the letter X on the keyboard. It's basically
which letter was that? Sorry.
X.
Oh, X.
X yeah, and you can do it you can do everything through the pull down menus too. I'm actually probably not good at trying to get rid of my stuff, but you can see plays, all the different functions you can do in here for inspecting and editing and stuff. It's all the same kind of keyboard shortcuts as well, and you can program your own keyboard shortcuts. So, but if you wanted to minimize the amount of work you do, you literally could do this, and I simply tie all these together, and then only do labels on the outsides. For that. But I like to try to keep everything fluid as far as both connectors look the same. I don't have things backwards looking. So for me, this is, even if it's a little more work, I think it's a better way to go.
Yeah, right. Because for instance, the ground one you would reuse now on the reset pin eventually.
Exactly. So for example, I'll take this ground and I'm going to make this the ground. I move this over so it's a little more centered. I'm like Kris Sekula. I got OCD when it comes to all this stuff. Yeah. And then so that's a ground wire, and then we know that this is the reset.
Go to the reset line.
So let me flip this around here for the fun.
That was X again to flip that around.
Yeah. It's actually no. In this case here, I rotated this, so I hit R to rotate.
Oh yeah, got it.
Yeah.
Oh, it's interesting. It does it properly with the text and all. That's great.
Yeah, it does. And so this is the wrong thing, obviously. So I'm going to say this is a reset. It's actually technically it's a reset.
Yeah.
It doesn't really matter how you label it, as long as your label is consistent, because otherwise it's not going to see it as the same ones. So for example, I went into here because this other side is reset, and I tied this together, and I made this actually reset. When I do the board output, it's not going to know.
No, it's 2 different things. Yeah, you might as well have written an entirely different word there. It's just
exactly. Yeah. And so for these, usually I don't use ground. I usually use a symbol for ground. And so in the place menu, you can add what's called power. Okay. And so under power, you've got power and then all kinds of different grounds you can do and negative. So for this particular case for boards, I use GND, and I would put it down here somewhere, which is pretty common. I would not do this or this. I would do this. And I'll move these over. And
How do you move to left and right without moving it like out of sync?
Again, Kicad is really great about keeping everything consistent between all the commands. If you highlight this, so they're all highlighted, and you hit G, is grab. And you can also do that from the pull-down menu to grab it. But grab will actually highlight everything. And at this point, you can move all this around, and the traces will follow it, which is kind of nice. So I like trying to move things up to they match up to the grid. So this is how I would do ground normally, is like this. This is the ground symbol is very common. So I won't do a local label for ground unless you absolutely need it. So one thing about any kind of circuit board design software is that I could do this as well. I could actually connect the local label to another ground pin. So now these are both ground.
Okay.
So they're connected to the same circuit at that point. But I will always do this. Get rid of, oh, that's the wrong one. Don't put it on the reset. That'll short things out for sure. Okay. And then so for connecting traces, you literally, Kicad's smart enough to know you're on the little box up here.
Yeah.
And you simply click the mouse and it automatically grabs it, and you can move this anywhere you want. And when you click this again, it connects it. It's pretty simple. So it goes. So if we want to take a quick peek at our board, we can do the update to our board. And now we can see that we've got even more rat's nest. We can see where the reset line is and where the ground line is. We know that ground was over here. And you can see it's kind of funny is that this is ground to here to here. It's no longer a straight trace like we had it, because this is the shortest path to ground it gives you. Okay. And one of the options in Kicad, depending on your video card, it'll give you rounded style rat's nest, or it'll give you straight. Actually, where is that one at? There, or straights, if you don't have a good graphics card. So that's a straight. This is really handy because it actually moves things away from your straight lines. And so it makes it easier to see when you're doing your trace layout.
Makes sense.
So we're kind of out of time for this thing right now, I think. Are we? What time is it?
Yeah, we are. We've got lunch. We've got lunch coming up. I think. I think it would be nice. Sorry.
Is it? What is the time? 12. Oh no, we only have.
Oh no, we got to 12:30. Gosh,
yeah,
I keep on. Yeah. So we got half an hour left.
So good. So we can continue on then. All right. So basically, we'll just like this becomes read write.
So Jim, I obviously I'm a lazy person. There is no way with doing a copy paste of what we see in the green on the right, because you're retyping this.
Not that I'm aware of. So if somebody knows it, chime in, because that would be handy for sure.
Yeah.
I do dot clock. And so this really doesn't matter so much for our particular case, because we are not using the signals really for this project. All we're doing is basically doing a pass through.
No, but if you do this now for one board, it kind of becomes your master board.
Well, here's where the cut and paste comes in, Yuri. Is that Kicad allows you to open up multiple instances of it. And if you already had this done in this board and you want to do another one, you could literally take either the signals and copy and paste them into your other board, or the entire thing, or just part of it.
Awesome. That's awesome. So you can just run multiple layouts at the same time.
Yep, you just run, like oftentimes I've got 2 or 3 Kicads open at the same time with different circuit boards, and I'm copying parts of the schematic out of it.
Yeah, that have large overlaps. Let's say you have a USB circuitry or something, and you just
I do it all the time. Power supply circuits, I do quite a bit as well. Anything I've reused, so you create it once and you can reuse it over and over again, which is super handy.
Makes a lot of sense.
Like here's a good example here. I cheat because I know that IO1 is IO2. So that's one less character I have to actually type when I do this. I'm so bad about trying not to type all the time. In fact, I didn't actually do this project ahead of time like I thought I was going to, so I could just magically load this in and it'd be done. So bear with me here while we actually.
That's okay. It's okay, because I think it's good for people to also see that this is the piece that you have to do manually.
Yep.
You know,
This
because
is
I
the
bet
not
you
fun
there's a lot
part.
of people that have been doing this manually have been wondering, I probably do this wrong all the time, and now get to say, oh no, this is actually, it's been the right way. This is just a step part of it. So
Yeah, like I said, once you've done this in one board, it's a great ability to be able to use that same data again
right.
on another board. It's like I'm copying the trace as well. The connection point's not really a trace yet. The connection point, I copy it as well, so that I don't even have to redraw that. So that's one less thing I have to actually do. And I'm just simply copying what's over here because for a reference for the signals. And so, oops. So D1. Okay, so is any questions about anything really? I think the biggest thing in designing a circuit board is really designing, I'm gonna connect this ground wire directly here, is designing the whole concept of what it is you want to do. Like, and what's it want to look like when you're done? That's really what you want to think about ahead of time.
Right,
You can
right.
change
Kind of
things on the
think
fly.
from back to front.
Yeah. So now here I'm going to cheat. I'm actually going to delete this.
And now you should be able. Hey, a question that came in: the slash sign, does that mean normally high?
No, that means normally low.
Normally
Active
low.
low. That's what it is. Normally high, active low. Yeah.
Sorry.
So, and I wouldn't actually use this either. I would use the power. So let me go and do that as well.
Hey, Jim, so did you say normally low, normally high?
It's normally high, active, low. So it's going to be high until you drive it low, and that's what causes it to be active at that point. It's going to like yours. For an actually, like the reset line is a good example. That's an active low reset. So it's always high until you deliberately drive it low.
Yeah, pull it low, pull it low to ground.
Yep.
Yeah.
So I'm going to pick 5 volt like this, and then
Great question, my man. That was, by the way.
This, and I'm going to connect here, and I'm going to connect here. So now the 2 5 volts that are connected here are through a 5 volt line like this. So I'm going to take this and I'm going to overlap this connector so it makes sure it includes the entire piece here. And so not the connector, but the pen itself. Let's see there. So now I hit Control C, Control V, and now I'm going to line this thing up, and voila. I don't have to do any more on that side. Now clearly there's going to be a problem with space here, I think. Actually, it'll be pretty close.
It looks pretty close.
It'd be close. Good. I'm going to move this to here, so it's a little further out of the way. So, and now this is another ground, and actually I have to move it over. Okay, so this is one thing nice. You just grab it and grab all of it, actually. And then you hit M for move. And I think you can also do it through the pull down menu, but I always do the M. And I think you can actually just drag it and it goes too. But so I'm going to move this over to here so that it is pretty close. Okay, that gives me more space over here. And because I have to drag this to here because I'm going to do another ground wire that's going to be here. Now you can do things like this. So it's connected to the same ground, or you can put another ground symbol here. Either way. It depends on how you like to design something, and everyone's different. I typically put 2 grounds, but I'm gonna leave it connected here just for the fun of it. So I'm copying this and this because I'm cheating because I don't like to type wrong. And now I can just type the letter H instead. And reset's done, ground's done. And I'm going to do NMI is next. NMI. And we all know what phi is. That's the clock for the 6502. Phi 2. And then now we have all the address lines. So 815. Actually, I can copy this. It's less to deal with. 814. 813. Oops. By the way, if you go over too far, notice this little dot. It actually connects to it, and it actually is correct trace. It just doesn't look good to me. So I like to make sure that you have a little point perfectly on it.
Yeah.
So for connection. And then don't be afraid to zoom in and out, because you can get really good zoom on things if you want to with Kicad. It uses the scroll wheel on your mouse for zoom. So you don't have to be out so far. Oops. Okay, 10. And to answer anybody who might be asking us questions, no, I do not have a cartridge port like this done. Otherwise, I would have copied and stole it from this. But now I will.
Exactly.
If I ever want to do another cartridge type of thing like this. The one I have for the IC64 actually is based on the original, actually, it's a long one, original schematic. So it's done in old long form, identical to the schematic. So it wouldn't be very helpful for this because it's kind of a mess, really. So this is a much better way of doing it for a new project anyway.
I think Matt has got a good suggestion. He says, why don't you copy paste all 5 address lines at once?
Well, I could have.
Because the spacing is similar, right?
Yeah, it's the exact same space between all of them. Yeah, I could do that. So, I mean, that's probably good now. That the reason why I didn't do it to start with is because I knew I was going to switch to a two character to a 1 character.
Okay.
But what I could do now is I could do this. Actually, I can highlight all these with it. Oh, I don't want to do that one. There. And then copy paste. And so, yeah, that actually makes things even quicker.
Yeah.
Good suggestion.
Yeah, that's great. That when the audience starts thinking with us, life becomes so much easier.
Yeah, I would have probably done it quite a bit different in my real life, because I do a lot of keyboard shortcuts for everything. So I'm going to connect the ground.
Yeah, and that's a good point as well. You've created some macros and all of that you're not using here. Just not to confuse everybody with functions that they wouldn't have in the install.
All the alignment stuff and all that horizontal distribution, vertical distribution, all the stuff I have programmed as macros. And we're going to do a distribution here in a minute. I'll show you about that. So I'm just going to copy, I paste into here. And so this literally is the entire design, except that we're missing the ground over here too. So we're going to copy this. And where can we connect this? Oh, wait a minute. The heck with it. I'm just going to copy. I'm going to copy the symbol, and I'll just recreate this real quick. Okay, so that's the entire design for the board. That's everything. That's a switch. That's basically a pass-through. So this is the connector side, the 90-degree elbow, basically. And this is the finger side, and we're just simply going to pass those straight through. So now we go to the board update, we're going to see an incredible rat's nest now, but that's the entire thing. It's all done. So what we need to do now is create the traces, and we do that manually using the function for creating a trace. And so over here on the left-hand side, you're going to find all kinds of things here for different visuals and such. And you can experiment with these of what you want to see, like just the rat's nest, the straight rat's nest. This is kind of easier to see, actually, in this case, of what we're going to be doing. We're going to be making straight traces through here. Right. And we're going to be doing a little bit of a crooked piece to here. This is kind of funny. That's like the first time I've ever seen that being handy for visually. You can turn the rat's nest off if you don't want to look at it, but we're going to look at it just for this case here. Oops. They use X, which is kind of strange for the trace. And so what we can do is we know that this is connected to here, and that makes the connection for the board. This is not ideal for a ground. What we really want to do is we want to fill the entire area with a ground plane on top and bottom, and then connect the grounds to that. And any power lines, we want to make sure they're fatter than normal, because that's important to have proper power. So for grounds, I won't do that, but we're going to go ahead and do like, we're going to connect this one.
So you're going to leave that to the last, or is what you're saying then?
Yeah.
Okay.
So we're going to connect. First of all, let's just do one side of the board. We're going to turn off the bottom side. We're going to turn off I'm going to turn off all this, turn off these. Okay, and I'll turn off this even. Okay, so now this is the top side of the board. So now we can really see that when you highlight this X, that's going to show you where it's got to go to. And then you can move this however you want to move it. So we have to decide in our design again, is it better to have this go between these traces here or around these traces? What's the deal? So in this particular case, we've got an interesting dilemma because both of these are connected together because they're both +5, but our ROM line here needs to go around this and connect to our top side finger. Okay. So if I connect it to, oh, actually it's the bottom finger, I'm sorry. Why is it showing that? Oh, ROM high and ROM high. Oh, that's because I was looking at the wrong one. Okay, we're gonna do the bottom one first, I guess. Bottom. So bottom is green, and then we're going to connect to, yeah, Kicad doesn't scroll real well sometimes, so you kind of have to fudge it.
Yeah, it loses it. Is there a way to reset?
So now it's connected to here, but obviously this is not very ideal.
Yeah.
Because it's stuck between a finger.
Right.
So if you simply collect it, you click on one of the links and hit D for drag, it'll actually move this up. And you usually want to have this centered if you can.
Yeah.
So I do that and I zoom out and then I drag, I'll click on it again and I'll drag this up and I'll have to figure out, do I want it here? And like we were saying before, this has got 5 volt between here.
Yeah.
Grounds on this side. I think from a design standpoint, it'd be much better to have this on this side.
Okay.
And so this is one of those cases where I was saying before that.
Yeah, it doesn't go right to the middle, indeed. It allows you.
So we want to go to
the
middle, and you notice that the grid is something where you really can't get to the middle. So you can either change your grid, which you can do up in here, to be like smaller, like one mil, and you can probably get pretty close to it. There's a really easy way of doing this if you really need to make sure this is accurate. In this case, it's not a big deal. You can get pretty close. But for some of the stuff you do later on in life, like high-speed stuff, the easiest thing to do is click this, and you click this, and then you invoke the pop-up menu with the right mouse button, and then you go into align, and where I see lines are here, and then you can say distribute horizontally. And what that's going to do is going to take those 3 items and they're going to make them perfectly equal. And because I selected the trace to be the reference, the last one to be referenced between these 2, that's what's going to move. Neither 2 are going to stay stationary.
Got it. So you got to be careful with how you select. Select the last item is the one that will move.
Right, exactly. So then I'm going to say distribute horizontally, and now it snaps dead center. It's perfect.
Yep. Yeah.
The only downside to this is that now when you go look up at your little thing up here, you can see this little jag.
Yeah.
And so there's a couple ways to fix that. Either you can do a G to try to connect it together like that, so it snaps, but your angle now is not 45 straight perfect. So you can hit D and then redo your angle if you want. Okay. So either that, or you can do a drag as well. But if you do a drag, you can see what happens here is that it doesn't still connect. So the G will connect to it, and then your drag will straighten out your angle.
Yeah.
And then, so you need to decide where do you want this to occur? Yeah. Somewhere down here or whatever. Because at some point, we're going to be making a big trace here for the 5 volt line. We want this to be a big fat trace. These grounds on the outside are going to be part of the ground plane that we're going to do, which will be a filled plane. So those are going to be connected together really solidly. And so it's one of those things in your design. I mean, do you want to do actually? Okay, there's a good example of what you want to do first. So I just grabbed this and moved it by accident. Yeah, which is not a good thing to do. So in Kicad, if you select it and hit E for edit, like everything, and we go back to the general settings, you can actually lock this if you want to.
Okay.
I can say locked,
and then the physical parts will no longer move.
Yeah, it's not going to move anymore at that point. Yeah, so
that makes sense.
Yeah, so I do that a lot because I end up grabbing something, whipping around on the screen, and something's moved all of a sudden. So good news too is that if you were to do this, if you just simply hit Control Z and you can do multiple undo layers. I don't know how many layers it's got, but it's got a ton. So we can go back and look at like all these changes I made here.
Yeah.
You can do Control Y to go
And it
put
redoes them
in.
again. Yeah, between Z and Y, it will redo it. Undo or redo.
Oh, nice. Oh, there we go. It's like, wow, Kicad froze for a second.
Yeah.
So I recommend, because this still is kind of like in, beta, but not really. Periodically save your board. So we'll just go save our design, and it'll actually show you a little asterisk in your file. Actually shows on the screen too. So in your upper left-hand corner in the file name, it'll show an asterisk, which is typical, saying it's not been saved yet. So we're going to go and save that as well. So now those are saved designs. So literally we just walk through here and we attach trace after trace after trace after trace, and then we make sure we can connect the ground plane to here for these two, and then the reset line. We have to figure out a sneaky way of actually getting the trace in between other traces, and then using a via, which is a pass-through typically, although where is the reset? Okay, so another feature too that's super cool about this, if you hold the control key down and click on any of the pads, it will actually show you that, well, typically it shows you, oh, does Kicad 7 not do that? I'm using 7, I don't use 7 myself. Oh, okay, it used to show you the highlighting of the trace itself. Maybe I got highlighting turned off. Maybe that's what's going on. I guess not. I'm not sure where the highlighting is. Usually it'll actually highlight the trace. It'll dim everything out and then show you this and highlighted. So it makes it easier to see where it's got to go to. So let's, for example, let's do this. Okay, so here's some big no-nos in circuit board design. This is fine as far as this goes. I can achieve, this will work just great because the traces will go on the outside of this as well. But this is a no-no. Never put a 90-degree angle on anything. That's a huge amount of noise being generated. So you simply just can drag this corner like this,
and then round it off.
Yeah, and then again, if you want to do your snap to your grid so that these are aligned, you can do the same thing. If you don't care so much, or if you set up a grid alignment where you know for a fact that this is going to be dead center, and actually this one is, I think. Oh, yeah. So then it's fine. But what I don't ever want to see anybody ever doing is this.
Right.
A lot of people try to put two traces through here. And if you absolutely have to do that, that's obviously you have to do it. But it's such a bad design trait to get into, to putting traces side by side inside a little place like this with a fat trace. That's another thing we didn't do too. We didn't set our trace width.
Yeah. And what is the typical trace width that you would be using here? Well,
typically, I try to make it as big as humanly possible that will fit without any kind of an interference issue. Okay. Because I have learned in the past developing active components. So I developed the majority of all the electronics for the paintball industry. So all the paintball guns had my boards, I developed them. Yeah. I developed one board that sat on top of an aluminum tray, and it had a couple of aluminum standoffs in it. And I had a trace running under it. And the vibration of the gun eventually wore through the trace. And I only used a 6 mil trace. So it's a very, very thin trace. I didn't need to do that. I probably should have made it 10 because 10 would fit just fine. I just happened to make it 6. And it was, when I made it 10, they never wore out. I made it 6, they always wore out.
Right.
So basically you can select your trace width wise.
Which in this case you would do in any case for the power
for sure. Yeah, for our power lines here, for example, I can connect it to here. If you could say this, you click on it, you can actually go up to here in the pull down menu, and you can set your track width if you want to be whatever you're designing it, or you can hit W or Shift W. And that changes your width. And I do this a lot because you never know what your width needs to be until you're actually looking at how wide you want this power plane to be. And so that's a nice size. And then so I can do another one. So I've got the set for right now in the menu up here, 30. So now when I start a trace, new trace is going to be that width. And so, of course, this is outside of the board. Yeah, it's the wrong side of the board, of course. So what you can do if you're on the wrong side of the board, you can actually hit E for edit, and then you can change the layer. And now it's the top side of the board.
Okay.
Super handy if you're the wrong side like that. And then, so we're going to be doing this to the top side. Again, this is a little bit irritating with Kicad. It can be the mouse setting and all that stuff. So we want to set this to here like this, and then we can either do this type of thing, or we can do this, or we can do two traces down the center like this, or we could make a third trace down the middle, which would make this like super duper fat.
Yeah.
Like that. So I mean, you can actually look at cartridges, you're going to find the cartridge actually extends probably between the fingers. Some of them have like this for 64, where it's all the way in.
Yeah, you see that.
And some of them
on JAMA
stop right
connectors
up here.
that often as well. Yeah.
Yeah, it depends on the developer how they wanted to do that. So that's how we do the basically the power plane.
So Jim, but I can't help but wonder, looking at this and you going through these. So there's no auto trace here. It is all.
No, there's no auto routing available in this. So heaven help us when auto routing becomes available, really, because I've seen the auto routers up to date and they're still horrible.
Okay.
As far as design stuff, I know I have to say, like, the high-end software where it's $100,000 for your software, like Cadence or like the upper end packages, their auto router is really good, obviously, but the stuff like for Kicad, where you can actually do an external auto route and then bring in the net list and then create the board and bring it back, and that it works, but it gives you non-optimal things. And there's a lot of things in auto routing software you can set for your minimum trace width, your minimum distance, separation distance, how close you want to be to a power plane. There's a lot of rules you can set up. And the rules are really important because it's kind of a really huge thing in doing the board design, which I'll show you here in a second. But there's no convenient auto routing available. So you have to do all this by hand. And this board's really simple because basically you're just going snap to snap,
right.
to snap. And doing this little reset thing we did. This reset would have been even simpler on the other side of the board.
Right.
We're not going through traces and working around traces.
Because then we could have just gone straight.
But fortunately, we know for a fact that we can do. We'll go back to a 10 mil trace here. We know on this side that this is going to connect to here, and we know this side is we're going to have to go around this, and we wouldn't have to do that if the switch is on the other side. But we've got tons of space in here, really, so we don't have to worry about. Tell you what, my mouse thing drives me nuts sometimes. We don't have to worry about this so much in this particular design. I'm just going to drag this up.
Yeah.
And I like having things close to what you're wrapping around, so it makes it easier to figure out what you might need to do later. So if I want to move this over, I'll select this trace, move it over. So this wasn't too bad of a problem here. And I also don't like having 90 or 45 degrees at the pad. I like to leave space between here and here, really.
Yeah.
So literally we're going to snap the next one. Actually, I didn't block that. Snap it as well and do it over and over and over again. So once you get the board assembled like this, where it's all traces are connected together, then we do what's called a DRC, which is a design rule check. And in Kicad, you can do this little gadget here, and you can say run the DRC, and it's going to tell you every error you've got, like the fact that the silk screen is clipped by the board edge. So in this particular case, it isn't like the fact that this silk screen is hanging over the edge of the board. And it's a warning. It's a warning, not a failure. And then you can turn these warnings on and off in the setup. And so it's pretty handy to have things like this, because what if I didn't realize that the connector is going to stick way out to here and I made the board accidentally that way? So the design rule check is something that's going to really help you as a developer, make sure you don't do things like this by accident. We're doing it on purpose in this case. So I can actually ignore that one. I can go into the setup for the board and just turn that off so I don't see the warning if I don't want to. But in Kicad, it's kind of cool because if you click on any of these, it actually goes to the location of the error.
Of the error, and then you can kind of
So it shows you like your warning, you don't have
you can fix it and then run the DRC again.
Exactly. Then you run it again, and then voila, then it, you got one less error or one less warning or whatever.
Yeah.
So so the DRC is like really important that we do because it verifies the board works. Because if your schematic is correct, if this part is correct, you are guaranteed, well, hopefully, as long as it generates the Gerber data correctly, you're guaranteed that your board's going to be exactly what your schematic was.
Right.
So typically when I find a problem, it's always something I did in here, not really in the board.
Yeah,
because
I get what you're saying. Yeah, you're going to have to go back to the schematic rather than the board.
So then if you're like, oh, this is connected to the wrong pin.
Yeah.
Then or I've got two things connected to the pin when it shouldn't be that the design rule check showed. I go back to the schematic and go, oh, okay, yeah, that's for sure, that's wrong. And I correct it, and I go back here and I run the DRC again. And then actually, before you do that, you're going to run the update because you're going to move the updates back into the board that you just did.
Yeah.
So I'm going to update the board, and then I'll do the DRC, and then it'll say, hey, it's great, it's done, or whatever. So we can take a look at the graphics view, and we can actually see now we've got traces.
Yeah, we can see the traces. That's
that we did on here. And you can see things that are really important for us when we're doing a case design, like how long these pins stick out.
Right.
Because a clearance issue. And so you may say, okay, for the case I'm designing, I don't have the luxury of having pins this long. Maybe I need to make the case super thin. So it's going to require somebody in the production department to cut all these pins off.
Cut them all short. Yeah.
And then cut these pins off. And I actually do that. Almost all the boards I do, I try to make them as small as humanly possible to wrap around because of several reasons. One, I think it looks better. And the most important really is expense. So the more plastic you've got to accommodate a bigger case, the more cost for production. So when you're building 100,000 pieces of something, and you can save 10 cents or 15 cents a board or design, it ends up adding a lot of money in the end. So this is basically how you do it. I will finish this and I'll make it available.
So Jim, I think indeed because it's 12:30 here.
Yeah, it's 12:30 now. I'll finish it up.
Yeah, and then tomorrow we'll pick up some of the points that may have not been able to be. If there's a VR, for instance, then we'll probably need to demonstrate that. Or if there's something we had to change or move, we can do that, and we can pick that up.
Little holes in here for standoffs or whatever we're going to do to mount this into the case as well. Yeah. So it'll be interactive between SolidWorks and Kicad.
Yeah, fantastic. Yeah, it is an exciting little project. I appreciate also the feedback on the Discord as well, and keep those questions coming because we'll just enter them in the next talk. So Jim, we got.
Before we go, the auctions yesterday, all the buy it nows were done. And so I redid the auctions today. They started 2 minutes ago, and it'll be a one-day auction. The buy it now is there, but it's a really high price. So I doubt it's going to happen. And so now you can go and bid on those, and then tomorrow they will end. And that's how we're going to do the auction. I have the exact same Uri colors, the neon green, yellow, and pink. And then I actually have today translucent red and translucent blue for the colors. So if you're interested in getting the keycaps and you want to go bid at the auction, go take a look at our Discord. I'm going to put links up here shortly to each one of them, and you guys can go check out those.
Love it. That's great. Okay, Jim, we're going to be back in half an hour with David Yout on some artificial intelligence.
Yes, we will. We'll see you in a half hour. We're going to go to some Slay Radio. See you guys.
This is the sound.
I'm Sean Connery, and when I'm on the internet, I listen to Slay Radio. Christ almighty.
And we're back. Do I got you there, David?
Sound test.
Sound test. All right.
Excellent. Hopefully my video is not lagging with the sound like was happening before, but if it is, what can you do?
That's fine.
Okay, good. So, I have a book to announce before I do my video on Python versus a Commodore AI. And it looks like this. I dropped this yesterday at CRX. I've gotten a ton of feedback because I sort of blasted it across the internet as well already from people. It occurred to me like roughly, like literally just 5 minutes ago, I have no idea how to pronounce this title to somebody. So, it's 6502 Ponderables and Befuddlements. I can pronounce that, but what do I say?
Sure.
They're like, oh, you read exclusive or immediate mode, hex FF. Or I could say like Eeyore, like the depressed donkey from Winnie the Pooh or something, but I'm not quite sure how to say this. But there it is. That's a new book.
Back in the day, I called it Eeyore.
Eeyore? Okay.
Yeah.
I always called it EOR, but yeah, it's interesting. It's a lot of the instructions from a while ago, they would emphasize the E instead of the X on exclusive.
Yeah.
And just like a lot of the stack operations would do pull instead of pop like they do today. But
yeah,
sorry, we don't have much time and I shouldn't get on tangents. What is this book? So this is inspired by this book right here, this Exchange REX. This is a wonderful book. It's just 64 different examples of x86 assembly language with absolutely no explanation whatsoever. So this is popular with my coworkers. There's no forward, there's no preface, there's no instructions. It's just figure out why each of these things is significant. So I decided the 6502 community needed something like that as well. So I made this, except I thought it would increase the fun if there was explanations in the back as to what all these things did. So I'll give you one concrete example here. This is like problem number 9. I don't know if I give. Is that going to focus?
Yeah. Switch to the speaker view here. Here we go. Now you're zoomed
okay.
in.
So there's an example of, I can't see the screen, but I trust it's there. A bit instruction on an address, and at that address is an RTS.
Yep.
So that's an example of why would you want to do that? So the 6502 has an instruction for clearing the overflow flag, but it has no instruction for setting the overflow flag. So that is a way you could do that. And the question is, why does that set the overflow flag as well? But there's big explanations in the back. This one actually goes for about 2 pages on why that works and all that kind of stuff. So that's what it is. Yeah, I've gotten a really good response, and the book is free. I've made it freely available. So as a PDF, as an ebook. Paperbacks, of course, I'm trying to sell as close to cost as possible because this is not a money-making endeavor. Lulu might actually force me to make a couple of bucks on some of these, and I'm going to be giving it all to a Redwood Preservation League. This is just something for fun. It's not a business thing. So I want people to be able to get it as cheaply as possible. It should appear on the Amazons in a couple of weeks. I would have expected already, but it can apparently take some time for that to show up. So if people wait to buy a paperback copy, if they're going to get a paperback copy, it might be cheaper shipping, as Amazon is all over the world. So yeah, we can share the screen. I didn't have many visuals prepared. I just wanted to give a quick heads up about the book. I was messaging Robin this morning and I was like, holy crap, people are actually buying this thing. Which I was really surprised by. I looked at the Lulu metrics. I was, in theory, that's how a book is supposed to work, but I was just sort of focused on getting it out there. And I was like, wow, people are actually purchasing this. So remember, please, there is a free version. I only put out links to the free version. You have to actually go looking for the paperback version if you want that, but it's fun in paperback.
Yeah, it's great. I have one myself, so it was a neat little read. Yeah, I mean, it's neat for people that from that era really did a lot of programming in that, because you get a kick out of some of the stuff that you read and it's like, oh yeah, I knew this and that's cool, and little walk down memory lane for some of us. So that was neat.
Yeah, I put together over the evenings of about, I don't know, maybe 3 months. When the wife's watching television, I can't just watch television. I'm ADHD. I got to be clicking on something, doing something.
Yeah.
So, I mean, I had the idea a while ago, but it was just sort of focused evenings when it all came together. But after I did it, I went back and started looking at some of my old programs, and I was like, oh my gosh, I shouldn't have done this. I should have done this instead.
Yeah, it's amazing how much you think you could optimize later on. It's like, wow, why did they do that?
Oh yeah, I thought I had really optimized code that wasn't optimized at all.
Yeah.
So I'm going to say some quick thank yous on this. I have an acknowledgement section. So Peter Ferry is absolutely amazing. Apple II genius. He works in the antivirus community, and he really helped out with the examples, especially a lot of the Apple II stuff. Michael Style, I gave him this. I met up with him at VCF West, not Midwest, but West, and showed this to him. And he's like, "Sure, I'll take a stab at that." So I gave him a copy, and he took it on a 10-hour flight and worked through almost every single example in 10 hours and gave great feedback. So that was pretty impressive.
Yeah.
And then Nate Lawson as well really came through. He knows his stuff. Another person in the computer security field, did all the Blu-ray protections and things like that. But Nate gave a lot of polish back on the all the text and stuff. So big thank you there as well. Anyway, I had fun making it. I hope you have fun out there reading it. I'm not looking at my channel in case there's any questions rolling in, but leather-bound edition. It smells of rich mahogany. Oh my, people are quick with the scope crawl.
Yeah.
Anyway, recreational 6502 thinking.
Very cool.
Yeah. Other than that, we have a pre-recorded session that's coming up where I had written a Python script to beat the AI of a Commodore 64 game called Piracy that was beating me, and that bothered me. I was going to make a little YouTube video out of it, but I started showing it to Yuri, and Yuri's like, "Well, let's just make this an interview." So we did that, and we have it recorded. So if there's no other questions about the book, we can probably let that roll.
All right, let me cue this thing up since it's in.
And I will turn off my camera here.
Yep, I'll do the same. All right, let's roll.
Hey, David, good evening. It is a Monday evening in beautiful California.
Yes, we are pre-recording for CRX, and I think we got all the Zoom issues worked out because, as you know, Zoom just works.
Oh my goodness, that just works has been quite the adventure. But I'm glad that we are where we are now. So today we've got a treat especial. As part of your popular series of 64 seconds, you found another great gem to go through, and it's the game Pirates. Tell us a little bit about this game.
So the game is Piracy. It's an Australian game from 1985. I had not really played it until recently. And you know how you have totally different ways of having fun with 8-bit than I do? I mean, you repair Commodores and you do things that people find useful. I like to do useless things. And one of the things I like doing is watching old 8-bit game AIs lose to modern computers. So I've done a couple of YouTube videos like this, watching 8-bit chess lose, 8-bit Othello lose, 8-bit Go lose. I did trying to remember the 7-Up spot game. I had that one lose as well. So what I did is I made this video that you see over here, because I was playing Piracy, and its AI is pretty good. It was beating me, and I didn't like that. So I wrote a Python script to beat the Piracy AI, and I have a video of that here, which I'm going to start. But I thought it made a really good concrete example to work from, so that you and I could just talk about what was 8-bit video game AI in general like. How did the ancient ones pull that off?
And before, and I think this is going to be really cool for those people that haven't seen the 64-second video yet, where you kind of explain the game Piracy. Tell us a little bit what the object of the game is before we even start. For those people that haven't,
I will explain the rules. By the way, Yuri watched that, and Yuri here, and got back to me saying that you talk a little bit too fast. So at any point, you could pretend like there's a speed knob and just do this to me. Give me that hand signal, and oh yeah, you have the power here. So okay, this part you can't see my mouse, so I'm just going to use words. So what you see on here is you have two pirate captains, and they each have their own boat. And there are 5 squares that you see on each one of these boats. Those are cannon holds. You got a cannon in there, those little flaps can open, and that gives you access to the cannons. But the cannons do not launch cannonballs, they launch pirates. So behind every one of these cannons is 3 pirates. So they look like little weird green faces behind each one on the left and yellow faces on the right. And I'm going to advance this video a little bit manually here. This is a point in which a green pirate was launched in the top left-hand corner, and you can see now there's a pirate missing behind that cannon hold because one of the 3 pirates is out. And the same thing in the bottom right. And what you do on each turn is you either launch pirates from cannons, and you can launch anywhere from 1 to 5 cannons. We'll launch 1 pirate each. Or you can move the pirates across the rope. So let me zoom forward a little bit to, yeah, this is a later part where in this circumstance, that green pirate on the left is moving towards the opponent. You always move across towards the opponent's boat. So you can go straight across, in which case if that green pirate went straight across, he would kill that purple pirate and take its place. Or he could go diagonally up, in which case he's ran out of net and he screen wraps to the bottom on the other side. Or he could go diagonally down, and you can see there's broken chain there or rope. And when he hits the broken rope, he'll fall into the ocean, you lose the pirate. When you move the pirates, all the pirates on the rope have to move completely together. So if the purple side was moving straight across, it would kill that green pirate. But that one by the broken rope would move into there and it would die. So it would take a pirate, but it would lose a pirate.
Right.
So the only other thing to consider is what happens when you're at the very edge. So if let me see if I can move this forward to where a pirate gets close to the edge. Let's see. Well, just imagine if I'm right at the cabin hold of the other pirate boat and I go into it, I can kill all the pirates that are there. And I do something called blowing that hatch. And then I can wrap back around to my side and come out of my cannon again if my hatch is not blown. And if there's a spot for me left. If there's 3 pirates, there's no spots for me. But if there's fewer than 3 pirates, I can come back. Those are all the rules of the game. I know I said it quickly.
But this is well, it's already a lot more elaborate than it was on the 64-second video. Now, what's the end objective? The end objective of the
end objective is to eliminate all the opponent's pirates. If you do that, you win. The documentation will actually say if you blow all the hatches, but it's not true. If you play a 2-player game and blow all the hatches, the game doesn't end. So you have to actually kill off all the pirates. But the AI is going to look ahead on the Commodore a little bit, and if it sees unavoidable death in its future, its pirate captain will just walk the plank and give up. And we're going to see that in the example here.
Okay. Now, so a little bit about the game then. You said you hadn't played the game when you were young. So this is a new game to you.
Brand new game. That's fun. It's a little gem I hadn't discovered yet.
How did you find out about this game?
I don't remember. All I know is it's made of unobtainium. People have been searching for this for a long time. It comes in this little clamshell thing. It had a very limited distribution in Australia, is my understanding. And I think the next time I see it on eBay, it's going to be very expensive. It doesn't show it very often at all.
So when you got this game, I presume because it's a style.
What is easier to find though is the board game adaptation, which is exactly the same game. So
there was an actual board game adaptation post the digital version of this game.
Yeah, see that?
That is awesome.
Based on the Commodore 1985 game. Yeah, that came out in 2006.
That's very, very cool.
That you can actually find.
Now, so when you got this game, obviously at that moment in time, because it's a style of game that you like, you collect these type of gems.
It's an abstract strategy.
You tried playing this. How did that go? How did you fare playing?
So the AI in this game was beating me badly, and that's why I had to write this Python script. I think now that I've actually gone through the exercise of watching the AI play the game, I have a lot better grasp of it. I don't know, it just didn't feel intuitive. I like it. I respect the game. I was immediately bad at it, which led me to write the Python script.
So I want to zoom in a little bit more on that, because that's obviously interesting. So I suck at playing games. I remember when I was young, the reason for me to start coding was actually to start writing trainers, because I wanted to make sure that I could somehow figure out how to get to the end of the game. In this case, obviously this is a lot more complex to get to. So at what moment in time what steps did you go to before you decided, let me try and write a piece of AI to try and beat this game?
Well, it was hard enough to figure out how to play it. I know the rules are rather simple, but I was frustrated for a long time. You would go into demo mode, and I couldn't even figure out how to get out of demo mode. I put in device, and I was looking at the CI registers. Is like, what keys is it checking for? It's like it's not checking for any keys. So like, there's no way to escape this. Not realizing the restore key is going to trigger the non-maskable interrupt, and that's what it was trapping to go back in. So I was off to a slow start, but. It has 4 skill levels, as you can see on the picture that I have on there. Nobody I was reading online, everybody respects this game and likes this game online. But not a lot of people know about it. Nobody's beaten it on level 4 that I saw. Everybody's like, that's, you can't beat it, which is what kind of gave me the idea for the challenge. And I didn't want to try to integrate the Python with the Commodore itself. If you look on the left-hand side there, you just see the green text. That's Python's view of the world. And so when it tells me to do a move, I take a joystick and I enter it in the Commodore. And when the Commodore moves, I put the move back into the Python. It's just for fun. I didn't put a ton of work into it. It came together pretty quickly. I have it out, by the way, on GitHub. I'll put a link in the CRX forums for anybody who wants to go and improve on the AI, because there's lots of room for improvement. I stopped as soon as it was beating the Commodore. So there's a ton more stuff you can do with it. Supposedly someone is making a cell phone based version of this game late this year. I don't have any more details on that. I just saw those hints dropped on Lemon, I think. That's something I will definitely buy, because this sounds like a fun airplane game for me to do. And then they're going to want to see how they did their AI as well, how it compares to my Python script. And then maybe I'll go back and make the Python script better. There's lots of options to do that, which I'll be talking about.
So let's try at the start. You played the game? Did you beat it at all at any level?
Well, yeah, like at level 1, ultimately.
At level 1.
Beating, yeah, this is embarrassing. I'm not particularly good at it. I'm getting better. But for me, the fun was in making the AI, just like for you, the fun was making the trainers.
Sure,
So
I get that.
It's the game outside
tell us
the game.
a little bit on how do you go about for a game like this, where in 64K someone has written something that is clearly hard to beat by mere humans. How do you go about figuring out a way to kind of cheat that without changing the code?
Okay, so let's dive into what you do when you want to make an 8-bit AI. First, though, I want to look at the board representation I have here, at least on my left, that green text. You can see that the initial board shows a bunch of 3s on the left and a bunch of -3s on the right. This is a common thing to do in very simple representations. You'll make one player positive numbers, and you'll make one player negative numbers. You can do this with chess pieces or things like this. And so the 3s are the 3 pirates that are behind the cannons, both the positive ones, which are green, the negative ones, which are the yellows. The X's are the holes in the ropes, and later on, when one of the cannon holes gets blown, that will be an X as well. So the Python starts with its first move. It said cannon launch 00001, which means that's just a binary number that I made for a nice compact way of saying anywhere from 1 to 5 cannons. So that's starting from the bottom, 00001. So the topmost cannon is what Python wants to launch. And you can see it right there. The pirates in reserve went down to 2. That spot became a 1. And that's the first move it wants me to do. It's currently looking a look ahead of 6 moves ahead, which I'll just explain in a second. And to do that, it had to consider 18,396 positions because of some optimizations it did. Otherwise, it would be a much larger number. And I'll go into how that works. So
118,000, I think I see.
118,000, yeah. So if you want to make an AI for, if you're in the early 80s and you have a turn-based game, you generally use something called a mini-max tree. And there's 3 things you have to build. And this is where you can turn that knob on me if I start to go too fast at any time. Just put your hand up. You have 3 things you have to build. You have to have a static evaluation function, which is just basically looking at the board at an instant without thinking ahead or anything and say how favorable is this to the player you're trying to maximize its value. That's in this case, the Python player. I want the Python player to win, not the Commodore player. Oh, by the way, the Python's going to be on the left, the green characters. So it's just how good it is at a time. And the most simple way to do it is just to assign the pieces values. Like if it's chess, a queen is worth a lot more than a pawn, whatever.
Right.
But then you just add up all those values and you subtract the opponent's values. And that's a very simple static evaluation function. And that's all I did for this game. My static evaluation function is dumb. Normally, you want to look at the board and what a good position on the board is. Like for chess, if you had a piece that is going to move, but it's going to kill a line of attack that you've set up, you don't want to. That takes away from the value of the board. Or being in the center, could be good. Or having your king, having the opponent's king pushed towards a corner, that could be good position as well. So the second thing you need is a move generator. So from any given position, like this starting position you see right there, initial board, you have to be able to say, okay, I want to consider some set of moves. Now, piracy is so constrained that you can consider all the moves. And I think the Commodore does this too. With chess, it's too many moves, and you just have to say, we have some heuristics that show these are the ones we want to look at. But with this game, we can look at all of them, because with 5 cannons, that's up to 31 different kinds of opening moves you could do.
Yeah,
and then as you're moving across the board, you're either going that way, or that way. So that's 3 more moves. So that's not a whole lot. So from every position, you can have 34 more different kinds of moves to consider underneath. And after that, when you have those 2 pieces, the last piece you need is a look-ahead tree, which we're calling a mini-max tree. And this is where it gets a little bit more complicated. From a starting position, I can see all of the moves that I Python, right, can do. And I want to maximize my goodness. I have some score for these I can statically evaluate, right? If this is my tree's only this far. And if I'm looking 1 move ahead, that's called 1 ply, P-L-Y. And so I want to maximize all of that. But for each one of these individual moves, you can build yet another tree under it of what the opponent's responses would be. And that opponent is working against you. The Commodore does not want Python to win. So each one of those, the Commodore you can assume is going to minimize the value on that. And then for each one of those moves, Python gets to play, and Python wants to maximize its value. So you have this min-max, min-max, min-max all the way down this tree. And what that lets you do is at the very bottom of these leaves, you evaluate what the board looks like. And then these evaluations trickle up these branches and they start to join. And you take the minimum value, the maximum value until it gets all the way up to the top. And then you have a good idea of which way you're supposed to go. And this algorithm goes way back. Von Neumann, if you've heard of him, wrote this up in the 1920s on paper, of course. There was no computer to type this on. A guy named Claude Shannon in the 1940s then developed this further, saying here's how you would have computers that would play chess. He came up with the static evaluation functions, like everything I just described. He had no computer to play it on, but all that stuff, played out marvelously once a few more years happened. So the thing you'll probably go ahead and interject at any point if you want to. This tree is getting really wide, though, because it's growing exponentially. If you look at the math over there, when that says look ahead of 6, that should be a much larger number than 118,000 positions considered, game boards considered. So that's way too big for a Commodore 64. What you need is some intelligent pruning on that tree so that you don't have to search all of that space. So this pruning is called alpha-beta pruning. And this was developed in the 1950s. And the intuition for this is pretty simple. If you're looking down the tree and something bad happens for you, and it's unacceptably bad, then there's no point in fully exploring that tree to see how bad is it really, right? You don't care. You just chop it off and you keep moving when you're doing your search. So more formally, not really formally, but if I have a position up here and I have a maximizing level, and let's say I have a 10 here, and this branch has been fully explored. Now I'm starting to explore a new branch. And now I come down to the minimizing level, and there's an 8. Well, this 8 at this minimizing level means nothing's going to bubble up that's any higher than 8. It is going to be 8 or lower. So if you bubble up that 8 is always going to be less than this 10 you're maximizing. So this value is independent of anything you will discover in this tree. So you trim it. And the way this happens is that you are maintaining 2 values. One's called alpha, one's called beta, right? It's the alpha beta pruning. The Alpha is that minimum score you're guaranteed of if you're Python, and the beta is that maximum score you're guaranteed of if you're a Commodore 64, because we're always trying to maximize the Python. That's how it works. And you maintain these things, you triple them down, and you just trim all over the place, and it really makes a difference. All the ancient ones use this technique, and it's not that hard. I made a bug in it. I found the bug. It's annoying to test, but it was probably harder for the 6502 coders to find that. So when it works best is when you are able to see your best scenario right off the bat, because then you have all these comparators and you can prune like mad. So I actually choose intentionally the order of possible moves that I evaluate to try to predispose it to certain kinds of things I wanted to look at first, like horizontal.
Yeah.
If I'm here and the enemy's here and we have one rope column in the middle, if I move, then I get killed. If he moves, then he gets killed. Whoever moves next gets killed. So the answer is to stall by launching someone from a cannon. So you want to be able to stall. I've even seen the computer shoot out a pirate and put it over itself and kill its own pirate in order to stall, because stalling was so important to it.
Right.
So so I favor those things so they come out first. So it looks a little bit smarter, because remember, my static evaluation function is really dumb.
Right.
So it doesn't look at heuristics at all. I think the Commodore, I need to do more testing, but I think the Commodore static evaluation function is better than mine, because when I made the plies kind of similar, it was starting to gain a little bit of a lead. If you look over there, it says board evaluation 0. That means that everybody's even. So when you see small, that became like the number 2, that means it thinks it's 2 points ahead, basically. And I was starting to lose in the middle of the game when I didn't have the ply far enough. So it's really dumb, but I look way into the future using all kinds of extra memory and resources and wasteful programming, because I mean, my laptop is sitting on a throne of Moore's law, right? It's not going to lose.
It's not a comparison that's even funny.
And I mean, I don't have to be efficient. I could copy this board in memory a ton of times. I could just throw resources. It's just a Python script, right? Now
but what is interesting in this, and I think you just gave the answer, but so far you have not looked at the code of the game. So when you speak about these optimizations that they have done in the game that you presume are there, you've actually not looked at that, eh? Unlike
I have not done any reversing on the game, but I've done some experiments. I know when it's at level 4, it is looking for ply. And I'm going to show you this with a video. I should have started the video earlier. I'm starting it now, and some of the gameplay is going to play out here.
So, and a couple of things on this, eh? So you're running the game in Vice, and the reason why you're running it in Vice, not just the video capture, it is horrendously slow, eh?
Yes, at level 4, it can take about a minute for the computer to move. So it will. Oh, I have Discord on. That's why I keep hearing those chimes. Never mind. We'll fix it in post. But yeah, it's on level 4. I don't want to waste that much time. So I have it on 4-speed emulation right here, because that's how much faster my laptop made it. But I do know that it sees 4 moves ahead, because there's going to become a point in this video where you can see right there, I'm increasing the Python look ahead to 7. See how I typed in ply 7 over there? As you continue to play the game, the search space goes down, because there's fewer things it has to consider, because the board is becoming simpler as more pirates are on the board and you don't want to make bad moves and more pirates are getting killed. So the search space goes down and down and down. And as it does, I tell the ply to go up. And then it's
you're about how many? I saw just almost 1 million positions being evaluated just a moment ago, right? Yeah, you're over 1 million right now.
That's because I increased the ply to 7, but pretty soon that number's going to go down. I'm going to increase the ply manually again. Now, the ancient ones did a better job. They would automatically increase the ply when they saw they weren't seeing as many things being considered. And I could have done that in the code, but again, I stopped once I was beating the Commodore. When I keep saying ancient ones, I'm going to show you a concrete example. This is video chess. Did you?
Yeah, is that the Atari 2600? What is that?
Yeah, so this is 6502 code, right? But this is in the late 1970s. And this game is only 4K. And remember, the Atari only has 128 bytes of RAM. So just to address the 64 squares on the chessboard, That's 64 bytes right there. Now they can reuse some of those bytes upper nibbles, for things and stuff. But I mean, everything got reused. And like my Python, this is doing minimax. This is doing alpha beta pruning, but it's way smarter because, like I said, one of the reasons is it automatically increases this ply as it has, as the game goes along. It also cares about board position quite a bit and has a lot of rules for that. But it also does something called quiescence searching. So one of the things that Shannon wrote about in the 40s was that you want to be looking at the board when it's nice and quiet for the most part. If you're like your king is in check, or if you're doing these massive piece exchanges and your ply stops right here, there's this horizon beyond which you cannot see. And something drastic might have happened. So if there's a lot of action on the board, you need to just keep going down and down that tree to figure out how did that resolve that particular little bit of drama. And this game will do that as well. Another thing that's cool that you had to do was you might have more time, so you want to explore more if you have more time, but you might have less time. Hold on. This game has an amazing AI in it. And what you can do when you want to stop the computer from thinking, you just press the fire button, and the computer has to stop where they are and use its best move it's found to that point. So it needs to be looking in not depth first. It needs to be doing a lot of breadth first kind of stuff in this tree for going depth first. So you really had to do some serious thinking, and you couldn't just, this chess game can't just make a bunch of copies of the board. It starts saying, okay, I'm going to make this virtual stack. I'm going to say my piece went here and it captured this piece and it's followed by this piece and this. And it has to wind all of this to get the board back to where it was, because you're still playing a game, right? And you have very limited resources to work in. So huge respect for the people that are able to do that. Again, Python script is just cheating. You just take the concepts and waste
just brute forcing. No optimization took place at all.
Yeah. So let's see where we're at this video. We have look ahead of 8 now. And so... okay, we're doing good on that. One of the
what moment in time can you clearly start seeing like, okay, my look ahead is at a level now where it becomes really hard for level 4 of the C64 game to keep up with me? I'm starting to
we can see that right now. The board evaluation is 2. That means if you look at it right now, it says board evaluation. That means it's up 2 points. And now I'm increasing the look ahead to 9. I give 1 point for each pirate, and I give 1 point for each hold that is not yet blown. Right. And of course, I subtract that when taken away from the opponent. And now the board evaluation is 3. It thinks it's 3 ahead, so it is clearly winning. It has a lead. It's keeping its lead. It can see 9 moves ahead. There's going to come a point in here where that board evaluation is not going to be 3. It's going to be 10,000. All of a sudden, it goes up to that high number. That means I see the win. I know the future, and in 12 moves or fewer, I am absolutely guaranteed to win. The Commodore, of course, can't see that until it is within 4 moves, and I'll show that difference when that comes. Before that, though, there weren't a whole lot of resources unless you were like subscribed to computer journals or went to the library to figure this stuff out in the early 80s, right, or the late 70s. Sure. This is one of the very few books that was out there. This is Computer Gamemanship. This is by Levy. This is 1983, and it doesn't contain code per se, but it talks at a high level of minimax and alpha beta pruning. It has various static evaluation functions for a whole bunch of different games on here, a probabilistic reasoning. There's tons of copies out there. They're cheap. This is like a $5 book. This is not like when Robin describes something and the price goes up. You're going to easily find a copy of this. Not a lot of people know about it, so that's a good one to add to your collection. Let's see, where are we at? Look, board evaluation still 3. So there's a guy named Oscar Toledo Gutierrez who has been making modern advances in all of this kind of constrained AI. And he wrote a 1K 6502 chess program called Atom Chess that I think is pretty impressive, as graphics, sound, a joystick input. I'll put a link to that in the forums. But he's also written the Nano Chess, which is really quite a good chess AI. And this is a complete book, which is just describing line by line how the thing works. Because he's, I have, it's just that block of text right there. That's it. It's JavaScript. And it does everything. It does pawn promotion en passant. It does castling. It's all in so very few characters, but it's impressive. He puts a lot of thought into how these things. So it's nice that somebody is taking these constrained things and moving them ahead. Okay, we're now on to Python Look Ahead 12. This is as far as I drove it, but I could probably drive it farther. Okay, I accidentally launched the wrong pirate, but there's only 2 more pirates left to launch, and so on the very next turn.
Pause there for a second. There, when you said I accidentally launched it, but that was just a typo, eh? Just a fat finger.
Yeah, I entered it wrong. There was 2 pirates left to launch. I launched the wrong one by mistake, and I was like, "Dang, I'm gonna have to start this video all over." But then Python, on its very next turn, asked for the other pirate to be launched, and so then the game board was back in sync again. In which
right.
But
which is so it basically was able to correct for the mistake in the typo pretty quickly.
Well, I have an undo function I put into this in case I made a typo, but I don't have an undo on the Commodore side.
Right. So now on the Commodore side, let's pause for a second on the Commodore side. The way the game was set up, would the game start taking more time to think out its moves, or was it time bound, or what?
It behaves exactly like my Python. When there's a ton of things to consider, it's slow, and when it's getting close to the end, it's fast because there's just it's doing the.
So it will start speeding up then because it sees a reduced number of moves it can possibly make still.
Well, look at this. I'm at 12 ply and I only evaluated 17,000 positions.
Yeah.
With the pruning.
So dramatically dropping now.
Yeah, this is why AIs are deadly in the end game. Like chess end games, you never beat a chess program in the end game. You beat it in the middle. So, but this is where it gets kind of interesting. So watch this. The score, the evaluation is about to hop up here, and I'm going to pause this.
Oh, there you go. Yeah.
So
Goes from
so
7.
the evaluation is now 10,000. Its look ahead is looking 12 moves down the ply. It now sees that it is 1. It is inevitable. It's perhaps not easy to see from the board, but Python knows that it is totally 1. And you're going to see the point at which the Commodore knows it wins when it's only 4 moves ahead. So we'll let that play for a little bit. In college, I wrote a Gomaku program, which is just get 5 in a row. And all I did was a static evaluation function on that. I didn't have any look ahead at all, and the thing would still beat me occasionally because if you just want to get 5 stones in a row, for every stone, I would just exert influence out in horizontal, vertical, and diagonal directions, like 1 point. And so when you had a bunch of stones on there, that would aggregate up. And so it was catching me in 2- and 3-way traps with no smarts whatsoever. It's just the one board evaluation function that did everything. I'm now turning off the warp mode because I know I'm in the end game. I want to watch him walk the plank. I don't want him to walk in fast motion. I want to celebrate. That's why I took it out of warp mode. And okay, so pretty soon, let's see. I think this is the spot where he knows he's dead. Oh no, yeah. After I plow through some of these,
you're maxed out at the 10,000 for the board evaluation.
Oh yeah, you can't go any higher. Okay, I'm going to pause here. So it says C64 now sees that it loses in 4 moves and walks a plank. That purple pirate, if that purple pirate went diagonally up, then green would launch a cannon pirate onto it and kill it. Right. If that purple pirate went diagonally down, green would launch a pirate from the cannon and kill it. These are the pirates that wrapped around when they win. I talked about before.
Right.
If the pirate goes straight, because it has to do some move, then green will waste a move and stall by taking that top left-hand pirate and moving it forward. And then he's forced to go into the hatch and blow it, at which point this green pirate will go in and kill it. That's exactly 4 moves away. It's a 4-ply game, and it sees it, and it now knows that it has lost. If it was played on an easier skill level, it wouldn't know at this time that it had lost.
Right.
And so the Commodore sees this, he walks the plank, and that's the end of the game. So that's how I know what how the ply lines up with the difficulty level.
Right.
So anyway.
This is awesome. Now having looked at this, I think you said you hadn't spoken to anybody yet that had won this at level 4. Some people even were able to master it at level 3 or do their own thing. Indeed.
Yeah, I read a couple of people saying they could beat it at level 3. Yeah.
Pretty impressive.
This is there's few data points to draw from. These are just posts I see online from people that are better than me at playing it. Yeah.
Sure. So how does this compare? Because you've done a couple of these games now, and the approach that you take on this is you can repeat. Like you said, chess would be another great candidate to try this on an 8-bit too. How does this one compare? Kind of like without having looked much at the code, what can you kind of tell about the game and the implementation of Minimax?
I think Minimax generalizes marvelously. This old approach is great for classic games where there's not very many states on the board. Where it's poor is when the number of states is huge. So, for instance, there's the game Go. Doesn't really work well with just a pure Minimax. It's absolutely terrible because there's just far too many moves to consider. Right. And it's hard to make a heuristic function and know what to do. Go, of course, in recent years has become dominated by conventional machine learning, the neural net stuff. AlphaGo, beat Lee Sedol 4 out of 5 games. And the fact that he won one at all was absolutely amazing. I lost a bet at work on that when that was happening. The modern ones, no, they will, and I haven't done any of this programming at all, so I'm just talking from stuff I've read. They use I don't know if you've heard of Monte Carlo kinds of stuff that's used to discover distributions and stuff. It came out of the physics world, but you can do a Monte Carlo search tree. So you start your trees of these branches, but once you get to the bottom, you don't use a static evaluation function anymore. You let the game play at random until you see what person won, which side won. And then you do this in a bunch of different ways, way down in these leaves, and then you bubble up those wins and loses to see what the win mass is. And the cool thing about this approach is usually used in combination with other approaches, is that you now don't have to write a static evaluation function at all, which means you don't have to know how to play the game well. All you need to know how to do is make a Minimax tree and then play it random. So it's great when you have you're not going to be the big kid on the block if you don't know how to play the game well, but it's very parallelizable. I said 6 syllables, it's 5 syllables, because you can be exploring all these random games at the same time. Like I said, I've never tried it, but that's pretty cool. We use Monte Carlo stuff at work, of course, all the time, but I doubt we use it for that. Tangent, though, for my work, we had a bunch of Cray supercomputers there all the way up into the late 90s. They're now in the Computer History Museum.
In Mountain View,
They went to a Berkeley National Lab, and then they had a little bit of a route to get there. But we had a mathematician there named Harry Nelson, and he wrote some really tight assembly code on the Crays, and won the computer chess competition, the World Computer Chess Competition, for a couple times in the 80s. And about a decade ago, he invited me to a couple of puzzle parties. These are private party meetups. Donald Knuth was there, who, by the way, also helped with Minimax trees in the 70s. And I went to his house, and there was this, I think I've told you the story before, there was a fast load cartridge on the wall from Epix in a frame. I was like, why is there a fast load cartridge on your wall? And it turns out his son, Scott Nelson, had created all of that, and Scott happened to be there that day, and he gave me a detailed explanation of how it all worked, which I don't remember. I'd probably understand more about that today. So I got the news at the wrong time. I'm more into Commodore now, but that was pretty cool.
That's pretty awesome.
Yeah.
So the game here, the game at 4 levels, how does it compare? Just you've done a couple. How does it compare? How intelligent is it compared to, for instance, the chess game that you had previously?
This is a very simple game compared to chess. What makes this kind of hard is that all the pieces move in lockstep. So that's kind of hard for me to reason about, but that's really easy for a computer to reason about. It's like certain kinds of Rubik's Cube kinds of puzzles, those permutation puzzles. There's a number of them, like some, the 2x2x2 or the tetrahedral one, things like this, that are never more, people have proven, they're never more than 11 moves away from solution. But no human can take that approach, really, or few humans can. Few humans see that it's 11 moves away, because they need to hold certain things in place as they adjust other things and do stuff like that. But that Cayley graph, right, that diameter is really narrow, and that's the same thing for this. There's not a lot of different things to look at. It's just weird for a human. I mean, somebody pirate themed this this abstract game, because screen wrap on ropes and going around with cannons and cannons launching pirates and stuff, it's not really, I know it's a better game because it's pirate themed, but it was clearly an abstract game that somebody made on some graph paper with some pennies or something like that before it ever became pirates. Level 4, could I beat it in time? I don't know, maybe. I'm going to be more interested when the cell phone version comes out to try to make an AI to take that on. I think would be more fun.
but you know, chances with that one is that the look ahead is going to be many times greater than the 4.
Well, I would need to have a static evaluation function that was better than just count the number of pirates, right? Because all I did was scale dumb, and it worked. So yeah.
And to that point, now you won with a look ahead of 12. Did you experiment at all with other look ahead values?
Oh, I could have gone farther than that. And I'm
how about reduced?
What's that? Oh, so when I was reducing, I need to do some more experiments. I was losing when my ply was close to the Commodore supply, which made me think its function was better. But I think I had a bug in the alpha beta pruning at that time as well. So I might be conflating those two things. I don't know. Okay. But it's a great game. It is definitely very challenging. It can be 1 or 2 players. If it's 2 players, the thing you got to know is that player 2 uses joystick 1, player 1 uses joystick 2.
Yeah.
And you
so the other thing, and that's actually, it's a fun game. It's got a lot of replay value when it comes to this. Now, you spoke briefly about some of this code being available. Did I understand that correctly?
Yeah. Well, my code, my Python script, I have it on GitHub. It's going to be a link in the CRX forums that go with this video. So I will make that available.
And you know, for people that haven't seen that, you're typically very good at documenting things. I see a lot of this as great learning material for a student that's entering in AI, basic concepts, and do it in a real fun way as well. And play with this.
Depending on your college, this is depending on the college. This is sophomore or junior level coding. I think I didn't.
Right. And if you're a bit older, like people like me, then you know it may take a few evenings extra, and that's totally fine. But what I really do like is the way you approach this, and kind of made it available for people to kind of understand this in a live concept. I really do think that a lot of people will appreciate that.
If you want to look at the history, this has been studied, like I've said, since the 1920s. This is an excellent book, the collected papers of Claude Shannon. So lots of his chess things in here. And you got to remember, these guys were writing up how to do all this before the computer was available to try it on. They were anxious for that hardware to come along. So
that's actually interesting. So you've shown 3 titles here so far, and I know one of them you're particularly fond of, indeed, and you should bring it back in at some point in time again to plug it, because I do believe that one. That one is a real
Toledo Nano Chess.
Yeah.
So this guy's great. He has written what I think is the best Atari 2600 programming book. It came out just this last year. I've read a number of them. It's all assembly language, right? 6502. But he goes deep and he has tons of examples and gradually builds it up. And you have full breakout games and all kinds of stuff. He's also really into constrained games. He has 2 volumes on boot sector games. Remember the boot sector viruses from a long time ago? Yeah. Well, we don't make viruses and boot sectors anymore, but he recreates those old boot sectors and tries to make the most compelling game you possibly can in just the size of a boot sector. And he's written 2 books on that too. He's got books on
I think it's really interesting. While CRX is mostly a Commodore event, I think a lot of the great books that are available for the Commodore are very, very well known. What I really like is you kind of looked at it from another angle as well. Let's take a look at the 6502 and kind of see what else great stuff has been written here. And this is a fantastic example here of an even more constrained environment and some of the magic that was pulled off there. So I'm
very partial to 6502. I don't think I have the brain power to learn a bunch of different assembly languages. I mean, people like Berger that know and can write natively in every architecture out there. Those people really impress me. But 6502 is fun. It's recreational thinking. So
I think people definitely should start watching your 64-second explanations. For those that are like hyper shiny object syndrome, well, let's try and test that out with your 64 seconds, because unfortunately, you've not been taking on the simplest games either. It's all games that 64 minutes would have been a better fit if it was up to me. But 64 seconds to at least, tease you enough. Say, okay, it's worth looking at. I think this is the first time where you said, hey, I've played this game, but now it's worthy of a lot more background, actually, to kind of look behind the scenes here and kind of place it within the context of today, with AI being all the hype, where really what we've been talking about so far is stuff that goes all the way back to the 20s. I think the first concepts were released.
Well, I told my coworkers I was doing some AI because I work with a lot of AI folks, and they're like, "Really?" I told them, and they all laughed. So
yeah,
the 64 seconds. I've only made a dozen of those. I've had 2 guest speakers. So I had Amy Taylor do one. I had Glenn Case do one. So if anybody's watching this and has a favorite game and think they can explain in 64 seconds, I'd love to have you as a guest speaker. Just let me know.
That's fantastic. Yeah, those are really
covered it, dude. I don't have too many other talking points on this. I look forward to see what anybody wants to do with the code and improve it. Remember, I just stopped as soon as it beat the Commodore. So
right. Well, and I think given the nature of the games that you've been evaluating as part of 64 seconds, a lot of this code is going to be reusable. Right? The concepts are being used in quite a few different games of that era, and even today still. So we may see some reuse of the code coming in here or there in order to be able to beat the game.
These are all very well known techniques, but it's if you've never played with them before, they're fascinating and they're fun, and everybody should make at least one sometime. So,
hey, now it always it's almost become a running gag between you and I. Do you want to do a last closing plug for your favorite game?
Favorite game? Oh, Archon. So Archon has good AI as well. Not just the combat, but it makes good moves and understands board positions. It understands the light and the dark. It understands when to cast certain kinds of spells. I don't know how the AI works in that. I would love to see if somebody has reversed that and documented how that all works. I'm sure somebody has. I just haven't Google searched for it yet. But Yuri and I have this friendly debate about Archon. He just that was not part of his Commodore experience growing up, and he thinks it's overhyped and overrated. So anyway.
It's fantastic. Okay. I've met many fanboys of the Archon game since, though. So it turns out you're not the only person on the planet that loves the game.
Yeah, it's a marvelous game. So
hey, Piracy, great game. Yeah. I think what you've shown here today was not just highly entertaining, but I actually think most people will have learned a little bit as well. Thank you for making it open source as well. Everybody should do that for this type of stuff. This is cool to bring into, especially if you're a bit younger, you're still in college, go and bring it in there. Bring some fun back to college. Bring Commodore 64 to the college floor. Go and do it. This is awesome stuff. David, thanks so much for your time, man.
Thank you. See you in the next one.
Bye for now.
All right. That was an awesome video from David. Yeah, with Yuri interviewing him. And I'm kind of waiting for David to pop back in here. And there he is. So we'll get him back. David, are you there? You have no mic and no video. Oh, you're gone.
I'm here. Sorry, technology is difficult.
Yeah, technology. So that was interesting. How you accomplished all that with the AI, and the amount of massive computing power being used compared to the 64.
Oh yeah, it was just cheating. The interesting thing is we can get 45 minutes out of a Python script in a talk.
Yeah. So we're a little bit short on the time frame, but we have the next guy in, and I think we should probably just bring him in, huh? Since you definitely want to be for this. So I'm going to introduce you, Arthur Jordison. He is the author of CBM Program Studio, and so Arthur, you can come on in anytime if you're there. We'll wait.
Hello. Oh, hello. Can you hear me? Okay.
Hello. Yep, we hear you.
You can hear me. You can't see me just yet. Wait a minute.
Not yet. No.
Let's have a look.
Okay.
Not used to this modern Windows malarkey.
5 minutes to get it working. We're ahead of schedule.
Yeah, we're fine. Yeah, we got 5 minutes. Really.
Why isn't that working?
I'm looking forward to connecting a name with a face.
Yeah, I am too. Especially it's been so long for me, for sure.
Yeah, I mean, I've worked with you a lot in the past, Bill. Jim, sorry, Bill, Jim.
Yeah.
Yeah, I mean, I know you did a lot of the work with the debugger. Helped me with that years and years ago.
Yeah, many years ago. In fact, I looked at that, some of the files. So I had finished, but also besides the debugger too, there was the importer thing we had worked on for the
Yes.
conversion of different programs. And so I looked at that. You can believe this, that stuff was mid 2012.
Really? Was it?
Yeah. So I've been communicating with you
That's
that long.
really, I was thinking it was that early. I mean, that's right at the beginning. So I only started writing this about 2009, I think it was.
Yeah.
I still can't get this video on. Yeah.
Did you get your camera thing worked out?
It was working earlier on when I tried it earlier on. What do I need to do? It's not start video.
On the lower left corner, there should be a stop video or start video.
There is a start video, but then if you click that, it says you cannot start your video because the host has stopped it.
Oh, okay.
I think it's you've stopped it, Jim.
Oh, ask to start video. How about that?
Oh, there we go.
Ah,
there we go. Hey,
oh,
Brian.
hey.
Hello.
A name to the face.
Hello. Hi. That's the problem with these things, isn't it? You kind of get to know people through their aliases rather than their actual names.
Right,
So,
right.
I think I've dealt with you before, David, quite a few times, but under Crypto Boy, and it was like, so not that. So now I know.
Yep.
And apologies that I only write when I want something. So it's excellent to talk with you today.
That's
kind of the running joke between David and I about that. It's like, well, I found this thing in CBM Program Studio. It's like, well, let's hit them up, you know. Because I know you want to fix everything, you know, that there's an issue for sure.
Yeah.
Amazing.
Well, I won't say that, but it's been quite a while. I mean, this last round of bug fixes has been quite slow. But prior to that, I mean, when I first started getting involved with you, Jim, it was every few months I was releasing a new version, and now it seems to be every year. So it's kind of kind of dropped. That's not your fault, but it seems to have dropped off a little bit.
Yeah. So can you talk to us about how you started this, why you started this? I mean, we don't know the history of that really, other than, you know, I kind of jumped in with you, I guess 3 years after you started it, which is a long time.
Yeah. Well, certainly, yeah. I mean, basically there was I'd been away from the Commodore 64 for quite a number of years. I didn't really get back into it until I was about 30, somewhere around there. I had when I was a teenager, as probably everyone here. And then I kind of got hold of a second-hand one just out of the blue, and then I thought, I'll try and try and do some tools. But I was interested in kind of writing some scripting languages and things like that for it. But I thought, well, there aren't really any modern tools. I mean, there was Petcat and things like that around, and was it CBM Prog Convert, I think, or something like that. But they were all kind of command line based, you know, useful at the time, you know, good for Linux users and things like that. But really, I wanted to put a front end on something, and rather than just putting a front end on Pet Convert rather, I thought I'd just have a go at writing my own. So that's basically how it was born. I mean, the original version was C64 Studio, but then people from other platforms were interested. So people would say, oh, well, can you do me a VIC-21, or I can do me a PET one or something like that? And I thought, well, I did a VIC-21, and I thought, well, it's 99% the same code, you know, almost. So I thought, well, I'll just try and merge them. And that's how Prog Studio came about, really. It was about 2 years later, around about 2011, I think it was. It came from there. And it's been developed on and off, mostly off, since then. So it's getting on 14 years now. It's been around. So
yeah,
you know, it man and boy.
Yeah.
It's kind of gone full circle, because I don't actually own any 64 stuff anymore. This is the only Commodore hardware I have.
Really?
So, yeah. Oh, and a calculator. I've got a P50 somewhere.
So you do all your testing in Vice then?
It's all in Vice, and I've just found another emulator I like the look of called Denise. I think it's quite old, but it's been reskinned or revamped or whatever.
Oh.
So that looks really nice. I don't know if you've heard of it.
Send this guy a 64, even if he just mounts it on his wall in his office. You need to have one in your house.
Do we need to send you a 64, Arthur?
Yeah. I can make that happen.
If I had this, no, really, if I had the space for it, I'd have another one, but I just don't have the space. So everything is emulated.
It would have been an NTSC anyway.
Well,
that's true. Yeah, I wouldn't be too happy for.
Although I did kind of during COVID, I toyed with the idea of making a cabinet, like an arcade cabinet, with Raspberry Pi. I've still got all the bits, but they went up in the loft or the attic, and they never came down. So, but might be a nice little project over the winter, something to do.
Well, if you have an attic, it sounds like it's a computer room to me.
Well, it would be if I could actually get in it. It's just full of rubbish. So, so I can stand up in it, but that's it. I can't really move around in it. But it needs a good clear out, and that would be ideal to get up there and get back into doing some hardware. But I haven't touched a soldering iron in about 2 years, so it's just a shame to do like.
So for people that don't know CBM Program Studio here, have we given I've already lost track. A quick overview of the major features of what it does. You've made an IDE, basically, an 8-bit IDE that is cross-platform, platform meaning the different Commodore machines.
Yes,
and you support. You support BASIC, you support assembly language development, and all kinds of other stuff. So why don't you give us the high-level features of what it does?
Sure. I mean, I was kind of going to give you a little demo, really, because I've got the new.
Outstanding. I'll switch over to.
I've got the new beta version. Which has been released on Discord about 2 weeks ago, but I'll put a link to the one I just finished off 2 days ago. I'll put a link into Discord for people to have a look at today. If you can get the live. Do I do show my desktop? I think that's all right. Share screen. This one? No, this one.
Here's are hard. There we go.
There we go.
I'm more used to Teams than Zoom, so we use Teams a lot during COVID, not Zoom so much, but I'm kind of getting the hang of it now. So this is it. It's had a little bit of a. People have been using version 4.1 for quite a while now. So this is it's had a little bit of a reskin, if you like. The front page has changed slightly. These are just some plugs for other people I know. Most of the people are here in the UK, I think. But if this space is available for rent, cheap rates.
Nice.
So here's a little demo of this. So the aim was with the original C64 studio was to, like you say, create a visual studio kind of IDE, and that's kind of what I've tried to copy. Is a bit strong. It's more of a mimic thing, really. It's kind of a feel of it. Because obviously they've got 1,000 programmers working on it, and I'm just me. So, so load this demo up. There we go. So for this one, it was just basically you have a what's called a Project Explorer. You'll both be familiar with this, but it's just for other people basically. The big revamp in this one is almost invisible, because the idea is that prior to this version, the Project Explorer was a fake directory structure, in that you would have assembly files, BASIC files, character sets, etc. But all files weren't stored in that directory in the drive, the root folder. And they were just added to these when the project was loaded. But these directories now actually exist. So it's much. I'll show you. So project folder. Let's bear with it for a bit. So see here, these actually exist now, and the behavior in the Project Explorer in here is the same as the Windows File Explorer. So you can drag and drop files around. You can set an output directory, that kind of thing. It's
real quick. You're not sharing your screen. You're sharing a particular window. So when you open up a new window, we won't necessarily see that that thing.
And soon
So
you have to actually do the option for sharing multiple screens or something.
All
like
right.
that.
Okay. Yeah. I mean, I'll only
you
do.
might not want to share your whole screen either. We don't know.
Yeah. I mean,
No, I'm just on a laptop at the moment, so that's all I've got. But there'll only be a couple of extra screens that will open up, but they'll be to do with Prog Studio, so I'm not sure how Zoom will cope with that. Because I was going to demo the sprite editor later on.
You can do share desktop, right, Jim?
yeah, you can share a desktop, or you can share a screen and then multiple screens too.
All right. Okay.
So.
So basically, this is now changed into a proper Windows File Explorer style tree control, if you like. And you now have, so click on that, you have file information down in the bottom left rather. Whereas before it was on the mouse hover, and it was a bit, I didn't like it, basically. So it's changed it. So what I wanted to do with this one is just to show a basic demo. It's one everyone's familiar with, so I'll just run it. Let's let it go. So it's the old balloon, the Commodore balloon. Everyone's seen that. You must have typed it in. I know I did plenty of times. So what I wanted to show, close that, was basically, and we might see if this will work or not for the sprite editor. Can you see that window?
Yep, yeah, we see that.
Yeah,
the sprite editor we can see. We didn't see the demo of the balloon because it was a different window. But when you ran that, it compiled and made a basic program. It sent it to your emulator of choice, which was probably Vice, and then we saw the Commodore balloon. I saw it in my mind's eye.
Okay, well, that's going to complicate the rest of this demo. So basically, what I wanted to show here is to make things a little bit easier on the developer, so we can import from a listing, because we have all of this sprite data here. So just find the sprite and it'll bring it in.
Oh, nice.
So what I wanted to do is just to make sure that it worked properly. We'd flip it left to right, and then let's see now. I'll just make sure this is at the end of this line. It makes things a little bit awkward. Back in the debugger, and export that to the listing. Start at line 1000.
Oh, that's nice at the back. Yeah.
So that's the new version of the sprite. I'll export it into the basic, and now I'll run it again. But you just have to take it on trust that it's been reversed.
Well, you can keep going down to share and changing what you're sharing, but I'm not sure you want to do that.
Right. Okay, that's fine. That was kind of it for the basic side of it. Anyway, there's a couple of other things in here that help the developer a little bit. You can leave blank lines in. You can also put kind of these style of comments which don't get exported to the generated file, so you can litter your own source code with plenty of comments. I know developers don't like putting comments in, but it's always an option. And then but those comments won't appear in the final prog file.
Yeah.
So also what I wanted to show you.
Well, real quick, back on BASIC. Yeah. You say that's about all the show. That is definitely not all the show about BASIC.
No.
So one of the things I love about your environment is our group here. Every once in a while, will participate in the 10-line basic coding game competition. It's been going on for a decade. I actually have Gunner's book he did in 2014. It's all in German, so I can't read it, but I can read code. But Happel and I have been participating. Happel, the judges love Happel's games way better than mine. But your tool is absolutely essential, because I don't know if people can see it well. There's a dividing line you have right there.
Yes.
That's 80 column.
Yes.
Yeah. And you also have to the left the number of characters that are in each basic line there as well.
Yep, that's right.
And so when you're trying to fit this into 10 lines of basic, that's very useful. And the other thing that's super useful is if you go to edit and go to, I think it's advanced, and go to compress and hit that. Now we have all of the basic abbreviations. And that is what everybody has to use to get these things down to 10 lines. So with all of those features together, it is so much easier because when you're refactoring code to try to do this actually on a Commodore is the path to madness.
It is a pain.
So thank you very much for making this. This is the environment for developing for Commodore. So I did a VIC-21. I did one called Duet Hero, where you have that little, I don't know where it is, the plastic keyboard that's a piano keyboard you can stick over the keys. And it was Bach's two-part invention number 13. And you had to play the right hand along with the left hand, and you had to keep up with it in the music, and it was scrolling up like Guitar Hero. And the only reason I was able to do that in 10 lines is because of this development environment. So thank you. I just want to say that before moving on. Yeah,
excellent. Oh, good. No, I'm glad it's been useful for, I mean, I do get a lot of feedback generally, and it's mostly positive. But it's always nice to get some praise.
Yeah, I'll be honest. I've only looked at the basic stuff. I don't do any basic programming, so it's all the
no. I know you. Yeah, I know what you do, Jim. You have all your drive code and everything.
Yeah.
I got one more bit of praise for the basic. So Happel should jump into this. Oh no, he doesn't use this tool anyway. He is using the Mega 65. He's going to be giving a talk tomorrow or today. When is that? Tomorrow. And he's writing a basic game on the Mega 65, and it's actually pretty cool what you can do in basic. It's made basic fun again. And he wanted me to make 6-part. Well, I don't know if he wanted to be 6-part. I made 6-part Battlestar Galactica music for him. The theme, with all the parts and stuff like this. I made it in a music environment first called Sibelius, but then I coded it all in the Mega 65 basic, all 6 voices. And again, essential tool here because all I have is the emulator for Mega 65. Mine doesn't arrive for like a couple more years. They're back ordered, but you have all the basic commands. You support all the tokens. So I was able to get my whole workflow and take the sheet music and make the basic codes here, and then move it over the emulator and see it work. And that integration that we were supposed to imagine with the hot air balloon worked for the music part. So again, thank you. That's a brand new Commodore-like machine that you're supporting. You support many computers. So that's more I want to say about basic before you moved on.
No, that's had quite a lot of positive feedback about the support for the Mega 65. But so if you want to send me one of those, that'd be nice.
Okay, well, hey, be careful what you wish for.
I know. The only problem I've had with the Mega 65 support is that the latest ROMs don't support the code injection, so you can't do the auto launch.
Yeah.
Oh, right.
So that's been a real pain. Well, for me. So, but if it's a little bit disappointing, really, that they took that feature out. I don't know why they did. I did ask them on the forum once, but I never got a reply. So.
Yeah, they've got the ability to FTP into it, because Jim showed me that the other day.
Oh, really?
Where they've got a virtual FTP into it. So that might be an option they can do.
That's an option, yeah, definitely.
Yeah, I'll have to ask Jim to give more information about that. But I got to see that. He actually transferred some files and everything.
I can't remember what I was doing. I think your code just generated PRGs and I dragged them into the emulator is what I thought I was doing.
Yeah, that's the obvious way of doing it, but it kind of cuts it makes the.
Oh, I'm sorry, Jim. You were talking about a real Mega 65. Sorry.
Yeah. So with the because there's no code injection that's into it, but so tomorrow, take a look at if you've got a chance, Arthur. Take a look tomorrow at the demo that Jim's going to do, because I think he actually talks about that.
All right. Okay. What time is that? What time?
Let's see. Our schedule says tomorrow at 10:30 a.m. our time. So
all right, so that's the middle of the afternoon for me. Yeah,
that's 6:30 p.m. for you.
Yeah, that's great. Yeah.
Yeah, there you go.
Excellent. I'll try and look at that. Yeah, it's midnight.
Yeah, and I'll make a note to Jim to make sure you talk about that for sure. That'll help you out.
Oh, good. Thank you.
Yeah.
Yeah. I forgot where we got sidetracked a bit then. Where were we?
Oh, we're going to talk about some real stuff, real assembly code
Yes,
now.
the real assembly code, not that little get anyone too excited, but this is more. Yeah, exactly. Again, I can't show the output, so I was just going to generate and show the output into the device. But what I really wanted to show, because I've made a few changes to the you might be interested in this, Jim. I've made a few changes to the debugger and how that works.
Oh, okay.
Let's see. I'll just fire it up.
David uses the debugger too, though.
Oh, I use your debugger all the time. You have a little virtual screen we could see that print on.
Yeah.
Of course, you already know that.
Mm-hmm. Yeah, I mean, I think you pointed out, David, a couple of bugs about a month ago, didn't you, about the stack overflow and underflow not working properly?
Yep.
I think that was you.
The wraparound
Okay.
or something?
Yeah, the wraparound.
I've been working on this. I dropped a book here at CRX. It's a bunch of assembly. I haven't shown it to you yet, I guess. It's a bunch of assembly languages examples with answers in the back as to what they do. You're supposed to figure them out to practice your code reading. But I used your tool for every single one of these things in here because you have a largely system independent interactive debugger that lets you step through and see all the registers, see the effects on memory, see the effects on the stack, modify these as you see fit. Yeah. And there's some wacky edge case kinds of stuff in here that I was finding bugs in Apple emulators. I was finding bugs in different kind of emulators. I found some bugs in yours as well, in the BCD and also in the stack wrapping. Yes. But thank you for the very quick fixes on those. I don't mean to steal your thunder. You just got me excited. So sorry. Yes, I use that extensively when making this. So thank you. And go ahead and show people what this is.
No, good. Well, the idea was that was the original intention, to make it kind of platform independent, because I didn't really want to try and emulate the C64 as such, because I'd have had to go down the route of trying to emulate all of the platforms, and that's just is a massive project. And I'd been competing with things like the C64 debugger. I don't know if you've seen that one, but that's incredible. That debugger, that just blows this out of the water. But I find it a bit overwhelming when you try and load it up. I don't know about you guys.
I'm used to this. I love this.
Right. So the first thing, as you know, we've got the simple Hello World program. We can step through the code. So it's pretty straightforward so far. Updated screen memory there, so you've seen the H. Yeah. So going well so far. So again. So we don't need to run the whole thing. Just right click there, run to address. So do it at warp speed. It's not really a warp as such, but it just runs it as fast as possible. It's not timed to any particular clock or anything like that. It just does it. So it's as fast as the computer you're running on, basically. So as you see, the output there, hello CRX. Now, one of the things that's been added to this is a kind of a state machine. So we can save this currently emulated state. Just wait for this box to appear that you can't see. Right, so save that.
We see this one.
Oh, you see that one?
This one. Yeah.
Oh, okay. Good. So that's saved the entire machine, if you like, a machine state. So it's saved the memory, the breakpoints, stack, the watch list if there were any set up. So just to prove that, so we had that memory and code in memory. Where's that gone to? Registers. So this might be a little bit. This is a beta version, so it's a little bit cranky. No, it's not the right one. Bear with me. Set that again to
3000.
C. No. Yeah. That's the fella. So there's the program back. So that's been saved in this state. So we can close the debugger. Everything goes. Just fire the debugger up as it is. And we see in here we have a list of recently saved states. So you can just double click on it. And it should have loaded it back up. It hasn't set that's a bug. It needs to set the PC. Yeah, it needs to set the PC for that. So and there it is, all back.
So
if
this is fantastic.
It was a last minute. Someone suggested it last week. Said, "Oh, how about a state machine?"
You know how I do this
Yeah.
is that you have an overlay capability.
Mm-hmm.
I actually load an overlay file before I do the debugger.
Yeah.
And so I load the entire system memory. So I went and captured an entire 64K of memory of the actual state of a real 64. And then I load that in first.
Yeah,
that
it's the Vice save state, isn't it? You can load that in.
Well, no, I actually do it in yours. I used the real 64 to do it, and then I copy the file over and all that. I used capture card. So that way I can walk through things in basic prints and stuff, and it all works. So this is great. This is even better by far.
Yeah, because you could actually load the ROM into this as well and things like that, and save the whole state machine in one go, and then just load it all in one.
And you can switch ROMs easily this way too. So that's awesome. Yeah, that's great. That makes it easy switching.
Sorry, I've just noticed another bug there. Let's make a note of that.
Yeah, it's interesting with the overlay. I did the same thing that you did, Jim. I don't remember how I did it. I used Vice and I somehow dumped. I made the banking the way I wanted to, for the ROMs I want to see, and I made that overlay file, which for this debugger means that that memory view you see in the top left-hand corner there, all that memory is populated by what the overlay is.
Yep.
Because I was doing some kind of ROM calls or something like that. Well, and now I forgot the point I was going to make. Well, that's cool enough right there. I was heading towards something and went out of my 52-year-old brain.
The overlay is required for doing certain ROM functions. So if you do like a basic call or something and basic memory is not set up correctly, you'll get trash.
Now remember I was going to say, I'm very familiar with the Vice debugger, but I find myself when I'm using your development tools, doing all of my debugging of assembly in the IDE before I ever even move it over to Vice, and I don't use the Vice debugger nearly as much.
Yeah.
Because I can do it all right in one place.
Yeah, I mean, I do like Vice, but it's a lot of keys to remember, and that's
I'm not a big fan of CLI stuff, really.
No. I'd say it's all right for you Unix guys, but not for everybody else.
So people that don't know about the debugger, what it can do, I know that what I used it for primarily when I first met with, or virtually met with Arthur, was when I'm walking through code at the top of the debugger, you can see last instruction number of cycles and the total cycles executed. So when you're doing things that are time sensitive, like disk drive serial transfer code and things like that, you have to cycle count, and you can cycle count through all of this. And if you want to know how to optimize something of your own code, you can run different iterations with different timings. You can see exactly what you're doing, your changes, like you save a cycle here, save a cycle there. So this was critical for me. It's not an option when you're doing like the disk drive code and stuff, because if you're off a cycle, it's not going to work typically, or it's going to work sketchy.
Yeah.
So this was super important for me.
This is quite useful as well, I find, if you've got some zero page addresses, and it'll tell you what it's pointing at.
Pointing to,
So that's quite useful, I think.
Oh, I've never seen that.
Yeah. And I bugged Arthur to death in the very beginning with the debugger, getting all this stuff working with the cycle timing and all that stuff. So I appreciate you spending all that time for all those months, literally.
It was a massive change, that actually. Just remembered how long it took me.
And he still came for an interview too.
Yeah, no.
No, that's good. So that was kind of it. I was hoping to, I'll show you what the debugger does. There are a couple of other things I've added in. For instance, if we close that off, one of the issues that we found, another person found the other day, was that if you've got a basic loader, for instance, you've got a syscall there. So when the debugger starts, it actually starts the debugging at 0801. So the idea was to add another can't type, to just actually skip all of that and go straight to
that makes sense.
So now when we start the debugger now, it'll just go to this label.
Right. Skip over
it'll just skip over the basic generation. I mean, it's not a great demo because it has to assemble the whole of the memory, if you like. It doesn't skip the generation, it just hides it. So that basic code is back down in 800 odd, but as you've seen there, it just goes and sets the PC straight to that start address. So it's quite handy, yeah.
It is handy. Otherwise, you got to scroll through the thing and click on it, because I've done that a lot, actually.
Yeah, the scrolling isn't great in the debugger, I'll admit it. And now that monitors have moved on, I'm kind of thinking about just increasing the size of this window, because it is quite small, I think.
Oh, true.
It doesn't really lend itself to make it resizable because of the code behind it to render that memory, if you like.
Yeah, we want to talk about that coding too. About the API and all the stuff you use for developing this.
Sure, yeah. This is all written in a mixture of VB.NET and C#. Most of the C#, let's say, just get rid of that, is the code to handle this control, which does all of the syntax highlighting and the other kind of text rendering. That's all written in a third-party control, which was written by some Ukrainian guy about 10 years ago, and it hasn't been updated for 6 years, I think. So I am in the market for looking to replace that, and I want to replace the whole thing, really, because it's one criticism I do get quite often is there isn't a dark mode for it, and there isn't, because Windows generally doesn't like being skinned. Not these versions of anyways. Right. I'm looking at some kind of third-party tools to help with that, like DivExpress. So that's other things that we
ran into with formatting of colors and things like that, and that's handled by that third-party API, which is why it can't be changed on certain things. I was trying to tell David about this, and I couldn't remember exactly what the story was with that. And
yeah, so, you can actually change quite a lot. Let's have a look. Options. This is a bit of a lick of paint as well. For instance, the IDE colors, you can change quite a lot in here. More there and more here as well. But it's fundamental things that are annoying, sort of like window titles, menu titles, that kind of thing, that you can't change. And if you set everything else to black, it just looks jarring because everything else is the wrong color, basically. So, and I don't really want to move it over to WPF because that's kind of dead in the water now. I'm looking at rewriting it in using Mono, so we can run it on a Mac. Yeah, a lot of people ask us if we can go on a Mac, and now I have access to a Mac, kind of.
It's a pretty heavy lift, though, right?
That's a real heavy lift. Yeah, that's basically starting from scratch. And I mean, I did a look at the project the other day, and there's nearly 200,000 lines of code in this now. So it's that's not trivial. I don't think I want to take it into retirement, you know, just being a mono developer.
So you have other kinds of editors I don't use quite as much. You showed your sprite editor. I think I've used your character editor. In fact, I know I did. I know I've used your screen editor at one time. I was making something for Yuri, and that came in handy as well. You have a sort of a SID editor, but I'm not sure I would use. I'm not sure I would use that because there's so much expressivity you need out of messing with a SID.
But
really bring that up. I haven't looked at it recently.
Yeah, it really is just for kind of experimenting with sounds. People have often asked me, say, "Oh, can we turn it into like a Go tracker or some other kind of tracking tool?" And it's not really for that. You know, it's nice in that if you bring a keyboard up, it might work. It's not working because I haven't set the gate. I haven't got a waveform there. There it goes, yeah. So we can. I think the last big change I made to the SID tool is it has MIDI support now. So if you've got a MIDI keyboard and you can route it through this, then at least you can muck about with it like that. There's also, hang on a second. Right, it's hidden. If you're using a Mega 65 project, and you open the SID editor on there, it will record, if you like, the last note you played and generate a basic string for play command. So that's quite handy. It's nothing flash. It just remembers the last key you pressed. But if you know what you're doing keyboard wise, then it's handy to hit it instead of having to transcribe everything. So it's quite good for that. But this doesn't get a lot. It was one of the first things I wanted to implement in the old Prog Studio, but because I couldn't find a SID emulator that worked properly and that I could get an API into, I just kind of binned it for a bit. I put it on pause, and it didn't kind of come back until about 8 years later, I think. So it doesn't really get a lot of love, but it's handy, I guess. It generates basic code and things like that, so you can save your settings and generally mess about with sounds.
Can you show your character editor?
Yeah, sure. So close that. So
this I have used.
This is fairly basic. The last kind of extension this got was to support kind of tiles, but they're not really tiles as such. You can drag characters onto it and make up a map if you like. But it's more of a thing to get a look and feel for how the map would work. Right? It doesn't save tile set data like Subchrist tools do and other popular ones like that.
Okay.
But anything you edit here does appear in the screen editor as well, so you can edit things live. Let's see if I can demo that without. So you might not be able to see it. Bring up the screen editor.
We'll try.
We'll try. Yes.
Yeah, I had a semi-complicated PETSCI thing I had to put together that for Windows, it was a keyboard tester thing. So I drew them all in this tool. So that was useful.
All right, it is quite good. Yeah, it is. But there are much better ones out there. That's the kind of the great now. This has been left alone for quite a while because the focus of the work now is to it's to get the assembly writing a little bit better. But now I've added kick assembler support. That's kind of fell by the wayside a little bit because most of the dealings I have with people now are writing everything in Kick.
So what kind of support is there for Kick? What kind of integration do you do?
Well, it's basically, the editor knows about Kick keywords and directives, and any project that you create with a Kick platform will be assembled by Kick as long as you've got all the right, it's the Java SDK setup and there's an XE file it needs, but it's basically just fires the source code at Kick and then picks up the output from it. Kick itself isn't integrated into it. It's just called by it. Yeah, it's just a kind of front end for it.
Gotcha.
I might add some other assemblers in the future. I don't know. Kick's the main one because I think most people's tool chain now is sort of Visual Studio Code and Kick editor, Kick assembler rather, and other third-party kind of character editors and stuff. But they're kind of the super advanced users, if you like. This tool here wasn't really written for them. It was more written for people like me, basically, who are trying to get back into the coding side, and help your hand, hold your hand with that, and then you'd move on to something a bit more advanced like Kick later on.
Anybody ever ask for Exomizer integration?
It's been asked for along with cartridge emulation, the cartridge support. It was that kind of trying to start.
It's that compressor. It's that
it is a compressor. So, but it doesn't support it directly. But what it does do is there are things like pre and post build commands you can use, and one of those is to run a batch file. And basically, you just set Exomizer up in the batch file, and it runs it from that. Same with the disk management. That's quite poor in Prog Studio. You can create a disk image from a build, but that's the only file it will target. So you can't keep adding files to it, at least not very easily. But if you do it through a third party, like I say with the post build command, and then use what's that tool that we use? there is one where it's like a GUI front end, but it does have a command line for it. It's dir master, I think it's called, or something, isn't it?
Oh yeah, directory master.
Yeah,
Yes, yeah.
Yep.
So I use that basically as a command and just get that to create the disk image from a batch file.
I love that tool.
It's a little bit it's a bit of a kind of clunky solution, but it's a mini kind of tool chain set, which is pretty good.
So I remember going out and looking for documentation. It's like, where's the documentation for this thing? And I think you're like, go to the help menu. So you have all the details about how to use the assembler up there under help and basic and stuff like that too. So
that's all there. Yeah, it's just getting a little bit of a revamp at the moment because it's falling behind a little bit with the Kick support and the Mega 65 support. Just it's one of those things. Nobody likes writing the help. And nobody reads the help either. So,
I do. I need lots of hand holding, so I definitely read it.
So thanks for that. So that's kind of on the list for this week, actually, because this beta version that you're seeing now is almost finished. There's a couple of bugs that I've spotted tonight, so it's been useful.
Leave it to us to find the bugs for you.
Just like the good old days, Jim. Yeah.
Yeah, really.
God, I know that was coming thick and fast.
Do you get a shot of dopamine or a shot of adrenaline when you see the email title bug?
It's more of a shot of dread, I think, if that's a thing.
More the adrenaline than the dopamine, yeah.
But then you realize what's been asked to fix, and you think, oh yeah, that's quite easy. I can do that now and send a beta version out. You know, that's a nice little thing.
Yeah.
It's the binary coded decimal edge cases that you don't like.
That was a bit of a head scratcher because that bug has been there for a long time, years and years. And it got to the point where they thought, nobody's going to do this one. You know, nobody's going to be interested. And then, of course, you came along, Dave, and that was the end of it.
It's funny too, because when we were doing the cycle counting and stuff, I know we ran into some of that stuff using switch between decimal mode and not. And so I had told David, it's like, I thought for sure this was already fixed.
Yeah, I thought it was as well, but it obviously wasn't. So we're looking at those specific edge cases. And
yeah, I guess so.
And I thought, well, no, I'll just have a go at it. Another one, it wasn't a bug as such, really. It was the implementing the Project Explorer as a proper file explorer. That's been on the to-do list for forever.
Yeah, that's good.
And it was one of the things that I wrote, and I thought, why did I do it like that? And then, of course, it's out in the wild then, you know, and people use it, and it never really got mentioned, but it was just one of those things that's been eating away at me over the years. So I thought I'll just finally buy. And it was quite a difficult task actually to convert it. I was surprised how hard it was. I thought it was going to be a lot easier than that.
Oh, that's always the way it goes.
But because I'd used a standard directory, like an internal one, it was so ingrained in everything. Like every file you open or close or manipulate in some way, it was totally ingrained in that. So it took about a month actually to rewrite it.
Oh wow!
Yeah, and it's still not perfect. I found a couple of problems with it last night when I was trying, because there are a lot of demo programs that come with it, and none of them work because of this. So I'm going to try and work. That has to be fixed this week.
Wow. You're showing us all these different things, but one thing that people probably don't understand is that when you set up a new project, that's when you can select what kind of machine you're working with.
Yeah, that's changed. I'll just close this lot down. That's changed a little bit because obviously now we have a proper directory structure. Sort itself out. So
yeah, there you go. Create a new project.
Yeah, so the Mega 65 is a new one. There's a new option for Kick Assembler, which Kick Assembler support's been in for about a year now, actually. So it's quite old. I think this version 4.1 has been out for quite a while. And obviously we get the same style of. This is the same. So we just create a CRX project. This is the new part where he says, well, do I want a new directory structure creating for me, or I'll just leave it blank and I'll create it myself. So it's basically that'll be the old style project where everything's in the root.
Right.
Whereas now, if you create it here, there's a summary. Let's create.
You mean I got to go and convert all my programs over now?
Well, no, because if you bring in an old project, like a version 4.1, it will, as long as you don't change the name of the files, the directory structure, it will import them into the proper. If you want it to, it'll import it into the. So if you've got some assembly files, it will automatically put them in the assembly files folder for you, as long as you haven't changed the names at that point. So just,
that's great. I use your screen designer.
That's quite useful. I mean, it's a one-way upgrade. You can't really downgrade it that easily. It's not impossible, but because it saves the root folder in there now, you'd have to take that out, and it's a bit of more of a faff about, but it's not impossible.
That's a good improvement for sure.
Yeah. This was awkward. This was surprisingly difficult to do. Just to make this scroll bar the same color as the screen. In the end, it was just done in CSS because this is just a web control.
Oh, gotcha.
But there's another one here. I don't have enough old projects to show them all. That actually be written as a custom control, just to. I know it's totally unnecessary, and probably a lot of people think, "Oh, you put all the effort into making it look nice." But I get a big kick out of that. I do like it.
Thing?
Sorry.
Was that a VBNet thing, or was
no? There's the control here, which mimics the scroll bar. It's another. It's a C# control. C#.net. So we use C# a lot at work, and I'm trying to get used to that and trying to build more and more of this into it, convert it over. I think VB. I don't think VB.net is a dead language by any chance, by any sort. But you by far you see more samples and sample codes, and it's all in C#. You just have to go and convert it, and it just ends up being more of a pain than anything else.
You have a couple of more people giving you praise in the forums, which you can circle back around and see later. So other people are using your tool and finding value from it.
Oh, good.
So I was just looking at your gallery that you have on your page of people's programs that they've written in this, and I've always been impressed by is Jim Orlando, I guess is his name, who's been porting arcade games to the PET in Petsky.
Yes, they're great.
So he's got he's got side-scrolling platforming games. He's got Donkey Kong, Space Invaders, Lode Runner, Defender clone, a shoplifter called Pet Lifter. So so apparently making all those and using your tool. So that's cool.
Yeah, no, they're really impressive, and hats off to him for doing that. I was really impressed with that, because I didn't think that the machine was capable of that, even though it's running at the same clock speed and everything. I didn't think it was. Someone's obviously showing it some love, that machine.
You got to be pretty creative with the Petsky as well.
It's great. Yeah, it really is good.
Changing Petsky.
Well, besides getting feature requests and bug fix requests from people, how can people help you? Do you have like a donate button or anything like that?
I do, yes. Shameless plug. Yeah, there's if you go on to help, I should actually put it on I should put it on this screen actually, make it a bit more prominent. But you can donate through that's PayPal, and that's not. Where's that gone now? It's disappeared. I wonder if it's on.
It's on your website as well, huh?
It might be. It might be on the other help actually. I don't know why there are two helps. I don't know. It's
like a good lawyer. I'm asking a question I already know the answer to. So
yes. Oh, there we go. Yeah, but there's a donation.
There it is.
Buy me.
Oh, okay.
Yeah.
Oh, so that's the Ko-fi thing site or whatever. Yeah, I remember that.
I think so. Yeah, it's quite good to buy me a coffee, because you generally get a little bit more than PayPal will give you, but they hang on to the money for quite a while, so you don't actually get it for about 2 weeks.
Well, expect some more coffee from me. I wanted to keep you incentivized to work on this, so expect some coffee soon.
Yeah.
Oh, thank you. Yeah, I appreciate that.
That's interesting you had with the scrolling thing. That is something that's advertisement for real, that you can actually, buy ads in there, or is that something you put in there?
No, it was just a throwaway comment, really. I mean, if you've got something you want me to plug, I'm quite happy to plug it. Yeah, I'll put it.
Well, I'd love to sponsor something for you.
Oh, okay.
Maybe it'll buy a copy and I'll sponsor something.
I'll get rid of these jokers and put you on, Jim.
Yeah, well, yeah. I mean, I'll buy an ad in there. I mean, that's
I
a
don't
great
know.
thing.
Yeah, I've no idea how that would work in reality, but it's certainly something I'll think about.
We'll work
I mean,
something out.
yeah, we'll work something out. Yeah.
Okay. Sounds
doing
good.
kind for now. The amount of hours you've sunk into this, Jim, is probably about the same as me back when we were doing the assembler.
Yeah.
So it's
that, and the other problem that we had was the converter program, because I used Develop 64. I used Commodore's assembler originally, and then I switched to Develop 64, which you hadn't even seen before. And so I didn't give you all the files of how the structure works, and you end up making a Develop 64 converter for it.
Yeah.
So then I was able to convert everything over for all my old products. I mean, literally everything I had done for Utilities Limited and Final Source Software, all the stuff I did back in the day. So I have every single commercial program I ever released in CVM Program Studio. And I have Stripe code and computer code. I've got the screen editor code. I've got all the stuff all separate. It's brilliant the way it turned out.
Good. Yeah. I totally forgot about that, Jimmy. Thanks for reminding me.
What features would you love to tackle at some point? They may or may not happen, but you've been thinking about them, or they're hard, or you just haven't gotten around to them yet, or people keep requesting it. What's on the horizon?
I'm one of the things used to get asked quite a lot, not so much these days, is trying to debug basic programs live. But that would involve writing a bit of C64 emulator, basically. One other way I thought about it was kind of making calls into the ROM, into the basic ROM as I was doing them. But then the kind of tests I did, you'd have to write your basic in a very specific way, so you couldn't have multi-line statements and things like that. It was more of a case of, it really didn't lend itself very well, and people kind of get a bit fed up pretty quick when they can't do it the way they wanted to do it. So it kind of got a bit abandoned. And another thing I got asked a lot about was a basic compiler. Which I did actually make quite a lot of headway into that. I kind of came up with a thing called PBasic, which is a little bit like the BBC's BASIC. So it was more like Pascal, actually. So it was no line numbers. It was all script based, proper control structures and everything. And that got quite a way into that. I got more stuck, if you like, on the kind of the syntax analysis stuff part of it, and lexical parts. That was just beyond me. So that was that got a little bit out of hand. And I've seen some other books since then. I think there's a Dragon book. Some people might know. That's a really popular compiler book.
No, don't use the Dragon book. Yeah. You don't, and I don't know if we want to give these terms. You don't want an LR1 parser. All you need, in my opinion, is a simple Dijkstra shunting yard, because the Dijkstra shunting yard is going to be about this much code, may not actually be just this much code, and it will do parentheses, it will do order of operations and all those kinds of things, but that might be all you need for some better parsing. But I'm happy to hook up with you if you ever decide to revisit that. I could throw some code your way, say, hey, how would you parse this? And I guess I could do your .NET stuff. I'll figure it out. But just let me know if you have a fire in the belly to get the parser better. I will whip up something for that on you. You don't want the Dragon book; that is way old school.
Yeah, I know it's quite an old book, that one. Yeah, it just kind of came back in memory there. But
I have it. I have it on the shelf over there.
Yeah. Oh, good. Oh, thanks, Dave. Yeah, I might take you up on that, because that's one thing that's been bugging me. But another thing that's been really bugging me is the support for expressions in the assembler. It just doesn't do them very well. It gets lots. It really does need a lot of work. Because people say, "Oh, well, I wanted to do, load the accumulator with this plus this minus this times sine theta, wherever it is." And I think people are trying to put a bit too much emphasis on trying to write code like that. But you need to make it a bit simpler, I think.
I have had situations in your tool where I have had to break that out with assignments into simpler steps and then use that simpler step.
Yeah.
So that if there was like, let's say you have the less than symbol for getting, the low byte and the greater than for the high byte, trying to combine that with any kind of arithmetic would have to be broken up into multiple steps. Yeah.
It does do that, but it has to be very simple. It's usually just one operation, and it tends to throw a lot of people. I had a bug report a week or so ago, arguing with this guy. I said, well, the results of this are wrong. And they weren't wrong. It was just the operator precedence. He wasn't quite understanding it. So it was getting the low byte, then adding 4, instead of adding 4 and then getting the low byte. There's quite a subtle difference. So we had quite a back and forth with that one.
So if we're done showing stuff, why don't we go back to regular view? You can stop your screen sharing.
Okay, sure. Yeah, I mean, unless there's anything else you want to say, I think we've been through the tools. The other odds and bits and bobs are more of a, it was really the debugger I wanted to show you. That's got its own kind of quirks still, in that you'll sometimes get more than one breakpoint passed over for the same thing. I don't know what's going on with that. Basically.
That debugger was so useful for the book I made. So thank you very much.
No, good. No, yeah. I'm just glad. It hasn't been touched for a long time, and then somebody else, a guy from New Zealand, he uses it quite a lot, and he said, "Oh, how about this and how about that and what about this bug?" And it's kind of got me interested in it again, because I kind of got fed up with it for a while. Because I thought there's only like 3 people using this in the world. Why am I wasting my time with it? But he says, oh well, I've been told that it's quite a few more people than that. So yeah, I'm a bit more fired up with this rather than fed up. I've lost my train of thought now. Yeah. So what else was? I think that was kind of it.
Okay.
For the kind of features, really. I mean, obviously, there's a lot more to the screen and the character and the sprites and everything than we can show in 20 minutes or so. But I think generally they work quite good, and they're good enough for people's basic use. I think I'm not trying to create like an animation studio here or something like that. Other people have done that and far better. So I'll just leave it to them.
Okay, so if you stop your screen share, we can all go back to full size again, and we can close this out because we've come into the top of the hour.
Okay, how do I close that? Just
click on the red button that says stop sharing.
Oh, yeah, there we go. Yeah, it's embarrassing. Oh, there we go. Yeah, make a full screen.
And then I can put this back to gallery mode. There we go.
Excellent.
And now we're all back together. So, yeah, I mean, your program obviously is extremely useful. I've used it now for more than a decade, literally. David's used it for a couple of years now, at least, right?
At least 5, I think.
Oh, yeah, good. Yeah.
So there's a few of us out there. No, well, there's quite a few, obviously, and we hope that people will check out your program and click the Buy Me Coffee button on it as well. It'd be nice.
Yes, that'd be nice. Yes.
So we can keep you going. Our goal here is for you to clean out your attic and make a computer room. So that's the goal. Keep buying you coffee.
Oh, brilliant. I'll tell the wife. To be interested.
Yeah, he said he would take a Mega 65, but he didn't want a Commodore 64. That was interesting.
Well, yeah, I think it's good. Well, it does emulate it, so I
don't want to push you in a corner. Yeah, you just emulate
a little bit. Yeah. But,
biting the hand that feeds me.
Yes, something like that.
Well, we really appreciate you stopping by. I've been communicating a little bit about this, Zoom thing, and didn't know if I was going to make it or not, and so I'm thrilled to be able to put a face to an actual name.
Yes. I don't think I've met either of you in the flesh. So, well, I haven't met either in the flesh, but that would be for another time, hopefully.
Yes.
Yes. Yeah. I mean, I do look at the. Yeah, I mean, I do
get over there every year or so. So maybe I'll buy you an actual coffee one of these days.
All right. Oh, good. I'm in the northeast of England, so it's. But yeah, I mean, I do like to see the shows. Watch LGR You know, he goes to the one in Chicago every now and again, doesn't he? That's always good. But we don't have anything like that in the UK, which is a bit of a shame, really.
I went to World of Commodore in the UK once.
Oh.
Went to London, World of Commodore, which is in the 80s. So
yes, that was
it was
the last
fun.
time I went to London. So, yeah, they are good, but it's just they just don't do them here. They're not that popular for some reason.
We'll try to make them more popular in your country.
Yeah. one bit at a time.
That's right, one bit at a time. Okay, so we're going to close out. We've got the next one coming up, and again, we really appreciate you stopping by. And it's
me too.
Yes,
it's been a pleasure to meet you both. Yes,
we'll keep debugging for you.
Good. That's what I like to hear. My minions.
I got one ready to send.
Oh, okay. I don't think I'll be getting right on it tonight. I've had a long day, but
it's a priority time too. So we appreciate you being up late. Yeah. Appreciate that.
No, excellent. Well, thank you very much.
Yeah, and check out the video tomorrow about the Mega 65, so you can see how that.
I'll remember that. I've written. So, I've written a note about.
All right.
Excellent. Good stuff.
Good seeing you, sir. Thank you.
Excellent. Andrew, thank you very much. Enjoy the rest of your show. Yes. Goodbye.
Right. Thanks.
Bye.
That was fun.
Yeah.
It's so many of these people that we're talking with here, I've only ever met, until recently, like within the last month, VCF Midwest are on here. There's just been text. Yeah. So it's fun to actually meet someone. It humanizes them, but it's nice to see the people behind what they type. So
speaking of which, like the next guy you got to meet for the first time ever at VCF Midwest.
Mark. So Mark lives. Oh, you know what? I'm a bad interviewer. I didn't twist his arm to join the Discord. We have a 2-hour talk coming up, and I'm gonna stop and I'm gonna go there and grab him really quick and bring him over to be in the forums to respond to stuff. But yes, so Mark Lemmert, I got to make sure I get the last name right, is the person who created Nox Archaist, and he has a very active Discord where people go for help because the game is immense, right? And instead of having a big wiki, it's interactive, and all the people that have previously played are there. So I've typed with him for a long time. And so when the VCF Midwest trip was coming up, I realized, that's like an hour and a half drive for him or something. It's close.
Close.
So so he should check it out. There wasn't a whole lot of Apple II there for him. I mean, it was pretty Commodore heavy, but there was a couple of Apple II displays, and he met people that he knew. But it was great to meet him in person also. That's how a lot of these talks, of course, got lined up.
Yeah.
But except the
interesting guy for sure, has a huge passion for what he's doing. That's what I got out of conversations with him. Oh yeah.
It's to do anything of that scale, you have to have a very weaponized, focused OCD, right? You have to be able to latch onto something, and it just like a pit bull does not let go. I can't imagine the scale and scope of those kinds of efforts would be beyond me. There's no way I could possibly do that. It's just too many details. I like little useless things, as you know. So
yeah. The more useless, the better. We know this.
The more useless, the better. Absolutely. That's the problem, is people are buying this book. I think they're finding it useful or something. So I'm going to have to back off and change gears. So,
well, maybe it's the same kind of mentality. Like, hey, that's useless. I need that.
There we go. Thank you. You're speaking my love language now.
Okay.
So yeah, once you queue this up, I'm going to run off and see if I can grab him and bring him into the forums. But did you?
This is a pretty long video. Good morning, everybody. But it is nonstop entertaining, so it's very good. I actually sat and watched the whole thing already. So
yeah, this is a technical deep dive. So it's I had never gotten to hear a lot of details about how things were technically working under the cover. So it's about code. It's about it's why this is an Apple II game. It's 6502 language, right? Which is what we speak here. And so it's how some of these things were written under the covers, like the compression and the things like that. Stuff that I find interesting. I hope other people will as well. It is 2 hours. I did manage to cut 30 minutes off of it to get it down to 2 hours. So we had to drop a couple of technical topics, but yeah, take it away.
Okay.
I'll go see if I can find them.
All right.
So welcome to our next CRX 2023 talk. I am David Yaud. I have with me Mark Lemmert. He is the Lemmert, sorry. He is the creator of the Apple II RPG Nox Archaist game that came out in 2020, right? Late 2020. And it's
December 12th, 2020.
2020. Yep. And it's also, you have a 2023 expansion pack, Lord of Storms. So Mark, thank you for being here this morning. This is pre-recorded, so we get to record anytime we want to. So it was great to finally meet you in person at VCF Midwest. We'd chatted online for a while.
Well, first of all, David, thanks for having me on.
Oh, yeah,
happy
sorry.
to talk to you and all of your viewers here today. This is going to be, I think, an exciting conversation, and it was great to meet you at VCF. Midwest as well in person. Like you said, we've been chatting for years, so always great to put a live face, to a name. And to your question, I thought it was a really fun experience. I'm definitely glad that I went at your encouragement, and wasn't too far of a trek for me being a Midwesterner.
It's fun to see across the divide. We have our favorite systems, but just be able to see what other people are working on. And of course, where there's lots of displays, getting to talk with people is the best part. And talking with you, talking with other people has resulted in many of the CRX interviews that we have for this time. So that was great. We create our own luck by showing up. So, okay.
Yes.
So I played your game when it came out in late 2020. There's the box right there. For anyone who hasn't played Nox Archaist, this is a gigantic RPG game. It has the feelies. You have the map and stuff like that. Although there's things not shown on the map that are important.
Of course.
It took me about 120 hours to finish this, and I had a Christmas break, and I was like, I gotta finish because my Christmas break is getting used up. So I was using a guy named Rickles made with Map Cartographer, a third-party extension that does auto mapping. I was using that. I was going in and editing memory. I was giving myself more gold. I was going on the forums and talking to the people that had previously played it. So I was doing everything I could to get that done, and it still took 120 hours. That is a lot of game in there. So thank you for that. That was fun. That pressed all the buttons of my previous 8-bit, kind of RPG experiences, at least as I remember them. I haven't gone back and revisited too many from the past. They might feel different now, but this definitely was very reminiscent of all those kinds of experiences. And then you asked if I would want to beta test the Lord of Storms earlier this year. And that was a lot of fun because that's very I don't know what the word for it would be, like exploration dense kind of way, like where every square on the graph paper matters, like in a Bard's Tale kind of game. And there was hardly any bugs in that. You must have had beta testers before I beta tested, because I just felt like, I see your look there, but we didn't really find too many bugs as far as I remember it. You probably found most of them before I played, is all I was saying. But
sure.
Yeah,
there were two days. This is a strategy that I first deployed for the original Nox game that I repeated for Lord of Storms. In both cases, I deployed 2 beta tester groups, and group 1 basically being the first, and then after group 1 had played through it, found bugs, fixed bugs, etc. And I thought that basically we'd kind of gotten as far with it as we could, because eventually people remember the game, and it's not fresh eyes and all that. Then that's when I deploy group 2 to come in with fresh eyes and see, okay, what else pops up, or maybe some of the fixes on the group 1 bugs didn't implement as well as seen with fresh eyes as all that kind of stuff. And in the case of the original game and Lord of Storms, in both cases, group 2 went in. Definitely some things were found. A lot of polishing, lots of little stuff. But in both cases, it was one where it's like, okay, there weren't too many like huge, big glaring bugs left, because those are the easy ones to find. So
yeah, there were no crashes.
What you experienced there without necessarily realizing how it all fit together in the development cycle.
Oh yeah, I have no doubt that there was a lot of work done before I actually looked at it. I mean, we had a floor tile pressure plate that turned into a monster and stuff, and we were able to track that down. There were some big fun bugs, but yeah, between GitHub and Discord, that was a great way of communicating and getting all that worked out. So, okay, let's transition into the deep dive technical talk that I talked to you about potentially doing.
Tech talk.
With a little bit of motivation for that. Oh, by the way, for anybody playing Nox Archaist now, it's a lot easier. You have a book of hints that's actually should read complete walkthrough that tells you everything. So that's
but only as much as you want. It's each quest is laid out so that it's like it gives you hint 1, hint 2, hint 3, hint 4, and put a sheet of paper on there so you can only see the first one and see is that enough. Or if you want the walkthrough experience, then just read everything and it's going to tell you what you need.
So you wrote this last year, I think, The Making of Nox Archaist. And great book. I love seeing how sausage is made. Lots of pictures, lots of illustrations. I got to this part in the back, and it is the tech talk. And I was like, ooh, finally, some technical goodness. And you gave me 6 pages. 6. That was a huge tease. So I was really hoping that you could go a little bit deeper today. You hinted that you might be doing another book that is more technical in here. Is Beneath Nox Archaist or something like that? Can you talk about that?
Yes.
Okay.
Yes. So first of all, I just wanted to say, well, thanks for reading the book. I absolutely appreciate that. It was largely, as you saw, it was less of a how to write a 8-bit RPG manual as it was a telling the story of how did this project come together, this 5-year endeavor that it took to develop and deliver Nox Archaist, a game that was on a scale that most people agree exceeded Ultima 5, the last Ultima on the Apple II platform, and had appearances from developers like Richard Garriott and John Romero and Steve Wozniak. Each and many others had little cameos in the game, and so the making a book is like telling okay, so how the heck did all this happen in 2020? That was the focus, and yes, there's 6 pages of tech talk at the end, and there was also I hope you'll agree if you think back on it, there was some kind of smattering of technical stuff throughout the main body as well. But you're right. I mean, ultimately, it was not designed to be a technical manual, and I did tease somewhere in there, like you said, that perhaps someday there will be another book called Beneath Nox Archaist, which is basically the name is an homage to the Apple II technical manual called Beneath DOS, which really goes down to the hardware and talks about the lowest level.
I was thinking it was stuff. I thought it was the Beneath Apple Manor that you were making a reference to.
More people have heard of that than have heard of the technical manual, so I get that a lot.
Okay.
It's I'll just chalk it up as an obscure thing. It's kind of like how in Lord of Storms, everyone assumes that the rod of death is an homage to Ultima 3 because there's a rod of love, soul, moon, and death, and actually the rod of death is an homage to Death Lord, which had a weapon called the Rod of Death. And I was like, I so want to do that. And then had to put a context around it. I'm like, well, let's do this whole love soon moon. I can have some fun with that too. So anyway, I digress. I have a tendency to do that, but
Death Lord is on my bucket list, by the way, to play. I've heard it's the most cruel RPG ever created. So
yeah,
I'm gonna give it a shot.
It has that reputation for sure.
So CRX is a mostly Commodore focused gathering, but what you're doing is you're solving your development problems with 6502 assembly language. That is the language of all the 8-bit Commodore machines.
That is where we come together.
So I'm looking forward to getting some tech details from you that we're missing in the book. If the Commodore folks here learn a little bit about Apple architecture or Apple I/O in the process, that just adds to the fun, in my opinion.
I think this is by far going to be the deepest dive that I've ever taken with anyone on any of this with Nox Archaist. So I'm excited. This is going to be fun. And to that, I guess with that said, I wanted to explain why am I wearing my Lord British Undefeated Nox Archaist shirt. Of course, not exactly as though it was a shirt that needs an explanation. But it fits into the context here quite perfectly, because when I launched the Nox Archaist project in late 2015, first public mention was early 2016. By the time of the first public mention of it, at least, I had crafted a mission statement for the project, and it went off the top of my head. It still exists on the noxarchaist.com website today, but off the top of my head, it goes something like this: we're going to try to explore what might have happened if RPG development had continued at a commercial large scale past the end of the 1980s. Like, let's just pretend that the PC and Mac revolution didn't happen, and development had just continued. What would have happened? Because it was ultimately, there were commercial pressures, market pressures in this change of technology that were huge factors in why companies at one point, in the case of Origin Systems, decided, you know what, Ultima 5 is the last one that we're doing on the Apple II, and the rest are going to be on the IBM PC. The Commodore, of course, did get a Ultima 6 version that,
but
really, from what Commodore folks have told me, really shouldn't have been there in the way that it was.
True.
So there were commercial factors that were driving that decision. And so what I wanted to see is, like, okay, if you pull the commercial factors out of it, how much of the machine was left? How much more could have been done? Because we had seen this decade over the 1980s where the 8-bit systems initially were highly underused in their capacity, because this was a new industry. Developers were just figuring out how to do things. And yeah, over the 10 years, there were a couple of advancements that happened, on the Apple line. It went from the 2 Plus to the 2E for the 8-bits. 2GS doesn't count. That was 16-bit as far as, what I wanted to explore. So there were a couple of shifts up, but nothing that was like really huge. It was still a 1 megahertz 6502 throughout the Apple II 8-bit line. It went from 48K to 128K on the RAM side over that period. But really, I mean, we basically saw, much more so than the hardware was advancing, we saw game development itself was advancing in the techniques and the skill of the developers, both from a design point of view and from a programming point of view. Look at Wizardry 1 or Ultima 1 at the start versus Ultima 5 at the end. I mean, that says it right there. And that had, a whole lot more to do with the change in the design, the development techniques, than it did with any kind of changes on the hardware, which were minimal. So I wanted to explore that and see what would happen, and what was left. And with that being the mission, the logical thing to do was say, okay, so the pinnacle achievement, the height of the art for 8-bit RPGs on the Apple II was Ultima 5. And, well, any 8-bit platform, if you don't count the Ultima 6 Commodore version, that really probably would not be considered as the pinnacle of anything, if what I heard is accurate as far as how it turned out. So I set the baseline at, okay, Ultima 5. That was the top. So to explore what happens next, that means that for the most part, fundamentally, the game I was making needed to at least meet Ultima 5's baseline in everything it was doing, and then reach out forward than that. Now, that's not to say that I set out to make a Ultima 5 clone. I didn't, and the end result, while it is a heavily Ultima inspired game, I mean, it's not like I made a fan game set in Britannia, and literally cloned all of the exact systems with the virtues. And no, that's not what happened in Nox Archaist. The similarity is in, it's a tile-based game. It's a game that has a party of characters. and it has turn-based combat, and there's NPCs that you talk to, and it has a bigature map that you walk around in an overworld, and you enter into towns and castles that bring up, those are the kinds of similarities. So as I looked at Ultima 5, it's like, okay, well, my game needs to have those things, and then look out at, like, okay, well, what's beyond that? So in any event, that was where the project started with it, and as a result, it became an enormous exercise in standing on Richard Garriott's shoulders,
Sure.
To say, okay, what is it that I would expect that he and his team could have done if they made one more iteration, but didn't, because they moved on to something else. And as I thought about things, it's like, okay, so they didn't do this particular thing that I want to do. Is there a technical reason? Is there a roadblock that prevented it? Or is it just that, well, between each Ultima, there was a set of progressions, and at some point, they had to say, this is the scope, and move on. And after Ultima 5 was done, there wasn't another, so they just sort of never got around to it, or maybe, it wasn't the low-hanging fruit as compared to other things. These are the kinds of things that went through my mind for all these years.
Sure.
As I explored, how the envelope could have been pushed. So like I said, it was a big exercise in standing on Richard Garriott's shoulders, a big exercise in, sort of getting into, his head at that time.
That's a fun focus. The Ultima 1, I think, came out in 81, and then Ultima 5 was 88. So there was this rapid fire. Yeah. That is a breakneck speed, but they start to have more time between the releases, and the development team starts to go way up. And it had definitely hit the complexity point in 8-bit space, where I don't think they could have afforded the time to have pushed it on the commercial release cycles. They just had to move to the next boxes anyway. So going back and revisiting what could have been done, algorithmically or whatever, within the constraints of the memory, and with floppy disks having to serve up everything, because you guys stuck with floppies, which is admirable and impressive. So anyway, it's a good mission statement.
Thank you. Yeah, and we're gonna get into the details here. What I want to say in the big picture is, I don't think Ultima 6, as it was done on the IBM platform, I don't think anything that gave that justice could have been done on the Apple II. There wasn't a version of Ultima 6 that was, as many people know, was started on the Apple II, and abandoned at one point. They pulled the plug on it and then moved over to the IBM PC. I don't know how far that got. I do know that theoretically the source code still exists somewhere. I actually talked to Richard Garriott about it and asked him, and he said something to the effect that, he thinks that it probably does, because he's got these boxes and boxes and boxes of floppy disks, like in his basement, that came, from the origin days. And he said something like, back then, I was the version control. Every time, there was an iteration, they'd burn off a copy of floppies, hand them to me, and I'd throw them in these boxes. So probably in there, he said, I'm like, please, preserve this before the floppies die. But that's a whole other thing. So I don't know. And that's going, too far back. I wasn't going to try to torture him to remember the details, but I don't know how far that got, but just based on the experience that I've gone through here now, I think I'm in a pretty good advantage point to know what's possible, on the machine, and I don't think that anything close to Ultima 6, could have been viable. So what we ended up with Nox Archaist was, I believe, a successful mission in pushing the boundaries. And what we ended up with, from as measured by a gameplay technology standpoint, I clock it in. It's somewhere in between Ultima 5 and Ultima 6. Hard to say. It's like, is it kind of in the middle? Is it more towards Ultima 5? Is it? I would say it's definitely not more towards Ultima 6. It's probably in the middle, or maybe still closer to the Ultima 5 end of the spectrum as far as the gameplay tech goes. But that's, obviously that's kind of almost a subjective measure in any event. So what we're going to get into, we keep burying the lead here, but is we're going to talk about some of these specific things that push the envelope, that took it out a bit farther. And so anyway, where should we start on that, Dave? You want to just dive in on one of these tech topics?
So your book talked about a couple of topics. One of them was your pathfinding for your characters. I mean, clearly the characters in Ultima 5 have schedules, in Ultima 6 they have it. You said in your book you went with an A-star search algorithm. You also indicated that didn't become prevalent until the early 90s. So what were the challenges in getting that implemented in your game?
Sure. Yeah. Well, that's a great one. So first of all, NPC schedules. That was something that Ultima 5 had. And so, in the spirit of the mission statement, I thought, okay, Nox Archaist needs to have NPC schedules, because that was a huge innovation between Ultima 4 and Ultima 5. And it's something that Ultima 6 had. So, to achieve the mission, it's like, okay, we need NPC schedules to get to baseline, and then let's see if we can push it a little bit farther in some way. That was the mindset going into that particular project. And now, as far as challenges go, well, first of all, was that to my knowledge, and I'm pretty confident of this, Nox A-star is the first 6502 A-star algorithm ever written in a commercial game. And as a result, had to deal with memory and disk, limitations that were not nearly as much of an issue in the early 90s, when it started to become, commonplace in the more powerful platforms.
Yeah, it'd be interesting to see how the SSI. I never liked the hex-based war games, but they had to have something to pathfind on those too. It'd be interesting to see how they did that. But anyway, go ahead.
Yeah, there's a variety of ways to approach pathfinding, and actually I intended to touch on this a little bit as well. So essentially, a couple of the ways is you can hard code the coordinates. Simple as that, and you just got coordinate data that gets fed into a movement engine. That's very disk heavy. And the memory side, you could maybe buffer some of it in and out depending on your disk access speed, but definitely very disk heavy. If you're talking about long distance paths, if you're talking about moving 10 tiles, 5 tiles, it depends on the length of the path, but the longer the path, the more the data, et cetera, et cetera. And then what I was looking at in Nox Archaist was, 32 by 32 town map, like, okay, we're, got to transit from one side to the other, which was comparable to what was going on in Ultima 5 in terms of path link. So that's one way to do it. Another way to do it is record flocking points. And a flocking point would be like your basic NPC/mob movement algorithm in an 8-bit RPG is something that I call a magnet algorithm. I literally think I made that term up because I didn't see it anywhere and I needed something to call it. But it's basically like you got the player in the center of the screen, and you've got like a mob or an NPC somewhere else, and the algorithm runs for moving that. I'm just going to say NPC to encompass mobs as well as the friendly ones. And there's an algorithm run that basically says like, okay, compare the XY coordinates of the NPC to the XY coordinates of the player, and if X is for the NPC is less than X for the player, okay, well then take a move towards the player, or Y is less than, do the opposite. And whether you check X first or Y first is going to cause a predictable, like, well, if they can, they always go this way first. And with that, if they're just two fixed points on the screen, the NPC can just find their way there. works perfectly, except for when there's an obstacle in the way. Now, here's where I need 3 hands. If there was an obstacle here, you got a wall, you got a mountain. If the obstacle is more than like 1 tile wide, eventually, the NPC is going to get caught on that, and it's going to move to the left, and it's going to move to the right, and it's never going to find its way around. I mean, we've seen this in like Ultima 3, but or also Ultima 4. But I remember I played Ultima 3 a lot, where you can see it happening. When you're hiding from the guards, and they're just on the other side of this wall, and they'll just go up and down, up and down.
It was a game mechanic that we exploited. Yeah,
absolutely. So that's like the magnet algorithm. So the flocking point method of pathfinding is you manually, as the designer, define a handful of different flocking points along the path from point A to point B, and you design them with obstacles in mind, so that the NPC basically has 1 flocking point active at a time. And flocking point 1, okay, so they're going to magnet algorithm their way over to flocking point 1. Then okay, flocking point 1 is reached, so then in its data table for flocking point, it'll switch over to flocking point 2, and then the NPC will magnet algorithm over to flocking point 2. So you've got to design your map and pick your flocking points in a way so that the NPC can find its way around the obstacles, which it's a lot more difficult on the design side. It also, there's disk space involved there, because you got to store these data points for the flocking points and things like that. Those are the 2 I'm thinking of off the top of my head. We kind of talked about 3 there, actually. There's quite possibly some ones that I'm not thinking about, and then there's A star, or something A star like, which is based on you've got your source point, your destination point, and you essentially call the algorithm, you give it the source and the destination, and then the algorithm crawls around the map building a database of coordinates, and it figures it out. And after it figures it out and locks in a final path, then that final path can be stored in memory somewhere, and then the database gets flushed. Really, data tables, database is certainly more glorified than what it actually is. The data tables get flushed, and the algorithm can then calculate on a different set of coordinates. So that approach, what I saw with that was when evaluating these options, was that, okay, well, that's going to be CPU intense doing these calculations. When's that going to happen? They're not going to be fast, and it's going to be memory intensive, because you need to have these data tables for building up the path coordinates as the algorithm's crawling around and figuring it all out. So as was typical in many design decisions in Nox Archaist in this kind of game, it wasn't necessarily clear at the front end. It's like, okay, I see a couple of different solutions here, and there's trade-offs to both, from a memory disk CPU perspective. And I had to think about those trade-offs, think about it in the context of the game engine as it already existed, because this wasn't the first thing that was done. By the time I was doing Nox A-Star or dealing with the pathfinding, I already had basically the graphics engine was already stood up. We could walk around the map, we could even enter towns, and I think that was the extent of it. And then the pathfinding came in, but there were big chunks that were already laid there. So I had to look at what memory was already spoken for, and sure. All those things kind of played into it. And then I also considered, like, okay, well, which path is most likely to create a scenario where I can push the envelope and do something a little.
How long are these paths that you're considering? It's easier to do a shorter path, obviously, right, from a memory perspective. So as you're figuring out your memory budget, you're probably also figuring out the maximum length a character can walk a path as well, right?
Yeah, well, right. And the I wanted to be able to go from one corner of a town to another on a 32 by 32 map.
Ooh. Okay, that's a lot of memory.
Yeah,
my,
that's my memory.
I did a Python A-star thing at one time, and an A-star search, and there's a lot of variation in how people do this. So mine was just, evaluating cost to move plus distance to location, and it starts to just fill everything, but it's always picking the lowest cost with like a min heap or a priority queue or whatever, however you implement it.
Yep. Yep.
That was probably challenging to make keep a min heap tree in 650 coin, right? Or did you do it differently?
So much of this was a hack.
Okay, good. That's how it should be.
That's what that's why I say Nox A-star is an A-star-esque algorithm, because to get the functionality I wanted, to do it actually, following like proper A-star design, it wouldn't have been able to have been done on the Apple II with the memory limitations. So what we have is A-star-esque in the sense of, okay, well, it's pathfinding. It's an algorithm that tells you the path between 2 points. It tells you, so that's an important characteristic of an A-star. It does it by crawling around the map based on some criteria and building a table of coordinates. That's very A-star. But some of the details of exactly how does it make its decisions, that's where it gets a bit hacky. Like, for example, I would love to have done it where it's like, okay, all terrain has different weights and it considers that when it's deciding, and all, which something by the point you get to Sid Meier's Civilization 1 in the early 1990s, it was doing that. But that was on the IBM PC. Yep. So, they built Rome on 640K a day is what, the book said there. So we're talking about 128 in a 1 megahertz processor. So nope, that wasn't happening. But what I did is I hacked in some logic that basically said when it's evaluating the coordinates, because at any given point, it's and the brain of the algorithm is in one tile, and it's looking at 4 different options fundamentally as to where it's going to move the algorithm brain to next. Without going back to the database saying I'm stuck, I've got to start over somewhere else, because it can crawl itself into a dead end, and then none of the 4 options are good, and then it has to parse the table and get back to a logical start to re-exploring. But setting that aside, when it's doing its thing, and what I call the algorithm brain is crawling around, and okay, so it's evaluating its 4 options. Well, first of all, it's not going to take the one that was the last tile it evaluated. It's not won't do that, throws that one out, because that's where it came from. And imagine the algorithm brain is like an NPC walking. Imagine it that way, and if you're walking down a path, if you've got three options, directions that are open, then there's no reason that you're going to go back the way that you came yet. So it throws out the direction it came from. So then it's down to 3 options. And then what I hacked in with some logic that basically said, if one of those options is a road tile or a floor tile, take that one just instantly. The first road or floor tile, it finds, and it does it in like a north, south, east, west, kind of clockwise evaluation. It's going to take that tile because chances are a road or floor is going to lead somewhere. Whereas if it starts wandering off on the grass or, trees or some of this other terrain, who knows where it's going, Did
you ever find yourself putting a non-road tile someplace just to force a character not to explore in its A-star time a certain direction?
No, I never did anything like that. But yeah, I mean, there could have been some. There certainly could have fooled with the behavior of it that way for sure. Yeah, so that was the way of hacking in the most important part of the functionality, because the key that I was solving to there was, if in order to get a path that could be calculated from one corner of the map to the other, or close to it. Actually, I only got it to be like 3/4 of the way was the max distance, but it was close enough that from a design standpoint, it rarely was a problem. but to get, I didn't get there right away. You know, for the early iterations, it was nowhere close to that. And this hack was one of the key things in getting there, because if I let the algorithm just wander wherever without any cost weighting, it would run out of memory in the tables before it figured out how to get to the path in anything but the shortest most paths. So that's what I was trying to solve to, but recognize that there isn't memory to actually do terrain weighting in any sort of a proper way. And this hack to go in there and basically, you know, just say, okay, if it's floor or road, go with that.
Sure.
That hack was enough to be able to get it efficiently moving towards the, you know, the destination enough to get the, you know, the ability to calculate that total pass, along with other. I mean, there were other optimizations needed to get that too, but this was a big one for sure.
You know, your book, I think it was your book, or maybe I heard you say this someplace else. It takes a lot of time to compute this. So you have to actually compute this in the background as the player is waiting to move and do other stuff. Which how could it be otherwise? But that's also sounds challenging to put together.
Yeah, that's exactly correct. And that was one of the things that it was not in the early iterations. You know, this was solving to the CPU limitation. I had to basically design the A-star algorithm as a recursive subroutine, so that it could get interrupted by the game loop when a key was pressed, and then kind of, you know, like get called back, you know, to where it was, and some goofy stuff like that. And the way I set it up was that it was guaranteed on every iteration of the game loop, and it calls A-star. Would always calculate 2 path coordinates on whatever the current path was that it was working on, just to make sure that something got done. So like if the player was holding down the movement key, I wanted to make sure that each time a little bit got done. But after the two iterations went, then the code logic opened it up to say, hey, if it you know, it pulled you know, the keyboard strobe on C000, you know, it just does an LDA C000, and if the value there, you know, it's like if the negative, the value is negative, that means key press, and then it would exit out back to the game loop and let the player do what they were doing. And so as a result, there's a big variability in what happens with the pathfinding, depending on, you know, when do you enter the town and what are you doing when you get there. Everything is based off of like the top of the hour. NPCs are supposed to be at their assigned anchors at the top of the hour, and they stay there until the top of the next hour. So if you enter the town at the top of the hour at 00 minutes, then, you know, there are 60 game minutes, and I think it's like 2 turns per minute. I had to dial that in too. For the A-star was what drove that. It's like, so how many moves can you make for 1 minute on the clock? And because we're doing this in these hour intervals, so it ended up being like 2 turns, two tile moves per game minute. So we got 60 minutes times 2, and so that's 120. And there's a minimum of two you know, tiles on a path calculated each time. So that's 240. So if the player enters at the top of the hour, that's like the minimum amount of time that's there for A-star to calculate a path if the player is holding down the movement key the entire time. If they let off on that because they're looking at the pretty lake, or, you know, saying like, wow, was that a cow over there? What, you know, and they're not, and their finger's not on the movement key, then there's tons more time.
Sure.
So the end result is, as a practical matter, you come in at the top of the hour, and A-star it's going to have enough time in any practical scenario to calculate through the pass that it needs for it's calculating for the hour that's coming up.
Yeah.
Who's going to move in the next hour, and there's usually going to be three or four transits per hour in a big town, and they can usually get through those if you enter the town at the top of the hour. Or a little bit after, wherever. The other extreme is like, okay, you come in and it's like, you know, 11:50 a.m. It's probably not going to have those calculations done by the time the clock strikes 12. And the way the game handles that is an NPC that's scheduled to transit, whose path isn't done, basically just ignores it. It continues to do basically a random movement algorithm around its anchor point, just like it normally does.
Yeah.
And it just continues in that mode until its path is done. And once its path is done, no matter what time it is, it then executes off of that path. So it will happen eventually. And I thought,
That's cool.
okay, so here, just simply by going down this path, I found a limitation that was actually a feature and a way to push things, in ahead from a gameplay perspective, because essentially what all this means, I'm showing you behind the curtain, but from a gameplay perspective, what this feels like is there's a little bit of randomness to how NPCs move.
That's good.
Maybe the merchant, doesn't show up on time and like, oh boy, what happened? Did he stop at the pub and
except for that one guard that had me stumped. You have a guard in some place which is blocking me, and he's there all for like 1 hour. I can't remember. It took me forever to figure that out. So there's nothing random about that. There is only one little time where he's gone and you can walk that path. You know what I'm talking about, right?
Yeah, your Herad keep.
Yeah,
probably. Yeah,
Sorry,
that was part of the puzzle. Where it's a particular particular reason for it, but in general, there's this randomness that gets in there, and now let's compare to baseline. And this actually this touches on something else I wanted to. So one of the fun things that I got to do during development of the Archaist algorithm is of course I had to learn more about how pathfinding was done in different games, and more specifically Ultima 5. Since the goal was kind of like, okay, well, let's move beyond that. That was the pathfinding example in a in an RPG at that point. So I spent a lot of time dinkering around in Ultima 5 and basically harassing NPCs. I would I would figure out, okay, so here's the merchant's house and here's the merchant's shop, here's the path they take, and I would like stand in the path of that merchant and block them just to see, would they go around me, what would they do? And no, they would stand there until you ran out of food and died, if you blocked the path. And I noticed that they always did it at the exact same time of day. There was no variance in it at all. And they always and they never moved around the player. Those were the characteristics that I noticed, as well as that if you barricaded the inn, where you got the innkeeper, if you barricade the inn with tables by pushing them around so that they can't get out, they basically can't get out. There's no way, they'll be trapped. But if you like wait for a while, to wait, it's like there needs to be a bed nearby. So I had to do this in a specific location, where I could like trap the merchant and then go, sleep for a few hours in a bed and then come back and see, oh, he had disappeared. He magically had, reappeared where he was supposed to reappear. So I was like gathering like all these characteristics of this, and concluded that likely what Ultima 5 was doing for pathfinding was hard-coded coordinates. Because if it was flocking points, they would have moved around me when I was blocking them. So it was, I think, likely hard-coded coordinates, which is disk heavy, and that can be shortened up by the length of the paths. I wasn't seeing NPCs going from corner A to corner B. They were much shorter, which would lessen the disk requirements. And then additionally, ultimately, everything's a trade-off. You can allocate more disk to storing more coordinates if you have less of something else, and there's all sorts of little micro decisions like that go on in there. But I have not looked at the source code to, to confirm this, but I think that that's how Ultima 5 probably did it, was hard-coded coordinates. In any event, so going down the A-star path, when I noticed, what I was wrangling with, what first I was thinking, this limitation, it's like, well, but if the player walks in at 1150, you're going to have NPCs that aren't transiting when they normally would. And then I thought, well, wait a minute, no, this is going to introduce some randomness to it. So that's really the and there's a couple other examples of it, but the one of the sort of pushing the envelope forward things about the Nox pathfinding is that NPCs do not transit necessarily always at the same time, which you can imagine creatively, as far as like, well, did they sleep in? Did the merchant stop off at the pub on the way in? Or there's a variety of things that you can imagine around that, which are fun. Having this little extra randomness in there. And then additionally, another way was that inspired by my harassment of NPCs in Ultima 5, where they would just, you're blocking their path, and they'll just come up to you and stand there. They will never move around you. They will never say anything. They'll never do anything. So I wrote some code in Nox Archaist to detect that condition, and number one, have the A-star instead of just, because we're now in the movement engine, and it's basically reading off the final path stored in memory somewhere that A-star calculated. So the movement engine, when it's basically just peeling off the coordinates one by one that A-star had provided, if it detects that it's blocked, and it's blocked by the player or another NPC or something like that, because theoretically it should never be blocked by a wall or something like that. But it's basically, if it's blocked, it then deploys a flocking point algorithm. It like sets a flocking point a couple of tiles ahead on the predetermined A-star path. It'll just like skip X register index +3, sort of thing.
Yeah.
Grab, the path coordinates, three increments down, declare that that's a flocking point, and then it'll move based on a magnet algorithm to that flocking point, which means that if the player is one tile, an NPC is one tile, and a magnet algorithm to a flocking point can figure out how to get around a one tile obstacle, because it's going to, even if you're on the same north-south axis, a magnet algorithm is smart enough to decide, okay, I'm where I need to be north-south, but I'm blocked, so I'm either going to move to the east or to the west and hope that my way is clear in one of those two. It can figure that out. Now, the player can be a real wise ass and say, okay, the NPC moved, to the east to try to get around me. Well, I'm going to move to the east too.
Yeah.
And then the NPC is going to move to the west. Well, I'm going to move to the west too. And I anticipated this because I thought this is exactly what I would do, in the spirit of how much fun I had harassing NPCs in Ultima 5. So I wrote some code to detect player harassment as defined by that pattern. It basically just tallies the number of times in a row, that the player was blocking them. And if it gets to like 3 or something, then it basically prints some text.
Yeah.
And the first text that I have a screenshot of this somewhere, was "beat it or I'll call the brute squad."
Yeah. Oh yeah. Everybody encounters that. The annoyed text. That's a great feature.
I changed it to something else, but you did encounter that? Did you say?
Yeah, I did counter text. I don't know if it's that exact phrase. It's been a couple of years, but yeah. Yeah, no, that's very cool.
Yeah, I don't know the exact phrase either, but yeah.
You were saying like you're indexing your X register, you just go forward a couple times. I assume this means that you don't have any pathfinding at all in your gigantic 256 by 256 dungeons, right? Because that's that's too big, right? You said 32 by 32 earlier, so there's no pathfinding
Correct.
in the large dungeons. Okay, that makes sense. For those who don't know,
But
the
there's a
size of
but.
the overworld in Ultima 4 was 256 squared. That could be just a dungeon level in Nox Archaeist. So it is a big, big game. Anyway.
Yeah, absolutely. And everything you said is accurate, and I won't give too much. I want to give too much away here. I will say that there are a couple of areas in the underworld, or dungeon levels, if you will, where we're 256 by 256 maps. There are a couple areas where pathfinding does occur with A-Star, and the way that I did that is there is a tile set. There is a special small map tile set, 32 by 32 map tile set that is used just for a couple of areas in the underworld where I basically embedded small 32 by 32 maps within the big 256 by 256. And I mean, they're technically all separate maps, but because it's a special tile set, when I was in the 32 by 32 map, I had access to stuff like cavern walls and cavern floor. Okay. So I make it look like you basically cross a transition point walking down a cavern hallway, and you hit a transition point, and it actually takes you into a 32 by 32 map.
Okay.
Which has which basically has the town engine running, and it has A-Star and all the other capabilities, but it still looks like you're in the cavernous, underworld environment, which means I could then place NPCs and make them transit around. And if I tell you the area that does this, you'll remember, but I don't want to spoil it for anybody.
While we're talking about these giant levels, you mentioned in your book, again, getting back to this book, your viewport, I think is what you called it, the portion of the playfield screen that is dedicated to drawing tiles as opposed to the portion of the screen that's displaying statistics and things like that. And clearly, the larger that gets, the slower it is to update. And you have a 11 by 17 tile set dimensionality to that. And apparently it was challenging to get that to go fast enough. Can we pivot over to what kind of challenges you had and how you solved that? Because that's sure. I've seen a lot of games, and some of them have very tiny ones as well, and they're picked that way specifically for performance reasons. And you have a gigantic one. So how do you get that to go efficiently?
Yeah, that's in fact, if I could, why don't I just boot up Nox Archaeist quick and show the size of the screen. I think
let's hope this works. So there you go, you got the screen up.
Yeah, so just to illustrate here, so this is 11 tiles deep by 17 tiles wide, and there's basically the only amount of the screen that is not used for the tile map is 2 tile widths here on the very far right for a little bit of information. And as David was saying, what was typical in the RPGs of the day would be they would have something. Actually, probably one of the larger would be Ultima had 11 by 9, so the same depth, but width would only come over maybe about more like half of the way. And then the remainder of the screen, that's where you had your character stats and a little scrolling text window, things like that. Some games even went further with it, where it was just like a viewport in like a square in the upper left. The Nox Archaeist was able to. One question might be is like, okay, well, where's the where's the stats information and all that kind of stuff. And that's another topic we're going to get into. So trust that there is an elegant way that's handled. But talking about the technical topic, David, that you had raised is like, okay, so there's a lot more CPU intensity, to what's going on here with a map this size, because every time the player moves, do we have sound? I don't know if sound's going to come through, but why not? Every time the player moves, all those graphics need to move, somehow or another, as well as animation is running. There's just a lot more. The more bigger the viewport of the map, the more that's going on. So yeah, this definitely was a challenge, and there were several. I wrote a couple. I know I rewrote the graphics engine top to bottom at least once.
Sure.
And then there were several optimizations that I did along the path to get here. One of them was, and this one I would not call like a first by any means. One was, instead of redrawing the screen every time that the player moves, instead basically do a direct copy in video memory and scroll the data in video memory either up, down, left, or right, and then only draw a row or a column of tiles that's on the edge of the screen in the direction that the player is moving. Yeah. And I know that's that's been done before, but that was definitely something where it's like I didn't have that in initially, and it was like really painfully slow drawing the screen every time. So I got the screen scrolling in there, and at that point it was like how I would describe it, that it was in a state where it wasn't as crisp as Ultima. You could feel a little bit of lag, and and from a modern standpoint, I mean, there's like people that on Steam that play this game that never played games back in the 80s, but are into retro stuff for one reason or another. Maybe they came in the 90s or whatever. They play it, and to them it still feels laggy because they're used to much more modern system response times. But Ultima 5 was my baseline, and it was like what I was aiming for was bigger map viewport, because that's new, that's innovative, that hadn't been done. But it's like no, it's got to still be at least as fast when you move as Ultima 5, or mission wasn't totally accomplished there. That was kind of the thing. So when I got the screen scrolling part of it dealt with with the video memory copy, it was no longer like, okay, you look at your watch as the screen draws, but it still felt laggy as compared to Ultima 5. It was actually kind of later in the process when this happened. It was a teammate of mine that really pointed that out, and I said, hey, this really, can we do some more on this, because it's really just not quite there. And I'm like, I'm focusing on like 10 different things at that time, and come back to this problem. And it's like, okay, so what can we do on speed? And what the final piece of the puzzle was is I counted the clock cycles for the screen scrolling loop. I mean, I literally printed out the source code, and for every opcode wrote down the number of clock cycles on each opcode, taking into consideration whether a page boundary was crossed, or was it an absolute or an immediate mode opcode form, all of that, and wrote down the number of clock cycles, added them up, and the total number of clock cycles was something like 500,000, 600,000, something. I don't remember the exact number, and it's I don't know if I've ever talked about this in an interview, but I know I've talked with individual people about it. I whatever number I give is probably give or take 100,000 in either direction on it, but it was somewhere approaching of like, okay, we're talking about a half second here, because 1 megahertz CPU, 100,000 clock or a million clock cycles per second. We're talking about approximately a half second is going by, just when you move, and that's noticeable. By 8-bit standards is noticeable next to Ultima 5, So my mission, of course, was, okay, how can we cut clock cycles? And, you know, there's a little bit of nibbling around the edges that I did and this and that, but here was the big one. Ultimately, a screen scrolling routine that's doing these video memory copies is a series of nested loops. If it's not, unless it's unrolled.
Sure.
You know, you could unroll all the loops, and that's one way to get
You don't
some
have the
speed,
space
but
for that.
that would absolutely have blown up the memory requirements
exactly.
to a point that it's we're writing a tech demo at that point, you know, of like, how fast can we make a map scroll, you know, as opposed to actually, you know, we got to have room for the game somewhere. So unrolling the loops was out, and unless we unrolled, you know, you could say, well, could you unroll part of them or this? Yeah, there wasn't really a good sweet spot doing some kind of a doing it half-assed as opposed to full-assed on the unroll side. So what I found though, but doing this analysis though, this clock cycle analysis, what it illustrated for me though was just the sheer number of nested loops that I had. Because when you get right down to it, when that video memory copy is happening, you know, you're only copying 1 byte at a time.
Yeah.
You know, so you ultimately have a routine. The lowest level loop is basically copying like a tile's worth of bytes or something, and maybe it was only a half a tile, may have even been less than that. Obviously, we're going to copy more than 1 byte at a time. We're going to copy some series, and that's the lowest level loop. And it was either a tile's worth or half a tile's worth, something like that. And then above that, the next level loop. Let's just say it was a tile that we were copying. The next level above that is like, okay, it is going to be a loop that's calling that, you know, copy the video memory for a tile over and over again until we've copied a column or we've copied a row of tiles. And then above that is going to be, okay, well, we're going to do, you know, a screen of tiles, or we're going to do a screen of tiles from, you know, there were some variances depending on whether you were moving north, south, east, or west as far as what was being copied, and some things like that. So we end up with, you know, nested loops. So I go down to that very bottom nested loop, the one that's copying like a tile or maybe half a tile's worth of screen bytes. And a tile, you know, we're talking about 32 bytes of memory is a tile, is how it's positioned on the Apple II. And this is for 14 pixels by 16 pixels is 32 bytes. Why 14 and not 16? Well, that's because of the Apple has a color bit as bit 7. So you got horizontally, you got 2 of those, you know, your 2 screen byte wides on a tile, you lose 2 bytes to the color bit, so you got 14 pixels by 16, but it's still 32 bytes to make that up. Anyway, so the loop that is doing that copy, what I you know, basically theorized and then implemented was, I'm like, well, what if we do some self-modifying code here? And instead of having traditional loop overhead where we've got a loop counter and then we're checking the loop counter, and based on the value of the loop counter, then we're branching to the top of the loop, you know, that takes, you know, a handful of clock cycles to do that. And instead of that loop overhead, what I did instead was did some self-modifying code so that basically it would not have to increment the memory address that it was writing to, because the STA opcode plus address, and basically instead of the loop overhead to deal with that, I would just like modify the address in memory that the STA is writing to.
Yeah, that's pretty frequent. You'll be like, am I going to do this as this level of indirection in 0 page, or am I going to do self-modifying code? And you always have to make the call each time.
Yeah. And any, you know, obviously you and any your viewers that are intimately familiar with 6502 know exactly what I'm talking about with the self-modifying code. Just wanted to, you know, round it out for all listeners, wanted to give a little bit of context around it.
Is the
And,
overworld all in memory at once, or are you bringing it in as you're moving around? I assume you're bringing it in, right? The overworld.
I'm sorry. Can you repeat that?
The overworld itself, are you bringing that in as you move around, or is it all? It's not all in memory at one time, right?
Yeah. So that's a great question, and I just want to finish off one thing.
I'm sorry. Go ahead. Yeah.
And then we'll dive into that. So just wanted to say that so that was the modification of the self-modifying code at the bottom nested loop in the stack of nested loops. And even though it only shaved off a couple clock cycles, literally just like something like 2-3 clock cycles, from the iteration of that loop, it was like that loop took like 12 clock cycles, that bottom loop, and then after the self-modifying code, it was like 9 or 10 clock cycles. So it was 2 or 3 clock cycles per iteration of the bottom loop, which means the savings was 2 or 3 clock cycles times, well, how many times is that loop called? Yeah. And it's called a whole bazillion times. And the end result is we go from something like 500,000 or 600,000 clock cycles on the screen scrolling down to something like 200,000 or 300,000. Again, I'm probably off by plus or minus 100,000, but it was just a huge chunk that just bam got knocked out of there. Yep. And at that point, you know, even with this huge map compared to what was typically done, we were getting this real nice crisp movement rate. So for example, so the overworld is 256 by 256, and it is broken down into zones that are 16 by 16 tiles each. And there's a regional map that consists of 9 zones. So it's like, in other words, it's like 3 zones by 3 zones. You're in the center, and then there's 3 zones above you, 3 zones below you, 1 zone to the east, 1 zone to the west. That's the regional map. And so that's enough that you can never well, it's enough to make it so that you can never see off it. What ends up happening is that to put a button on your original question is, so that regional map is the only thing that's in memory. The rest is on disk. The map data is read off of disk in a compressed format, and it gets 9 zones get read in, and each zone as it comes in gets uncompressed, put somewhere in memory. So the end result is 9 uncompressed zones in memory.
So I got a trade-off question for you on that then. In your book, you're saying you're using ZX7. I had to go look that up. Apparently that came out of the ZX Spectrum world. They've been doing that. It's an LZ derivative. And so if you're compressing map data, I could see that having to decompress it slows you down, but also having fewer bytes to read off of disk speeds it up. So I imagine the I/O having to read less is the greater savings than the cost of having to decompress a memory, and overall you win with the compression from a performance, not just a storage perspective as you're moving around. Is that true, or did you measure that trade-off?
Yeah, that's true. Especially when we're talking about floppy. You know, that's slow access time on floppy. Yeah, you want to get that data down as small as possible, and the CPU overhead to run the uncompressed. Yeah, it was a good trade-off from a CPU perspective and a win on this perspective. So yeah, for sure. And the last, as long as we're on the subject, the last thing I was going to mention is in this regional map of 3 by 3 zones, and the players in the middle. As the player moves, their position floats within the regional map, and until they get to a certain point, there's like a rectangle or a square inside of this 3 by 3 zone map, where if you go past the edge of that threshold, then you trigger a zone transition and a new set of zones is loaded into memory, and the zones that you're in get shuffled down in this 3x3 map. It's essentially scrolling the zones, and so that you never look off the edge of the map data. Because if you look off the edge of the map data in a 8-bit tile RPG, you see a bunch of random tiles, which many of us have seen, like when a game crashes, or you put the wrong disk in the drive on some of the early games, and like Ultima 4, you put walking around in Britannia, put in the underworld disk, and all of a sudden you see this collage of tiles that appear in the game in some insane order.
That was a great way to get special items in Bard's Tale in the store. She just throwing a different disc. Yeah.
Right. Yeah, because it could be anything, and what you're seeing there is a graphical expression of the hex values in a part of memory that the game did not intend to be map data. It's just, it could be part of the program, but and that never happens in a properly functioning game in Nox Archaist, for example, because there's these zone transition boundaries that are set up that once you cross that, it refreshes the regional map in memory, shuffles you around, you never see it, etc. So, and even on floppy disk, when that zone transition happens, even on floppy disk, you don't notice any lag. You just briefly, there'll be a hit to the disk, you'll hear it, you'll see the light flash, but it doesn't really interrupt the speed that you're moving around.
Topic to put on the stack, because I know you may not be finished with this one, just so we don't forget.
Oh, I am.
Okay.
I'm done.
So you had to stream a couple of things. I say stream, I mean the appearance of low latency as something is retrieved from the floppy disk. Some of your spell effects or something had to be very quickly streamed from the floppy disk. Is that right? Or is that not the case? Okay.
Yeah, that's absolutely correct.
And you had to do all kinds of custom floppy disk controller stuff for this game as well. Do you want to talk a little bit about that, or? Okay.
Yeah, sure, absolutely. The Apple II floppy disk drive, as I understand it, is notably faster in disk access than the Commodore floppy disk drive. Even so, it was still a significant bottleneck from a development standpoint in what could be done. And when Nox Archaist started out, I was doing things in a fairly I guess conventional way, and I want to point out at this point that if I remember correctly, the Commodore disk drive has a disk controller like built onto the drive.
Yeah, it has its own 6502 processor on the drive, so you can send it arbitrary code to execute in parallel and independent of the Commodore, yet still be able to coordinate, which was at the heart of some interesting copy protection schemes at one point.
I bet, exactly. So on the Apple II, it does not have that. There is no hardware disk controller on the floppy drive. There is no second 6502 processor on there. None of that. So essentially, the drive controller is a piece of software in the Apple II's memory, and that interacts with the hardware. Which, to your point, there was a lot of interesting copy protection that was done based around all of that going on. So basically, the like Commodore games, I would expect, large commercial scale Apple II games in the 1980s did not use an operating system. They kicked the operating system out of memory and used a bootloader to run the game on bare metal. And that's exactly how Nox Archaist works. And when I somewhere probably in the first year of the project, I know in the first year, initially in the first year of the project, I actually was running it through DOS, but I knew that wasn't ultimately going to cut it, because of knowing how it was done. and so I set out to write a bootloader to kick DOS out of memory and get to that level of functionality. And that was a really interesting and fun project because at the time, I didn't really know anybody in the Apple II community, and there are a few people out there in the Apple II community that know how to do that kind of programming, but I didn't know they existed. I didn't know who they were, and I was like literally spelunking through old news group postings from CompuServe, dated 1990, 1989, which were all rolled into Google Groups, and I'm like spelunking through these things, picking up little bits of information on like what's an Apple II ROM, how does it do the handoff to essentially code on a floppy disk, and then what does that code need to do, and essentially the bootstrapping process, which I don't know how it works on the Commodore side, but I'm guessing it's probably fairly similar, where ROM is going to read track 0, sector 0, one spot on a small amount of data off a disk. It's going to read that into memory, and whatever's in that spot of memory better be able to take it from there. And so the code that you put in track 0, sector 0 is basically just enough code to like read in another sector, and it can't be more than that because of some reason that I don't remember. And then you like read in another sector, and then that gets you enough code so that, all right, now you've got enough of a disk controller to be able to read in multiple sectors at a time. And you just you're just in these stages, you're reading in bits and pieces of a disk controller until you finally get to a point that you've got a fully functioning disk controller, and then you can actually read in whatever you want, such as the game loader, and actually get down to the business of getting the game in memory. And there's all these different steps to it, and I figured out how to piece that together. From
we don't have any of that, so it's interesting to hear about it. So anyway, keep going.
Oh, okay. So you get to skip all that fun.
Oh yeah, there's no DOS on the disk.
So in any event, I got that far with it, basically to the level that the 1980s games were on the Apple II for the most part. And it was used in the disk controller code that I was bootstrapping into memory. I had to write some, little customizations and massages of it to get it all to line up right, so to speak. But the final code that was in there, like the full disk controller, that was basically like a disk controller that Steve Wozniak wrote in 1979. But I couldn't start with that. I had to break it down into these small chunks to do these different stages, and that's where the kind of the technical complexity came in of coding this without a roadmap. But anyway, the end result was this basically Steve Wozniak 1979 disk controller that was like what all Apple II games were using, so comparable performance, etc. And that was pretty much how I was intending on rolling with it. And then I met up with somebody who goes by the alias Cucumba. And
It is cucumber.
Yes, that's his little joke with it. Is
that guy is bright, by the way. I was when I was working on my 6502 book, a lot of value when he proved that for me. So yeah, you got a smart one there.
Yeah, he is, and it's not just me saying this. He has been referred to as basically one of the best 6502 assembly language programmers in the world ever. It would probably take like John Carmack or Becky Berger or Woz himself to give him a run. He just like thinks like the computer. He can run a 6502 assembly, complex 6502 program in his head, tracking the register values and the memory values and the bit flips, and come up with a result on the end and convert it from hex to decimal on the fly. And And I actually saw him doing that once at Kansas Fest at a copy protection cracking session that he and 4AM, another famous Apple II hacker, were doing. And it was it was just like watching him do it was a work of art. And somebody figured out what Peter was doing. Peter's his real name, Kikuma's real name. Figured out what he was doing, running the program in his head and doing these conversions. And he was like, giving audibles to 4AM, as he was looking at his console that 4AM was using to inform what he was doing. Someone figured out what he was doing. I didn't quite catch it. He said, like, Peter, did you just, run the program in your head and convert the hex to decimal and flip it around and spit it out back the other? And he's just kind of a shy, quiet guy by nature. And so he didn't say anything. He just kind of smiled as if to say, like, well, what, is there another way to do it? So anyway, I eventually meet Kikuma, and he suggested, well, I could write a ProDOS driver for your game so that you could run the whole thing on ProDOS, and then you could use hard drive disk images, not just floppy, and there'd be all these benefits and all that. And at this point, I knew his reputation because we're on CompSys Apple II, where the best of the best Apple II hackers kind of hang out. And I knew him by reputation, like, okay, this is a serious guy. Didn't fully understand yet quite how brilliant he was, but and he's making this proposal. And at first I'm thinking, like, how can that possibly work? ProDOS, takes up this huge chunk of memory. It's basically as big as regular DOS. There's no way that there's room in memory for that. Unless you design the game around it to begin with, but then that's trade-offs. You're giving up something else, and the games back in the day didn't have the operating system in memory, so that's not a trade-off I want to make. And eventually I but knowing his reputation, I agreed to, like, okay, let's talk about it. And eventually I figured out that actually, no, he wasn't talking about having the ProDOS operating system in memory. He was talking about something else entirely that I knew a little bit about from reading the book Beneath DOS, the one that is the, Beneath Nox Archaist would be the homage to. And Beneath DOS talks about basically how does DOS interface with the hardware. And as a result, it's basically telling you, like, well, if you wanted to interface directly with the hardware, here's in theory how you would do it. And I say theory for a reason. So, for example, it's got a chapter that talks about how a bunch of what they call latch toggles work for the floppy disk drive, which are basically soft switches in memory up in ROM. That it's if you do like an LDA or STA to one of these addresses, these soft switch addresses, that something happens because the computer.
If you strobe the I/O register that is memory mapped, you get in effect irrespective of whatever the operand was with the instruction. Exactly. Yeah.
So on the Apple II, there's a series of these soft switches in memory that are essentially it is the software interface point to the hardware that was built in by the hardware designers. It's like, we're exposing the hardware to you in the form of these dozen or so soft switch addresses. That's basically how it works with all of the Apple II hardware on some level, is it's all exposed through soft switches, or in the case of video memory, there's just a chunk of memory that's reserved. That's like the hardware is connected to it, and whatever you put there is interpreted as values that the hardware runs out the video port. But anyway, so for the disk drive, since the controller is software, these latch toggles. The book calls them latch toggles.
Yeah, no problem. Yeah.
soft switches, latch toggles, treat those as the same thing synonymously, because they are. So the book talks about essentially using these soft switches to do things like power up the drive motor on the floppy drive and then move the drive arm, stop the drive arm from moving, and it takes a bit for it to slow down and actually land somewhere.
Yep.
And if you forget where the software, if you forget where the drive arm is, then here's a latch toggle to tell the drive arm to go bang against the side of the disk case, which makes the grinding noise, that we've all heard on the Apple II. I assume Commodore disk. Maybe they don't. Do they?
No, oh, we do. We got the grind noise.
They do. So I imagine it's for a similar reason. On the Apple II, it's the software has told the disk controller software has told the drive arm to basically move until it hits the edge of the drive case, because then it knows where it is, and then it can find track 0 from there, sort of thing. So this is the granular level that you have to interface with the disk drive at a software level in the Apple II, because there is no hardware disk controller. You've got to write one in software, and when you write a disk controller in software on the Apple II, these are the kinds of activities that you're doing. Oh, and then of course there's a soft switch for, yes, let's actually read a byte off of the drive head, or let's place a byte on the drive head to be written. You get, you have that too, but you've got all this other stuff you have to deal with before you're doing that. And so the book Beneath DOS talks about this stuff, and it came with an important preface to it. It basically said, well, so if you want to interface directly with the floppy drive, in theory, this is how you do it. But we don't really actually recommend that anybody does this, because Wozniak took care of this in '79. Just use his stuff. So, and this was like one of the monumental things that Wozniak did. Was to, as you may know, is developing that floppy drive and then writing this controller for it and everything else. It was totally groundbreaking. So I had read this book before this conversation with Q Kumba, so I had some kind of general sense of this. And as I got talking to him, I started to understand that no, he's not talking about having ProDOS in memory. He's talking about writing a drive controller, a new drive controller that uses the soft switches described in this book, but writing it in such a way that it would understand the ProDOS file system format, so that without ProDOS in memory, we could read a disk image that had been basically formatted by ProDOS. And the reason that that's significant is that because I know ProDOS, I mean, we're Commodore's a whole different, has a whole different set of stuff on this, so to bridge the worlds together. The reason, and I think this can be appreciated, is ProDOS. What comes with ProDOS is, because that was like the last Apple II DOS iteration, and what comes with ProDOS is that, well, it understands how to read 32 meg hard drive images, for example, and ProDOS has a bunch of tools that were written for it, modern day tools in the Apple II community. You can fire up a tool on a Mac or Windows PC and open up a ProDOS ordered disk image and look at what files are on it. Oh, and ProDOS has the concept of files built right into its file system structure. And with DOS 3.3, which is what came before ProDOS, you could basically have files if you had DOS in memory, but the disk controller that Woz wrote in 1979, it didn't understand files.
Yeah.
So the ProDOS ordered file structure or a file system had file names embedded and things like that. So what Cucumba was proposing was writing a new controller, use the latch toggles, get down to the lowest possible level with it, but write it in a way that it could read a Protoss disk image, which would mean that we could use all of these Apple II community development tools that were based around Protoss formatted images, as well as ultimately end up with a game that would be runnable both on floppy and on a hard drive disk image, which at the time I didn't appreciate the importance of that at the time, and I certainly do now. So once the light bulb for me came on that's what he was proposing doing, my mind was just blown, because having read Beneath DOS, I understood the monumental,
It's a heavy lift.
nature of what he was talking about. What's that?
It's a heavy lift.
Absolutely heavy lift. But I knew enough of his reputation at this point that I was like, if anybody can do this, this is the guy,
Yeah.
So I was like, I'm in. Let's do this. And over the course of the summer of, I believe it was 2016, we basically worked together on writing what is now known as Pro RWTS. And he had the mastermind vision for how it was going to work, and was writing the code for doing it, and would send the code over to me, and I would test it on various different kinds of hardware, observe bug patterns, report them back to him, rinse and repeat essentially. And it was a very symbiotic relationship, because he only had a single Apple II computer with one floppy drive, and we were trying to write this this controller so that it would work on a 2-drive system, as well as on not just the Apple IIe but also the 2C and 2GS in compatibility mode. I had all that hardware, he didn't. And as well as to truly test it beyond just like basic testing. Well, the true test was, can we stand up Nox Archaist with this as the controller? So after we sort of code golf back and forth to get the basics working, then I was like, okay, I took the code and swapped out the WAS controller for the new one. And of course it didn't work, and went back and forth with Cucumba on the different errors and things like that, or crashes, and not like there was, we're in assembly, there were no errors. What we got was crashes and memories dump. I want to use the proper terminology here. And so then we worked our way through that to the point that, okay, Nox Archaist was functioning at the same, it had the same functionality that it did with his controller as it did with Waz's controller. We got it back to that point, and that was probably a 6-month process to easily to get it there.
Sure.
And there was fine tuning of Pro RWTS that was going on right up to like a couple weeks before release, because of just how finicky the floppy drive is. And there's different models of floppy drives, and the drive arm doesn't move at the same speed, and all that had to be taken into consideration. And it was actually kind of a nightmare, which is talked about in the Making of Nox Archaist book and how we got through that. But so connecting all this back, so the end result, which just blew my mind, was Cucumba not only rewrote Waz's disk controller and made it compatible with Protoss ordered file systems, he made it better. He objectively did, both in terms of size and speed. And of course, it has to be acknowledged that he was standing on the shoulders of giants, having had decades to look at Waz's work and think about where it could be done, just like I was doing Nox Archaist vis-a-vis Garriott's work in Ultima. But nonetheless, just the thought, just Wozniak was so brilliant. Just the idea that anybody could improve on what he did, no matter how much time they had to spend on it, was a little bit of a, it was like a wow moment for me. And but yeah, objectively speaking, it's like a third of the memory. Pro RW test is like a third of the memory of the 1979 WAS controller, and I did a stopwatch test on it. It is like 7 times faster.
Wow.
In terms of the disk access. And I saw this early enough in the development of the game, because this was probably this was like pre-alpha. I mean, I think I had like, there was the overworld map and there was one town, and I had maybe started writing a little bit of Nox A Star, but maybe not even that. It was really early. So, there was no combat system, there was no spell system, there was no lots of systems. And so I had time to think about, okay, so how can we leverage this? And one of the ways that I thought about leveraging it was like, I want some really awesome spell effects in this game. I knew that from the beginning. I wasn't sure how to get it, but I knew I wanted it. And specifically on the bucket list, where I want a lightning bolt that sizzles across the screen, I want a fireball that explodes, and there's actually a technical innovation story that goes around that's separate from this topic, so I'd love to come back to that, to the lightning bolt and the fireball. But on the more general topic of spell effects, it's like, okay, so spell effects in Ultima 5 were nothing like that, and it was like there was a tile-sized shape that would be projected towards what you were attacking, that looked kind of like a little glowing glowy blob type of thing, and that was it. That's like the spell effect for every missile style spell, and then when for an area of effect spell, it would like invert the screen and do a high-pitched noise, and then mobs would die, kind of a thing, which was cool, which was great. And I think one of the reasons for that was that you need some code to do something more than that. Where's the memory that you're going to store that code in? And the disk access under the 1979 WAS controller was too slow. I tested it, because it's like if you press C to cast in combat and you read some code from disk for a spell effect of any nominal size, you're making the player wait a couple of seconds. And that just doesn't feel right. When a player enters a town, waiting, 7, 8, 9 seconds is what it would take entering a town in Ultima 5 on the Apple II. It was probably longer, I'm guessing, on the Commodore. And that was okay from a player perspective, because you're entering an entire new map. You don't do it that often. But combat is like, this is supposed to be this rapidly moving thing. So a couple second delay after hitting C to cast, that just doesn't feel right.
Yeah.
And so I didn't consider that to be viable, and I suspect other developers, I don't know whether it was thought about or not, but if they did, I suspect that was the conclusion that they would have come to, that no, that just doesn't work from a gameplay perspective. However, I saw that, wait a minute, with 7 times the speed, I tested it out, and yeah, we could read in a block of code of meaningful size relative to what it could produce for spell effects. And I mean, there might be a slight little delay, but it's barely noticeable, even on floppy disk.
Yeah, that's cool.
In Nox or Cicada. And that is made possible by that innovation. It's essentially a gameplay innovation that was made possible by a low level, machine level hardware, interface level innovation on the disk controller.
Yeah, and it's totally worth it. As you're upgrading your spells, they become more, distributed across the screen. They get bigger and more flashy. So that definitely added to the fun.
Did you hear that?
No, sorry, can't hear it. It might be, technical difficulties. I think it might be sufficient to tell people that when you boot up, you have this Nox Archaist commanding voice that always kicks off the game. Why don't you tell us a little bit how that came about?
Sure. Yeah, so that was not planned at all at any point in the process. It really it obviously happened, and so this is the story of how. Well, the story starts with Dr. Cat, the well-known Origin Systems programmer who also appeared in a couple of the games like the pub in Pause, I believe, in Ultima 6. I think a few other times. So I got to know him through a friend in common, and we were kind of talking off and on about Nox Archaist, and there was a point when he told me about this technique that he had discovered, pioneered, invented, whatever term you want to use, in the late 1980s for getting the Apple II to be able to produce high quality sound, high enough quality for human voice to be clearly heard and understood. And he said that it never made it into a commercial game, and he'd really love to see it, make it into Nox Archaist, and it would be kind of like a fulfilling of destiny there of
Sure.
something he'd always wanted to happen that didn't happen. And I thought, okay, well, that sounds interesting, and asked him for some more background on the whole thing, and he said that in the late 1980s, the game Windwalker, I believe it was Windwalker, was under development at Origin, and this is back when Dr. Cat worked there, and he tried to talk Greg Malone, the developer and kind of producer of Mobius and its sequel Windwalker, into putting 5-bit pulse width modulation into Windwalker, somewhere. And that according to Dr. Cat, I've not had the opportunity to talk to Greg Malone about this, but get his perspective. According to Dr. Cat, Greg's first reaction was, yeah, there's no way you're going to be able to get that to work. Which is like, you tell that to a programmer, and that's when they're going to really dig in. So Dr. Cat, digs in, was able to get his theory into practice and produce clearly sound, this crystal clear sound with 5-bit pulse width modulation. And I don't remember how much time had passed, but I imagine it was a while. And so he goes back to Greg Malone. They had according to Dr. Cat, Greg Malone, in fact, not only said he didn't think he was going to be able to get it to work, he bet him a cheeseburger on it. He's like, over the whole thing.
High stakes.
And yeah, gotta put the stakes on it. So Dr. Cat eventually gets it to work, goes back to Greg Malone, and whatever it was late stage in the development cycle with Windwalker. There are lots of considerations, and even though Dr. Cat did in fact get it to work, Greg Malone decided nope, not going to put it in. So Dr. Cat instead took it to Soft Disk Magazine and basically did a tech demo. Took it to I'm pretty sure it was Soft Disk. It was one of the computer magazines of the day, and they did an article on it, and included it on the disc that went out on the magazine, and that was like as far as it ever went, as far as the public view. And more importantly, Dr. Cat notes that to this day, Greg Malone still owes him that cheeseburger. And that's pretty much where the story ends until his conversation with me about saying, hey, well, it'd be really cool to have this in there. And that kind of got me excited, the whole story of how it all went down, and thought, yeah, this would be really nice to to have something like this. And it was getting kind of late-ish stage in Nox Archaist to be doing something like that as well. But decided, okay, well, let's try to get this to happen. And one of the challenges was Dr. Cat had time to explain the concept of what he had done, but didn't, have time to actually jump in and do the programming for it, or at least not all of it. He did offer to do a piece of it at one point, but not like the full programming and the sound creation, which has to be in the right format for the programming and for it all to work together. And I honestly didn't have time to do any of it. Nor did I personally have the sound skill to do it. Sound programming is a very special thing, especially sound programming at this level. And I knew it was not something I had the ability to do, nor did I have somebody on the team that this was really, their wheelhouse. I had one team member that maybe could have, taken a good crack at it, but he didn't really have time to dig in that deep. And so ultimately, I ended up recruiting Kris Kenaway, who is a programmer in the Apple II community that is known for his tech demos. And he wrote like a tech demo on the Apple IIe where it was hooked up to the internet. There's some electrical engineer who is an Apple II fan created a, like a network adapter card. I think it's called the Ethernet card for the Apple IIe to get it connected to the internet. And Kris Kenaway wrote the code leveraging that, internet connection to basically have streaming audio and video in double high res graphics off of an Apple IIe. And of course, the graphics, even in Apple II high res, is a far cry from seeing video on a modern computer. But you could kind of make out what the shapes were and, things. And he even got Doom running, through this, kind of mechanism. But the audio, on the other hand, the audio was actually, really good, because the quality of 5-bit pulse width modulation is just phenomenal, and you can get clear human voice from that. And of course, you've got, your data and your memory limitations, but since it was streaming off of this modern, built for the Apple II network card, you didn't have those constraints. The data just kept coming in, and it just kept cranking it out. So I thought, well, let's reach out to Kris Kenaway and see would he be up for, doing this implementation, and he was. And I don't know to this day. This is getting off a little bit on some esoteric historical, side of it, and I do want to talk a little bit on, technically how does this even work, but I don't know to this day whether or not Kris Kenaway's technique traces back to Dr. Cat's work in the 1980s, or if it was two people figured it out independently. I know Kris Kenaway learned it from work that a gentleman by the name of Michael Mann did in the 1990s. And there was a bunch of posts and things, in the 90s about it. And Michael Mann is still around. Kris might have even talked to him at one point. But that's where he learned it from. What I don't know, because I've never had the opportunity to meet or speak with Michael Mann, is did Michael Mann develop it on his own, figure it all out on his own, which he could have, or did he get a hold of the Soft Disk magazine that had Dr. Cat's tech demo in it and basically take that and build on it? I don't know, and it's something I'd be very curious to know, and maybe someday I'll have the opportunity to meet Michael Mann and ask him. But in any event, that's really just a historical footnote on the whole thing. The bottom line is it's the same stuff, 5-bit pulse width modulation, and how it works goes something like this. On the Apple II speaker is a very simple speaker. Under the case, it looks like something you could buy at Radio Shack. Commodore has much better sound capabilities in every way. The Apple II speaker is basically capable of being in two states. It's either on or it's off. And all the sounds you hear coming out of the Apple II are a function of turning the speaker on and off, on and off. And when you turn it on, how long do you leave it on before you turn it off? That's your duration variable. And when you're doing that, turning the speaker on, leaving it on for some period of time, turning it off, what you get is a square wave. And square waves that produces the sound on the Apple II that, we're all familiar with if we've heard an Apple II. And I apologize, I don't know that much about how the Commodore works for sound. I know it's better, but are there square waves involved there, David? Do you know?
So, yeah, the Apple II has a 1-bit speaker, so it's either this way or this way, and you choose the rate at which you do that to create a square wave of a certain perceived pitch. On the Commodore, there is no speaker built into the machine itself. It is sending the audio signal to your monitor or television set. And there's a special chip that has 3 oscillators and different waveforms and filters and a tact case, sustain release and ring mod and hard sinks and all kinds of stuff going on. It's a different animal. But what's impressive about the thing you're describing is what you can do with a 1-bit controlled speaker. So back to you.
Like that you can do much of anything is, yeah, exactly. So, I mean, that's what was producing the sound in games like Ultima and Castle Wolfenstein, and except for music, there was a Mockingbird card in the Apple II that was used for music in actually not many games at all, but Ultima 3 through 5 had that. Any kind of music created off of the 8-bit speaker. I mean, it was done, but it was, not great. We'll just say that. So in any event, that's what we're working with, is basically we can make square waves. That's, the starting point, technically to the challenge. And what Dr. Cat figured out first, at least, having done it in the late 80s and possibly eventually independently by Michael Mann, we don't, or related, we don't know. What Dr. Cat figured out in the late 1980s is that if you write some really, really tight code, you can turn the Apple II speaker on and off really rapidly in such a way that you can round off the edges of the square wave. Now let's dive into that a little bit. It's like you turn, theoretically you have, okay, the speaker's on, and then you have it off, except you're controlling that through code, through a soft switch. So if you tell the speaker to turn on, and then you tell it to turn off, a different soft switch, okay, so it's turning off, but before it's fully powered down, you flip the soft switch to tell it to turn on again, you can do some really interesting stuff. And between a full power up on and a full power down off, you've got all these different places that you can wait before you send that power up again. And that's where you get the granularity from that takes your square wave, rounds the edges off, which is the key to the subtleties of something like human voice being able to be clearly understood. And the code to do that, because speed is of the essence, because you're racing the hardware, with its power up and power down cycle, you're in a race against how fast the hardware is doing that to be flipping these soft switches. It results in code that has to be so tight that if you started out with a lump of coal, you'd end up with a diamond. It's only barely possible, because it's just hitting up against the threshold where you just can't optimize it any further, and the 1 megahertz processor is just maximized in every possible way. I mean, we're talking about to the point that if you cross a page boundary where you've got opcodes that take an extra clock cycle if they cross a page boundary, that's enough for it to be not fast enough if that happens at the wrong place in the code.
You have to use any pseudo ops to make that hit the unintended operations to hit those speed, or do you just use all standard 6502 instructions?
It's all standard 6502. Okay. Yeah.
So thank you very much for this deep dive. Before we go, you have Nox Archaist 2 there in the background. tell us a little bit about what the next game is. I assume you're going to get the chance to change your engine a little bit and do new technical goodness. Just give us a quick wrap up of when it's happening, and if people can help, tell us how that can happen as well.
Sure. Well, a couple things. So, firstly, if you happen to be interested in the original Nox Archaist game or the expansion for it, you can get that by heading over to noxarchaist.com and clicking on the store link. They're both also available in Steam on Steam and Good Old Games with a built-in emulator. The two books, the Book of Hints, Making Nox Archaist, those are also available on the website mentioned, as well as Steam and Good Old Games. Nox Archaist 2 is going to be a full sequel. It takes place in a region called Dragonsmere. The first game took place in a region called Isles of Windmar. These are two regions of a broader world called Valley. So what you can infer from that is Dragonsmere will have a completely different overworld map. Some of the goals that we have for it are to have more large portrait images in the game. Like, for example, when like if you make camp, there's this like a quarter of the screen size portrait image that pops up, and the merchants have portrait images like this. So we want to have a lot more of that in the game, is one thing we want to do. We're also completely redoing the statistical system, which is of course, like the core of the game loop. So things like items and how classes work, or how skills work, or Nox doesn't even have classes. It's a skill-based system, but all the interplay between all of that and the spell system, that's going to get rewritten and improved, and that will result in rewriting big chunks of the game engine, like basically rewriting combat, probably rewriting most inventory and merchants and things like that, and probably spawn some other interesting content ideas. There could be different merchants and things that crop up because of stuff going on in the stat system. So that's definitely a big goal as well. I'm also going to try to put in an auto mapper in the game that will kind of keep track of your position as you go, probably a fog of war style thing. And if not that, I would probably plan B would be to do something like Ultima did with peering at a gem, where you can get a map of the region. It's still intended to be a game where you're going to have fun with the graph paper, if that's your thing. I will still design it in with that point of view in mind. The auto mapper or peer at a gem would just be an augment for those that would prefer to do it that way. So it's going to be a big undertaking. I'm also rewriting the Nox Archaist tool chain in the process. Map editor, pixel editor, game item data management, things like that. The tools that I did for that the first time around were kind of clunky. Going to redo those, which is going to be a big time investment, but ultimately, if not speed up the delivery of this game, might be a wash, on the first one, but certainly for future games and expansions, those tools are going to pay big dividends. So that's kind of what we have in store. The project just kicked off here in about 2 months ago. We did a Patreon campaign to raise support for it, and we hit 100% of the minimum goal, which was great, absolutely wonderful. Thanks so much for everyone who contributed to that, and we hit about 85% of the ideal goal. So if this sounds like a project that you're interested in, we could definitely still use your help with it, and it would be much appreciated. And you can find our Patreon campaign at patreon.6502workshop.com, and we look forward to delivering a excellent RPG a second time in a row. Or third time if you count the Lord of Storms expansion, but second time in a row in terms of a full game.
Hey, that expansion took me 40 hours right there, so there's a lot of game in just the expansion.
Yeah, and it is brought to you, if not entirely by the same team, largely by the same team. I was the lead developer on the original game and will be on the second, and some of the other my teammates from the original game are already getting involved in Nox Archaist 2. It's possible we might get some new folks involved in along the way, but you can definitely count on, this is it's going to have the same look and feel. It's coming from the same mind and minds, etc.
Excellent. Okay, well, with that, again, thank you very much for your time, and I look forward to
You're welcome.
playing your next offering. And I think we'll close it here. See you on Discord.
Sounds good. Thank you so much for having me, and see you on Discord. Have a good day.
All right. Well, that was an education for sure, right? So we are at 5 o'clock exactly. We're running a pretty tight ship here. And so what's going to happen next is we've got Bitscape. And so Bitscape is our chiptunes music showcase, and it's run by Sajtron. And we're going to play a little intro here. And then you'll understand a little bit more about what we're doing. Right back with this intro here.
Welcome to Bitscape 2023 at CRX Commodore Retro Expo. With music by Ctrix, Manta, Labrat Warfare, Hope-1,170. Incenso. From 0 to Z. DJ Space. Jeff Gregory. Robert Kingston. Electric Gypsy. Sajtron, and Wagner Fulco.
Oh, yeah. Oh, you're muted. Your mic's muted, Saj. Mr.
Oh,
DJ,
here we go.
here you go.
What's up, everybody? Back for day number 2.
Number 2.
We've got a lot coming today. We've got, well, we played, I just want to thank all the artists yesterday for their participation in this year's show. Awesome feedback on everybody. Why don't you explain to everybody again today, for those that weren't here yesterday, how to get on Discord, that we're all partying over there doing all the performances.
Okay, so what you want to do is you want to go to the CRX event website. It's the easiest way to do it. Go to crxevent.com. The homepage has links to our Discord, to the YouTube Live, and the schedule, which is something that people want to know what's going on. So if you go to crxevent.com, click on the link, go to Discord. You can sign up on Discord. It's free. If you already are not a Discord member, it's not a big deal. You can run from a browser, or you can download the app. They have apps for Mac and Linux and PC. And it's a super easy way to communicate with people. It's kind of like Twitch in a way, but I think it's much better interactive with their people, I think, really. So we've got rooms, we call rooms, they're actually channels. And so if you look on the left-hand side of your screen, you're going to find a bunch of different categories. And one of the categories is Bitscape, and you'll see all the artists that are a part of Bitscape, and there's 12 of them in there. And so yeah, we're going to be doing what, 7 people today? We had 5 yesterday. We have 7 today.
Yeah.
I think that's what it is.
Yeah, it's a lot of fun. We've got like Jim was saying, everyone's got their own room. So basically, like Electric Gypsy's our first artist tonight. You can hop into Discord, find Electric Gypsy's room, and that's where we're all hanging out. So while his music is being played, we kind of go in there and we're like commenting on the tracks and just chit-chatting on like the sounds or the gear that's being used. And sometimes the artists are in there too, and you can ask them questions about the track, you know, things like that. So it's a lot of fun.
Yeah, it was hopping yesterday.
Yeah, yesterday was pretty busy. A lot of people were jumping in there. Also, another thing we wanted to talk about, and Jim was talking about also, is we're thinking of remastering the whole CRX, like a CRX remastered edition. You want to talk about that a little bit?
Yeah, I think we're going to do, so yesterday we figured out that we might have some problems with stereo or something, we weren't really sure. But the reality is that when we go from live video to Zoom to YouTube, there's a loss of quality in the video. So what we see, us personally, we see 1080p videos, and what you see on YouTube is 720p, which stinks really. So if we take the live content, like us talking right now, and we insert the actual real videos that we get from the artist, like Saj sends, then send that back to YouTube and link to that, we'll have a much better remastered version where you're going to see high quality audio, high quality video. So we're going to go ahead and do that when the event's over.
Exactly. So after the stream's over, you guys can still watch the stream, but in a couple of days we'll have a remastered version, and that one's like higher quality, better sound, things like that. Yeah, and I guess the way YouTube works is, I think it limits it and compresses the sound, so it sounds more even. But when it does all those compressions, and you know, it's almost like a VHS second generation copy,
right?
Because you're also losing. It's like capturing it from Zoom, and you know, so you do lose some quality there. But
we
we're
have filters too. Remember, there's audio filters that try to suppress things, and so we're trying to turn all those things off on our side, but we have no idea what YouTube does, and we don't have any control of that side. So.
Exactly. So that's, yeah. So look forward to that. And then also, I'm working on a Bitscape website where we're going to also have all the previous shows listed on there. Also, we're going to have links to all the artists and all their pages with like their bios. So you can go back there and check out those links as well. And yeah, I think that's it. And then, so this is the 4th year we're doing this Bitscape. And for CRX, I believe it's our 7th year now, right?
Yeah, this is number 7.
Number 7 for our virtual. No, not virtual. It's set
7 total. This is our 4th
total.
virtual.
Yeah, 4th virtual and 7 total. We started doing physical events in Las Vegas, and you know, hopefully we'll come back to that once things stabilize in Vegas. Just rentals on any real estate over there is just so expensive at the moment.
Yeah, it's crazy. Like
it's
I told
crazy
people, they're trying to get all their money back that they lost during the lockdown all one time. So
yeah, it's crazy. I mean, I moved out of Vegas during lockdown. One of our artists, Wagner Fulco, he flew over and helped me move. That was a crazy drive. We drove cross country, and yeah, that was a cool experience though. And but yeah, I'm based out of Miami now, and the gym's out in Arizona, and I think everybody's pretty much scattered everywhere. We got California, Chicago, everybody's kind of spread out now.
Yeah.
But we always try to meet up in Vegas once a year for our CRX events, which is also always a treat to have. All right, well, let's start the show. So our first guest tonight is Electric Gypsy. He's from here in Miami. He's actually an old friend of mine from Panama. We actually grew up together down there. Our families worked for the Panama Canal in Panama. So we used to be in the Department of Defense schools down there, where all the military and US government kids go. And it was awesome growing up down in Panama. We had actually a pretty cool retro scene there. It started with the Atari group, when we all had the 8-bit machines. And then the only place to buy, believe it or not, microcomputers was in the PX on the base, the base exchange. They didn't sell any Commodores or Ataris in Panama City. So basically, the only thing you could buy, I remember, was the Atari 2600. That's all we had access to back then, because that's where we got ours. But when the Commodore and Atari came out, only place to buy was on base. So we bought ours because we could shop at those stores. But I remember a lot of Panamanians couldn't get them. So there was a lot of contraband going on for people trying to get their computer. There was no other way to do it. The other way people were getting them was they were vacationing to the US, or other parts of the world where you could buy the machines. But it was mostly contraband in Panama to get the machines right on base. So there was a small community of military on base. But as the years went on, there was more Panamanians in the groups, and that's how they were getting their machines. And the groups were big. I remember my first time at the Commodore group, it was in the Army base. I couldn't believe it. There was like over 100 people there. And it was just kind of like those demo parties in Europe where they had all the computers set up. Everybody brought their drives, they're exchanging software, playing demos, games, it was awesome. It was a lot of fun. And we had a really good thing going on there. And then later we had the Commodore Amiga, Atari ST. And anyways, me and Electric Gypsy, we used to head down to those groups. But every time we went there, we would see, what new software people had and things like that. And tell the truth, I think we had we got a lot of stuff first, because we had friends from in school that had contacts in Europe, and they would get stuff, and we basically had a lot of the latest stuff. So every time we would go there, everybody would surround us, knowing we had brought some stuff from Europe or something like that. So we didn't attend too many of the meetings there because, for us, we kind of work a little bit ahead of what the meetings had or what they were presenting. So it was cool. We had our little groups there, and Electric Gypsy was one of our crews, and we ran some BBSs and stuff like that. Nothing too crazy. It was just local stuff, just to chat and stuff like that. But Electric Gypsy started with the Atari 8-bit, so did I. And then I got into the Amiga after the 64, and he had the Atari ST. And he loved the way the Amiga had the sampling capabilities and the pro trackers. And in the early days, the Atari didn't have those trackers yet. They always had the MIDI, and he didn't have the MIDI stuff, not in the early days. So he would come over all the time and mess around with the trackers. And so he eventually got an Amiga himself, and that's when he started producing stuff. And then later, after he graduated, he moved here to Miami. He was my roommate for a while, and I think I had 4 roommates at one point, and we all had Amigas. So we would create all these tracks, and it was really cool. So anyways, after the Amiga died out in the mid-late 90s, he got into the PC, and he started buying real gear, mixers and synthesizers, and then he just started using the real stuff. I'm not sure if he had a real sampler. I can't remember, but so over the years he started getting more into different kinds of music after that. And but when I moved back to Florida, I kind of started getting him back into the old retro stuff. But by the time I got here, he already had a full-blown studio with everything, whatever you can think of. He's even got a modular now, like me. And but anyway, so I'm like, dude, you got to get a Commodore 64, in your studio. But he's never gotten around to do that. So I just donated one to him a couple months ago, and it's just sitting there in the box still. I'm like, dude, you need to get a monitor for that thing. And he's like, oh, I don't want to get a big monitor for the studio. It just looks so bulky. I'm like, all right, well, maybe we can get there's something called a, what's that thing called? It uses a Raspberry Pi, and it's got an HDMI out. I already forgot what it's kind of like a multi-cart with HDMI out. Remember what that thing was called? Anyways, so I'm thinking of maybe getting him something like that. So he's got HDMI out and he can use one of his flat screens.
Gotcha.
But he was also telling me that he wants to get someone sells a module for modulars. And it comes with a SID chip. So you actually control it with control voltage. It's really interesting. So he was really interested in getting that. Those are a little pricey though. They're like $300 to $400.
Yeah.
And I don't know they come with a real SID. I think they come with like a ARM SID or Swin SID or one of those. But you can swap it out and put a real SID. But I'm really excited if he gets one of those. I want to see what he comes up with. But let's roll the tape and let's see what he's got going for us.
Right.
I'm excited to see this.
All right, Electric Gypsy, coming up.
Go.
Tuned into the 2023 Bitscape Commodore Chiptune Music Showcase at CRX. Up next we have Electric Gypsy.
Hi, I'm Electric Gypsy. This year for Bitscape 2023, I decided to do things a little bit differently. The first song I am performing is a cover from a game that I used to play on the Commodore Amiga. I remember when this game first came out, the music was really what caught my attention. This was because it was the first game that I had heard at the time where the music emphasized the relationship between harmony and melody, which is often not the case in game music. The music just seemed to grab my attention as soon as it came on, and it has been one of my favorites ever since. The second song I performed this year is also a cover. It is a blend of two movie soundtracks, both which are considered to be classics to this day. These two movies explore a window into the future of AI technology and its dangers. Both movies have a huge cult following, and the music captures its complexities perfectly. I hope everyone enjoys my renditions.
Wow, I'm going crazy over here, man.
I know.
I'm a huge Tron fan. So like this was a surprise. So like I remember 2 years ago, right when I moved back to Miami, me and Electric Gypsy were writing a track together for the first Bitscape when I moved out here. We did a track together called Can't Stop the Future. And after we finished, each day, because it took like a month to work on that track, he would doodle around the keyboard, and he knows I'm a Tron fan, and he's always doodling with Tron, you know. He's like, hey, listen to this Moog synthesizer with the Tron, you know, or the Prophet 5, and I'm like, man, that sounds good. And every time, like over the days we were working on the track, he would get further and further into the track. I'm like, dude, you gotta like do something with that, you know. You can't just like mess around, like hit record. So I made him hit record one day. And I'm like, dude, just get it down, get the idea down, because you know how to play most of it. So he did. He hit record, and then he kind of shelved it. You know, he does. Yeah, a lot of artists do that. They just doodle around, shelve it, maybe come back to it, or maybe not. So he kind of shelved it, and I over the years, I've been bugging him. Hey, man, you know, you're gonna go back to that Tron track, you know, work on it. So this year, after he worked on the Hybris track. I'm like, hey, you think you still got some time to work on that Tron song, right? And he finally said, yeah, I guess so. So, but I didn't know what he was doing. That was a surprise. I didn't know he was doing original and legacy, and then like fusing it. I was like blown away for that. That was really cool. And that's something I've never heard anyone do before. So that was really cool. And I love how the Sid creeps in like later in the track. Like you have no idea it's even in there until later. And that was really smooth, the way everything was like transitioning, and it was great.
Good feedback on the Discord for sure.
Yeah, for sure. And now that Tron 3 is in the works, I'm sure that song's gonna be hitting the internet for a while.
Sure. Some variation for sure.
Yeah, and the roller coaster just came out a couple months ago, so that's gonna be pretty cool. So yeah, if you like what you heard, Electric Gypsy did more music like that in the previous 2 Bitscapes. And the Hybris track, that was cool too. That was a big popular game on the Amiga. We played that all the time. Yeah, it was the best. It was one of the better shoot 'em ups that they had, because it had the crazy ship and all the attachments that came on there, and then you like crazy firepower. And
Data Storm, all those games.
Data Storm, yeah. What was that comment someone made yesterday about R-Type? About the tip of the ship attaches to it, and supposedly it's like bulletproof.
Right, it's completely bulletproof. So why make the whole ship out of it? Yeah,
make the whole ship out of that material.
There was somebody had commented with budget cuts.
That was pretty good. That was probably the best comment of the night. That one made me laugh. So yeah, let me get you some information on Electric Gypsy. You can reach him on YouTube. He's got a lot of videos on there of his previous Bitscape tunes, as well as other works he's done. It's on youtube.com / @Electric Gypsy 6141. And he's also got even more music on SoundCloud, soundcloud.com / electric_gypsy. And you could check out all his work there. And let's see who we got next. I think we've got
you.
Oh, me. Okay, there we go.
I know that Sajtron guy.
So this track, I kind of had got a lot of good feedback last year on the track that I did for the 40th year anniversary for the C64. Yeah. I did a remix for Are You Keeping Up with the Commodore, which is kind of like their famous jingle. Yeah. And they made a commercial, and I think it was the Australian commercial that they made. And that commercial has gone viral for many years. Everyone knows about it, because everyone's like doing the salute in the track. And the best part's like the business guy in the pool. Right. He's got his SX64, and he's got like a beautiful girl like diving into the pool, and he's just like typing away with his cocktail on the side. And I'm like, man, I got to make a track to celebrate the Commodore, and everybody loves that commercial. So I decided to remix that, put some Jim Butterfield in there. So
Yeah.
there was like a good educational like concept that I put into the track, which I think it worked pretty well. So this year I figure, okay, yeah, that kind of worked pretty good. Let me do another track, kind of like put some educational angle into it as well. And so I did that, but something happened while I was producing the track and inspired me to do what I'm going to do. So let's go ahead and play the track, and then we'll explain it all after.
Now, I have to be honest, I've not watched this myself yet. I wanted to wait until
okay.
now. So
Okay, awesome.
That's gonna
Here
be
we
awesome. All righty.
You're tuned into the 2023 Bitscape Commodore Chiptune Music Showcase at CRX. Up next we have Sajtron.
Hey, what's up? This is Sajtron. For this year, I was writing a track, and unfortunately, the sit chip died in the middle of the track. I was lucky enough to have a spare. That incident kind of inspired me to write what you're about to hear. I hope you like it.
Well,
There we go.
it's too bad you have no talent, man. That's amazing.
Thanks, man. So basically, I was working on this track, and the chips had died on me in the middle of the track,
Yeah.
and I was like, "This is unbelievable." You know, I've had some SID chips die for me, but like on computers that were sitting for years, and I just turned it on, didn't work anymore.
Sure.
So I really felt really sad when this thing like died on me, and I was like, so as you see, I pulled the chip out and I added it to my little graveyard. I kept all
Right.
my old SID chips.
Yeah.
Who knows? Maybe one day we'll figure out a way to resurrect those. I don't know. I know they've tried different things by like heating them, and that didn't work. But who knows? Maybe someone will find a way. I don't know.
Maybe.
So yeah, so it inspired me after that incident happened. Like, you know, this is something that a lot of Commodore users are going to have to face in the future. And there's already a lot of solutions to like keep them alive longer. But there's also controversy about that too, like putting heat sinks on them. And there's many ways you can do it, but some people are just like, just leave it open air, don't put anything on it. So yeah, I'd love to hear what people are doing to keep their SIDs alive and to keep them running longer. And I think people understand now the value of the original SIDs, their limited lifespan, you know. How many years are we now into the SIDs? Like 40 years? So they're getting quite old.
They were designed for that kind of longevity when they were designed. It's an old analog part, you know, so that's the thing is that, and they're all different, as we know, like the 6581s. I mean, that's why everyone likes a particular rev version of it, you know, or the 8580 seems to be pretty common, constant between all the different ones. But yeah, it's just a part that's, you know, made in a process where, you know, things change and
exactly
time changes.
So I put a little history on the video, explaining all the revisions of the chips. There was some of the later revisions that I couldn't find much info on it, except where they were manufactured. If anyone has some insight on the later revisions, on what those are, I could always re-edit my video and put more info in there. I found most of that info on Wiki and some of the forums. Doesn't seem to be too much documentation on.
There's one website that I saw that actually had a scope output for every single SID and showed the difference.
Wow.
Yeah, so I'll link that to you. I didn't know if you didn't know that. So yeah.
Yeah.
A lot of time.
I have not seen that. I've got quite a few 64s, and I need to open them all up and document which ones I have and what years they came out in. I got my little shot glass here with the SIDs.
It is.
I've got a lot of 6581s. I gotta admit, I did mess up one chip myself. This was a noob mistake before I knew too much about these chips. I didn't know there was a 12 volt and a 9 volt version.
Yeah.
So when I found out about the 8580 R5, which is this one, I was like, oh man, I'm gonna put this on my other. I'm gonna put it on my bread bin.
Yeah.
To get that cleaner sound. Oh my God, I blew it up. I was so sad. Like when that happened, I'm like, and then I went to my I remember I talking to Forrest about it at our Commodore meeting in Las Vegas, and he's like, "Oh yeah, you can't do that. There's different voltages." I'm like, "Oh man, that's terrible."
12 5 volt. That's a big difference.
I learned an expensive lesson that day. That's true, because these are quite expensive these days to get. So yeah, I would love to hear people comment on how they're making their SIDs last longer, what kind of techniques they're doing. Also, there's all these replicas now that are out that are gonna probably take over after a certain amount more years. When all these SIDs pass away, we can only use the replicas,
right?
And there's a whole bunch out there that people could try out. There's like maybe like 6 or 7 options now.
Quite a few.
There's quite a few of them with hardware, and then there's the virtual ones too. There's some VSTs now, like Insidious. If you're making music in the studio, that one's legit. It sounds really good. Then there's like I think Machine Native Instruments makes a virtual SID version as well, and one of their hardware synthesizers. So there's a lot of options out there.
Yeah.
But yeah, so I just wanted to make this song about the SID, and I kind of learned a lot too about the revisions and things like that. So yeah, that's what I wanted to put out a tune about the SID. So I think it
Well
worked out
done.
pretty good. And I want to
Very well done.
I want to thank Keith Green. So Keith Green is an animator that collaborated with me in this video. I know that he was doing in the years ago, he was creating 3D renders of the Commodore and all that. And he's going to be interviewed tomorrow if you guys want to catch that.
Yep.
He's going to talk about, I'm sure he's going to talk about what you guys just saw in the music video on some of those SID animations that he did. I basically just kind of wanted him to create me just the front facing SIDs with the badges on them. But then he started creating these like wicked looking 3D spinning, and then he started putting the electricity coming out of the pins. I'm like, oh my God, that's just awesome. We got to put that in the track. And then at the very last minute, he got it to like, we were playing with, like I sent him some samples of my bass lines and stuff. And he said that he's able to put in some kind of audio plugin into the animation program where you can feed the bass through it. And then the electric kind of wiggles to the bass.
Ah, gotcha. That's
so
cool.
some of that that you hear, even the arpeggios, all that's going is a real time going through the audio, and then he renders it that way. And yeah, it was great. So it was great working with Keith, and you should check out his interview tomorrow. He'll talk all about that. And yeah, so let's
wait a minute. Where can people get your stuff?
Oh, right. I always forget.
Come on now. Let's do some self-promotion here.
You can go to my website, Sajtron.com. That's pretty much it. I don't have any band. I have a Bandcamp. There's nothing up there yet. I'll probably set that up later this year. So to look into that, you can always find out through my Sajtron.com. I also run the Facebook.com/Bitscape showcase. But that's mostly stuff from the Bitscape shows. But you can always contact me in there too. And all right, cool. So let's move on to Wagner Fulco. So unfortunately, he couldn't be here this year.
Yeah.
He got really busy in the studio. Also, he works for Disney now, so he's got a lot of things going on with them, and a lot of family things are going on with the family. So he just couldn't make it this year. But if you were here last year and the year before, if you don't know who he is, he basically, I met him in Hollywood when I lived out there, and he's worked with top producers and artists such as like Steve Vai, Antonio Banderas, Sting, Elton John, Black Eyed Peas, Snoop Dogg. I mean, there's so many more. If you go on his website, he's got a lot of photos with all the artists and things like that. So he's a really good friend of mine. Way back in the days, I used to work at Guitar Center in Hollywood, and he was the manager there. So we got to be really good friends, and yeah, we just stayed in touch ever since. And I would go visit him in the studio and things like that. So anyways, so I asked him if he wanted to be part of Bitscape when I moved here in Miami, and he was like, "Yeah, no problem." And I'm like, all right, well, I know you don't have a Commodore. So I hooked him up with Insidious, and he started putting that into his studio. He's got Pro Tools, I believe he uses over there, which is what most of the major studios use. And yeah, so let's give this a roll. These are the past 2 years that he did. And yeah, he's going to shred for you guys. Check this out.
So we're going to do them back to back.
Yep, here we go.
You're tuned into the 2023 Bitscape Commodore Chiptune Music Showcase at CRX. Up next we have
Hey everyone, Commodore community. My name is Wagner Fulco, and I'm here basically trying to crash your party. I'm a big fan of the retro sounds, the retro gaming, the retro stuff. So my friend Saj gave me the opportunity to play a song for you guys, and I hope you guys enjoy what I did. I tried to use all the Commodore sounds and play my guitar on top of it, and forgive me for all my mistakes. Was on the fly. Whatever happened. It was a live take, one take, that's it. So hope you guys can enjoy my music, and maybe I see you on playing some of my tracks on your Spotify. I'm about to release my solo album soon. Maybe I keep you posted if you guys want to hear more about it. So no further ado, take it away. Hey everyone, congratulations, one more year of Bitscape, and you guys invited me again, so I'm gonna have to play another song for you. This time it's gonna be something a little bit different. This time I'm gonna play something that you might recognize, and if you do so, I want to challenge you to go on Discord, the group chat you guys have, and name that song and tell me where did this song come from. Of course, I modify. Of course, I'm gonna make a little bit difficult for you to understand, but let's see who can catch it. There's actually 2 more Easter eggs in this track. Let's see who can name all 3 Easter eggs. So the name of the song, where the song came from originally, and also there is 2 other Easter eggs that you're gonna hear, and let's see who is able to catch where those mix. Where did this song come from?
Damn, that guitar was on fire.
Literally.
We should put the CGI smoke in there.
Really?
Yeah, so that was great. Sad that he wasn't able to be here this year, but we had to pay our regards and kind of still have him in presence and have him play. I'm gonna be visiting you, Wagner, in a couple weeks. So
lucky.
So yeah, we're gonna have I think he's got some music coming out. I think he had music last year coming out, and I think he's working on some other stuff now. So that'll be pretty cool to check out.
So let's talk about those Easter eggs.
Yeah, so the Easter eggs, someone in the chat guessed it. Who was it in the chat that guessed it? I think it was, let me go back. I think it was
David. I think it was David.
No, from 0 to Z caught the Great Jana sisters first.
Yeah, before that, I think it was David. Yeah, I was looking for a GIF of Darth Vader saying a sister.
Oh yeah. I gotta go back up there.
Yeah.
Okay, maybe it was him. I'm not sure. And then someone said for the other track, what was it here? You guessed it, no?
Yeah.
Randy
I knew it right away when I heard it last year when he played it. I was sitting there, I was listening to the video. I wasn't paying attention because I was cueing it, making sure everything was fine, playing it through. I was like, holy mackerel, it's crazy strange. Because his transitions between anything is so smooth. It's amazing.
Yeah, that's how good of a player he is. Like, he just makes it like a walk in the park.
So what we found out the first year, he said he did that in one take.
Yeah.
That first song. He did the thing in Pro Tools to do the backing track, sat down with the guitar, filmed it, done.
Yeah. I don't know how you memorized those tracks so well. Like Great Jana Sisters, he didn't even know what game that was. I think I asked him about that game. He's never had a Commodore, by the way.
Right.
So I think he went online to see what was one of the famous Commodore games, and he think that's how he found Great Jana Sisters. Yeah. So he picked a good game because that one was very popular. I remember playing that on the Amiga. And I later found out it was for the 64 too. I never played it on the 64 until just recently, actually. And it's actually pretty good.
Super rare. The original disc and package is super rare.
Oh yeah, let's talk about that real quick. So didn't they get into a lawsuit with Nintendo?
I have no idea what the history was, but I know that if you find one like on eBay, it's thousands of dollars.
Yeah, I think that's why. I think it got recalled and they had to take everything off the shelf. I think I read it somewhere that it got recalled.
That would make sense.
And then they just stopped selling it. And but now if you find one, you got to pay
super rare.
Super rare.
Expensive.
So Wagner, if you want to check out his music, WagnerFulco.com. All his information is on there. Once you're up there, he's got other links to other social media sites, and you can check out his library and a lot of good stuff in there, especially the photos. If you just type Wagner Fulco on Google Images, there's amazing footage of him and videos with Snoop Dogg, Steve Vai. Like it's amazing. So it's a treat that he was able to spend some time and work on some music for Bitscape, which was really cool. So I really appreciate that. That was really nice of him. All right, well, let's go to our next artist. So next we have Jeff Gregory from Illinois. He's a returning artist. We had him here back in 2021. And I actually met him at our first CRX in 2017 in Las Vegas. He attended our show at the Alexis Park Hotel, which was across the Hard Rock. And that was our first and last year at that location. It was a cool spot, but man, they were nickeling and diming us for
it was horrible. It was horrible.
Oh, you need internet? Oh, you want water? Oh, you want this? You got to pay for everything. It was crazy. And the thing we didn't like the most was the time restrictions that they gave us.
Yeah, that was the problem.
It was a cool space, but we couldn't be there after a certain hour. We had to lock it up and all that. And then we moved it to the plaza. And then since I worked there at that time, there was no restrictions. It was great.
Full reign to the hotel. It's great.
We even were soldering there the last year, and you're not allowed to solder on property. We were soldering, smoke's coming out. I remember my manager walked in, he's like, "Are you guys supposed to be doing that?" And I'm like, I don't know. He's like, all right, don't worry about it.
Hey, we were safe. We had trays and everything. It was actually very well contained for that.
Yeah, it was well contained. So, but it was good. That just shows you the freedom that we had at that property. They were very cool there, and after lockdown, everything changed.
Sure.
So,
unfortunately.
But hopefully, we'll get another spot. But anyway, I saw Jeff Gregory there in 2017. He came in, and I think he was maybe in town for another event. He found out CRX was going on, so he came by, and I had my little booth set up with all my my synth cart with all my, I don't know, I think I had 3 or 4 Commodore set up. I had a Qualaman set up. It's kind of like a Qualipad where you can draw on it, and then the SID goes crazy, kind of like make music with a Qualipad. And then I made something called a floppy drum, which is like 4 floppy disks held with cassette tapes on the back. And then you use 2 number 2 pencils, and it's got tinfoil on each end, and you hit the metal. They're 3.5 inch discs, so you hit the metal piece of the disc with the tinfoil on the newspaper. I mean, on the pencil, and then that's plugged in through the joystick port. And each direction of the joystick is a drum sample. So basically, I took the wires from the Atari joystick and hooked them up to each floppy disk, and then you can kind of like play live drums on the 64. So cool. Jeff Gregory came by the booth, and he started jamming on the drums. I'm like, man, you're pretty good at that. And then I brought in a guitar on the second day of the show, which is a Casio DG20, which is like a MIDI guitar. And I had it hooked up to the C64 with synth cart, and I had like an ARP going on. And he came in and he was just jamming on that thing. I'm like, man, you know how to play guitar? Because no one else that was in there. I think we had another member of our Commodore group that knew guitar, but Jeff was shredding on that guitar. And I'm like, man, you make music or something? And he's like, yeah, I also make all kinds of stuff. So I got his information, and we weren't virtual yet, so we were just doing physical shows. Bitscape wasn't even thought of at the time. It wasn't until we went into lockdown that we did the virtual show, and then I thought about, this is something that I wanted to put into Bitscape anyways, and then maybe build something so when we have physical shows, we can have artists there performing live. So I hit up Jeff Gregory. I'm like, dude, I'm starting this virtual event with artists from all over the place. You got to get on the show and, come on in and, show us what you got. So he did a great performance that year. Yeah. And I wanted to have him back the year after, but we were kind of tight on artists. And I told him, dude, next year we're going to have a 2-day event, and I'm going to have a lot more room to bring back artists. Sure. So that's what we did this year, especially today, is a lot of returning artists. And yesterday we had a lot of new artists. So Jeff is back this year. He's got a lot of great music. So let's take it away and check this out.
All righty.
Tuned into the 2023 Bitscape Commodore Chiptune Music Showcase at CRX. Up next we have Jeff Gregory.
Jeff Gregory here. You're about to hear a set of original Commodore 64 SID tunes that I've made. If anyone is interested in using any of these tunes for a demo or a game, or if you'd like me to compose new music for any demo or game that you're working on, please visit jeffgregory.net and contact me via the email address shown there. I'd like to thank Sajtron for inviting me back to Bitscape, and I'd also like to thank Jim Drew and the rest of the CRX crew for hosting this event. Have a great weekend, and thanks for tuning in to Bitscape 2023.
Oh yeah.
And we're back. Wow, that was some raw. Hold on, I wrote down a couple of words. Raw, dirty, gritty, crunchy.
Crunchy. There you go.
That's what we love about the Sid, and Jeff Jeff knows how to put it all together like that. I mean, that was wicked. He was using a lot of interesting trackers on there. There was one you mentioned that I haven't seen before. I did see Sid Wizard and a couple of other things in there. Yeah, great job. So Jeff's work could be found on his Bandcamp, jeffgregorymusic.bandcamp.com. He's also got his main website, jeffgregory.net. And he's on SoundCloud as well, soundcloud.com/Jeff Gregory. Really cool setup he had there.
Yeah.
He's got all the old analog mixers, and he's an analog junkie. He's got a lot of cool gear. I remember
old school for sure.
We were talking about all the outboard gear he's got. He's got a lot of cool stuff. So yeah, thank you, Greg, for coming back to Bitscape. And yeah, we'll love to have you again, man. So get ready for next year.
But sign them up.
Yeah. Now that we're doing 2 days, we got room for a lot of returning artists. So this next artist is man, these guys crack me up. So
yeah, for real.
Labrat Warfare. They're from West Virginia. I came across their video and I was like, what the hell is going on here? They got it's kind of like a laboratory. Like they've got all kinds of retro stuff going on. You will see in these videos, they kind of fused everything together. They're kind of like in the lab creating stuff. And yeah, they're definitely lab rats everywhere. I mean,
they need some pest control for sure.
There's definitely some stuff going on in that lab. So Labrat Warfare is Ryan and Brandon, and they're really cool. Had a chat with them for a bit about trying to create a set for Bitscape, and they were totally down with it. They've got a lot of they do a lot of all kinds of music, electronic, dubstep, things like that. But these videos that he put together have the C64 in there, thrown in the mix with some of their other stuff going on. So let's roll it and check this out. Labrat Warfare.
All right.
Hi, I'm Ryan.
And I'm Brandon.
And we are Labrat Warfare. We want to send a quick thank you and a shout out to the folks over at Bitscape for having us out. We really appreciate you reaching out to us. Thank you. You can find all of our music on YouTube and Spotify.
In the upcoming music, you're going to hear the Commodore 64 as well as other video game consoles. I hope you enjoy it.
Thanks again and enjoy the show.
Warning, listening to the following music at loud volume. Make all rats to go through your speakers. Hypothesis formulated. Begin experiment. hypothesis formulated. Begin experiment. been concluded. Thanks so much for watching. Labrat Warfare.
Wow.
Right.
Wow, man. I'm speechless right now.
You're muted. Am I muted?
Oh, no, I can hear you.
There you go. I got it.
Wow. So they were like cooking up some experiments there. And every time they concluded each experiment, it just like, it peaked out to an apex. Incredible stuff.
Cool.
There's so much dimension in those tracks, man. So cool. Yeah, so these guys are awesome because they do like a great balance between all the different chips, you know, all the different consoles. They don't really like focus on one thing. They kind of balance it all out. I love that. That's really, really cool.
A lot of equipment though. That's why.
A lot of equipment.
Yeah.
And it was trippy because every time there was a new track, I'm like, hey, wait a minute, something's going on. Like everything's moving around. Instruments are moving. There's different rats everywhere. I think Crypto Boy was counting the rats at one point. I'm like, I think he was wasting his time because they kept appearing. Different rats were appearing and disappearing. Man,
they need some pest control there for sure, huh?
That was awesome, man. Really cool. We got to get if someone could post a song list of that set. There was some good stuff on there, definitely. Yeah, if you want to check out their stuff, they've got quite a few songs out. They're on Facebook, facebook.com Labrat Warfare, and you can catch them on youtube.com/C/Labrat Warfare. And yeah, I'm just blown away. I really would like to do something like that as well, trying to grab different consoles and make a track with all the machines going on. They did it right. They just did it right. The balance was really well made. The drums on that track, oh man, I love drums. So they did a really good job with that. Really impressed.
Yeah, definitely.
Anyways, we got a lot of good shout outs and comments on the Discord. So if you're not on Discord right now, head over. We've got Ray Manta coming up next.
Ray, another returning artist.
Yeah, one of our
he's resident though. He's like every year.
He's our resident Bitscape artist from day one when we started.
Yeah,
and Ray never disappoints. He's got
never. That's why he comes back every year.
Yeah, he's one of those like mind-blowing, mind-melting kind of sets. Because he does a lot of visual work as well. So he kind of fuses it all and melts it all together in a really trippy way. Yeah, so we're happy to have him back again on our 4th year. And he runs an iconic Commodore label called Datador out in Australia. He releases software and hardware titles. He did a hardware cartridge release on the Commodore a couple years back called Duck Cart. And I asked him a while ago, I'm like, man, that cart would be great if I could just use it as a visualizer. And he did say something about that. I hope he keeps working on that project. It'd be great to be able to do all those effects and stuff that they were doing with the Petsky graphics as a visualizer, as a tool. What else we got here? So he's a Petsky artist. I'm sure you're going to see some in the visuals. But yeah, let's let the viewers check it out for themselves. Let's check this out.
Yeah, a little SID box action too in this one, right?
A little what?
SID box action.
Oh, there's all kinds of stuff. Yeah, you'll see a mini box. Yeah,
a mini box. Yeah.
All right, let's check this out.
Tuned into the 2023 Bitscape Commodore Chiptune Music Showcase at CRX.
Hi, this is Tim Koch aka Ray Manta. First up is 8 minutes of a jam using a MIDI box SID that has 8 SID chips, 2 broken, featuring artificial intelligence generated isometric junk and strange robots, and a preen FM. Following that are some Pro Tracker Amiga modules that are forthcoming Amiga music disc, again with funky weird robots. Following on from that is an altogether too long last Ninja remix, made in Musicalc on a Commodore 64. I hope you like ring modulation as much as I do. Ha 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 ha. And lastly, observe as I play a questionable melody using Amiga program Sonics, emulated on a Sony Vita. Enjoy.
Hey.
Hey, what's up? Oh my God. So that was awesome. Ray Manta always giving us the incredible mind melting visuals. That was some crazy stuff.
Yeah, it's funny. I always think of Ray as like just the pesky guy, but there's a lot more non-pesky stuff in this. It was cool.
There was a lot of AI weird stuff with the legs and you could see all the imperfections the AI does, but he like accents those things.
Right. It's like, yeah, that's cool. Let's do that.
Like we want to see the AI imperfections in his videos. It actually fits with the music, you know? So awesome set again. Never disappoints. You can check out his music on his YouTube channel, youtube.com/@datador4079. And he's also on Bandcamp at raymanta.bandcamp.com. So yeah, and he just said on the Discord that the dub part is coming soon, visualizer. So
nice.
Something I've been waiting for a while. So yeah. So next up we got Ctrix. Holy cow! I just saw him pop in for a second. I didn't know he was gonna. Is he gonna be on?
I didn't either. He's here. Do you want to bring him in?
How do you do that? I thought I saw him.
I'll bring him in.
Yeah, bring him in.
Yo, Ctrix, come on in. Hey,
what's up, man? You escaped the zoo.
Oh, you're muted still.
Muted. Yeah, sorry. Everything's yeah.
There
I'm good. How are you guys? The zoo was epic.
I
didn't sleep at all, but yeah, it was pretty cool.
Cool.
Yeah, so basically hey everyone, to put it in, like last night, yeah, it was weird. My uncle won this competition where he was taking his nephew to the zoo like every couple of weeks because like his nephew loves the zoo. So they've been going for a year. And every time he was going there, he got put into a competition to win this like crazy like 20-person sleepover at the zoo where you bring all your friends and your family or whatever, and then you all sleep over and you have this midnight tour of the zoo and you go and see all the animals at night and have these infrared torches and so yeah, he won it and he just took all of us and we just had a blast. And it was like drinking and like they had like really nice food and they had like, you know, it was like gourmet sort of thing. It was wild. It was really cool. And then we all had these amazing tents that were set up like kind of teepee, but really high quality teepee tents. Yeah, and super comfortable mattresses. And so it was just weird, but you're in the middle of the zoo and you've got the entire zoo to yourself. And this is a big zoo in the middle of Melbourne. So yeah, it was really crazy. So yeah, I did that last night, but I didn't sleep much. Sorry.
Imagine that. I wouldn't be sleeping either. I'd be scared to death something eating me.
Oh yeah, you hear the roars of the lions and stuff, but you just hear the muffled version through the trees. So you hear this sort of like, and it's like you can feel the bass and stuff. It's real weird, like how it travels. So yeah, right. It was pretty cool. And then the elephant started up early at about 5 a.m. and all the birds and there was frogs and stuff. There was just sound everywhere. It was really cool. I wish I had a field recorder, to be honest. But yeah, so that's what I've been up to. Yeah, it's been pretty hectic. And checking out their sets. How cool was Ray Manta? That was just out of control.
Yeah, amazing. So, Saj, you're muted. Why did you mute?
I don't know what happened there. That was weird.
Aren't you a DJ?
It muted on its own. That was strange.
Well, you know, it's Zoom, so strange thing with Zoom. Yeah, so Ray was awesome.
Yeah, really good stuff. But Ctrix, wow, it's great to have you on here, man.
Yeah,
I had you were going to be available because you were out on that retreat, but I'm glad you popped in, man. So cool, man.
Yeah, no, I came straight here from there. I got a couple of hours sleep on the couch, got up for the last couple of sets, and then yeah, and then I was like, well, I better get the camera up. So yeah,
cool. This is your studio. You're in your studio now.
Yeah. This is just the studio. So I got my new school machine in front of me, and then I just have whatever set up for.
What do you got? What do you got going on? What do you got going on? Seen Amiga?
Well, I've got. Well, to be honest, I've got an Atari, but I chucked an Amiga on top of it.
Yeah, we know about your Atari.
It's under there, but we'll just.
Yeah, there we go.
So, yeah, the screen gives it away. And I've got just a VIC 20 and a 64. I just threw them up there. They're not actually hooked up right now, but they will be shortly because we've got Syntax coming up. But I've just got otherwise just like normal stuff like Dave Smith, which I use as a controller. And then what have I got today? I got a K1, K1. That's M1, Korg M1, like classic house.
Yeah, I remember that one.
Oh yeah.
And then a Grand, just a Kawai Grand. And then a DX7 on the shelf behind me, and whatever's on the floor, a couple of Yamaha Porter Sounds, and there's a Moog as well sitting on the other side. So yeah, it's just I swap things in and out as I need them, to be honest. I don't always have them hooked up. I'll bring them usually to this desk and hook them up, or if I'm sampling into the Amiga, I'll often sort of set that up over here and maybe have my old monitor over that side. So
that's so cool. I got a question for you. How long you been doing this? Because I going back, I see a bunch of your stuff that's old.
Yeah.
So how long?
91. Well, if you want to be totally correct, 84. Because when I was a kid, or 85, I got a copy of. Where is it? Still in one of these boxes. I can show you.
It's show and tell time, Saj.
Yeah. So Commodore 64, the music studio, which was like a really early C64 package. Actually came on tape so that you could save on
brutal.
But I remember we managed to get it onto a disc somehow. I think we managed to get a crack copy of it just so that I could use it as good. But I used to noodle with that before I was 2 years old, 3 years old, before I could even I could walk and I could have a chit chat and stuff. And so, but I could definitely run the Commodore 64, get that up and running and start stuffing around with it. So that was and I didn't want to play any of the educational games or any of the stuff that my folks had found for me to play with. I just wanted to play with the music studio and make sounds. I didn't even really make music. I just banged it full of just random notes and just played with the synthesizer section in it. So that was when I was probably 2 or 3.
Really? Yeah. Wow. So that really started your career for real.
Yeah. It was because they've got this program actually has a really it's it almost looks like a VST. I'm going to do a video on it shortly actually. And it really feels like the modern paradigm because it's got all your controls for the SID chip on the screen. And so and all the bits, I didn't really know what they were at the time. I kind of learned that LPF was a muffly one and something, and HPF was the sort of lighter one. So I kind of learned all my basics from synthesis in the 80s using what is effectively the very first VST, I guess, because it was all on screen control. And with probably one of the first cheaper computers that had a synth in it where you could do things without it being Cubase or something. So but then I didn't really know what I was doing, but it wasn't until 91 that I got into the Amiga tracking stuff. And that was on a friend's computer, but then I was stuck on a PC because I could only borrow an Amiga. So I was using Mod Edit on PC, which was pretty garbage, but I could get things and work on things and then take them to my friend's house to listen to them and see how they sounded with cross-DOS. So and I just kept noodling around and then eventually sort of managed to get an Amiga for a holiday period where I did a heap of stuff and then give it back. So that was sort of early 90s, 91, 92, 93, 94.
That's cool. That's a cool history. I didn't know that.
When did you start doing live shows?
That wasn't until later. If live shows in 99, 2000, when I sort of got to uni, I bought a Groovebox 303. And then I bought a Groovebox 909, and then I bought a sampler. It was a Zoom sampler of all things. But then I had these 2 boxes doing stuff. And then right about a week before a show, I was sitting with my Groovebox 505 in bed. This would have been 2004, I'm going to say. Or maybe 2005. And up until that point, I just used the Groovebox to play live. And because it was an all-in-one unit, I remember I was saving something and I kind of stretched as I was saving it, and I was right near sorting the end of the set, and the power fell out of the Groovebox. And what happened on the old gear when you powered it off when it was saving, the first thing it would do was wipe everything and then recopy itself into memory to shuffle a memory around. So I was like, oh shit, I've turned the power off. I know this isn't good. And I plugged it back in and pretty much everything was missing from it. It was just garbage. And then just half the stuff was there, but none of the custom sounds were there. It was all just completely wrecked. So I didn't know what to do because I had a smart media card with the backup, but it wouldn't run, wouldn't load. So I was like, well, I don't know what to do here because I'm going to play a show in a week. It was a warehouse party kind of amongst friends. So I was like, well, I don't have to technically bring anything. I could just say I'm not playing, but I might just bring out the old Amiga. And by then I'd got a 500 that I'd had kicking around, but it had always sort of had a semi. Well, no, it worked, but I didn't have a way to get anything onto it. So I ended up getting, I picked up a 1200 because I was like, well, I'll see what it's like to get like, you know, an Amiga again, because that's something I can take to a party that's like, I don't really care about because they're just cheap and everywhere you can just get them off the side of the street, you know, at that point. So yeah, I picked up, I actually bought a 1200, like people kept on their 1200s, but I got one for $50 or something. Because, you know, this is back 2004.
Yeah. Back in the class.
And I started loading my old mod files up and I was like, whoa, this is better than I remember it. And then, yeah, from there, I just went on a week binge. And I remember because it was like, it was about 3 weeks away from exam time at uni. And I just got suddenly massively obsessed with making mods again. And I'd always still made the odd mod in the background, but I just underestimated how good the Amiga has sounded. And so I just made a bunch of new stuff, took all my old stuff, like reworked it with like modern hindsight of me having like, you know, years worth of production on the Groove Box. And then just played this show and people were like, that was awesome. Keep doing that. Like, I was like, oh, here I am with like, you know, $2,000 Groove Box, $1,000 sampler, and people want to hear this $50 Amiga, you know?
Right.
And I was
well,
like,
you know
what? I really kind of like this Amiga thing too. Like getting back into it. So yeah, that's how I switched back. And I was like, well, bugger it. So it was a while ago, about 2004, 2005. And I just kept doing shows with the Amigas because people were like, use the old computers again. So I was like, all right. Yeah. And then from there, I mean, people like Evoke Demo Party saw it. And then, you know, I went over to see a bunch of demo parties and they were like, oh, come play the party. And I was like, well, all right. And then that led to chip shows and some YouTube stuff and just went from there. So that's the long version of the story, I guess, but that's how I got
cool.
into.
You ever
That's
notice
how I got into doing it live after years of hiatus from it.
That's so cool because you look at a history of everybody. It seems like anybody that was in Commodore at some point, they're back in Commodore whether they like it or not.
Yeah.
You know,
they come back years later.
Yeah.
Yeah. Well, I did actually play around because I work in video production now, and my first hands-on something that was more powerful than just a sort of switcher was the video toaster.
Right.
Nice.
So like when I was in high school, like the place I was working for had a video toaster. And so we used to do live stuff and they had the toaster running, doing their live, all their titling and things like that. So yeah. So I used to be preparing. So I did actually use it immediately. I'd be preparing floppy disks full of titles like ahead of time because I used to do the racing. That was horse racing stuff. And I'd have to get all the titles of all the things typed in and formatted. Then I'd give that floppy to the operator who would load all the files and dump it in and load them up for broadcast. So, you know, that was all done on the toaster, you know, so.
That's awesome. You actually used it like for real world applications for like TV.
Yeah, and it was sort of overdue in its time. Like this was 97. Where they were really holding on to it late, but it was standard def and it worked. So why would you use anything else if you were still 4x3 and standard def and the Amiga could do standard def output? Like
sure. Right.
Yeah.
So wasn't the toaster NTSC? Are you guys PAL over there or NTSC?
Yeah, we're PAL. So there's a PAL version.
Oh, okay. I didn't know that.
PAL version.
Oh, okay. I thought it was NTSC. Interesting.
But they never had the tower machines. They had the, I think there was the 3000s they were using at the time. But yeah.
Okay.
So I was just fascinated. And again, it was the Amiga showing. Every time I've used the Amiga, it was doing something that it shouldn't have been doing in a situation where it was like, I can't believe this thing exists. You know what I mean? Even then, when you think about it, there was a lot more that was available, but everything was just so much more expensive. Even 7 years later, 6 years later. I mean, it was.
Yeah, a lot of rave productions were done on the Amiga. A lot of them.
And live viz.
All that stuff.
Oh, and they were still using the Amiga into the 2000s. I remember going to raves when I was just starting getting into them, and people had the Amiga systems at the back of the room, just triggering stuff. And
I remember when that Amiga format issue came out with Aphrodite on the cover. And he was talking about the Urban Shakedown, Some Justice track. That was huge at the raves. And that magazine was circulating quite a bit out here, and everyone was like, "Oh my god, we got to get some trackers and start cranking out some tunes."
Yeah,
So-
well, Octamed yeah.
Yeah, they
It's
used
just a-
Octamed, correct.
Yeah, like Paula Power still uses A1200, and I mean, there's a lot of artists that still use Amiga. So
Yeah, back
Yeah,
then there was a lot of people were using them. STs too, but for
Sure.
sampling, a lot of them were using the trackers and stuff.
yeah,
Well, what they would do, it's because it had really tight timing, and it kind of works really well with things like drum and bass and even techno to some degree. And so like you wouldn't necessarily use the Amiga for sampling, or you might with its 12-bit card, but you'd use like an S2000 or whatever I've got over there, an EMU something, and you would have that external to the Amiga, but you would use it for its layout in Octamed with all its triggering and all of its things, because you could do stuff really quick where you could flip in and out, and you could copy and paste parameters real easy, where you couldn't really do that on Cubase. I know, because I've got Cubase sitting up running on that system at the moment, doing some YouTube stuff on it, and it's very clunky for electronic. It's great if you're trying to compose something jazzy and funky or with specific timing it's got all the SMPTE lock and stuff, but it just, as a raw for electronic music where you want a filter to go and then slowly build up, it just doesn't have the easy access to do that stuff. Like, you'd have to have extra external hardware stuff and be like probably on manual filters and things. Whether if you were just trying to use everything that was in your sampler and unlock it, plus build up a SysX library of stuff that you could easily call and throw out, like the Octamed was just great for that, because you could do macros or things that would link to pre-programmed SysX, and it would just become a command. So yeah, I don't know. It was just like that thing of like tight loop control as well, and just where you're in a loop, just refining the loop. Just for some reasons, trackers are just better for it, and people still use Renoise now.
Renoise is pretty dope. Yeah, Renoise is pretty sophisticated actually. Because now you can put like VSTs and all kinds of stuff in there, and so it's a pretty much a well-rounded software now. Really cool. Hey, I talked a little bit about, because this is how I found out about you. Years ago, I was watching some YouTube videos of your old shows, and you created this Gitari 2600. Talk to us about that.
yeah.
Well, at the time, because after the Amiga stuff, I discovered, it was once I started Syntax Demo Party in Melbourne, with my buddy Scotty. There was these people who rocked up who were the local chip music people, and they were using LSDJ, which is like a handheld Game Boy tracker. And I was like, wow, there's this whole like kind of little crew of people. I think I got on to the third one. And there was the guy who wrote the music for Defender of the Crown was there and playing on this like DX7 saxophone breath controller to all the original music and stuff. And it was like, wow, like there's a whole crew. But they had never really gotten to Amiga stuff or anything like that. They were more on the Game Boy stuff, and we all just started lending each other hardware. So as a sort of from that, I was like, well, what else can I make music for? And I just started exploring the options for, what other bits of hardware did I have? What could I get to compile and run, and went on this journey of starting to buy flash carts and dev carts, but it was all quite expensive. And the Atari 2600 was one that I was like, well, I can make an EEPROM cart for that. Like, I read up on how EEPROMs worked, and I was like, oh, well, this is pretty easy. It's just like, So I then was trying to make music on it, and there wasn't really any software for making music on it. So I wrote this little tracker program. Well, it was actually took OpenMPT, which is a tracker. And it took an impulse tracker file I made that I sampled every single sound from the Atari into it, because there's only 31 times 8 sounds, I think, all up. So there's like maybe, I think there is like 256 sounds. Sounds about right. And they're all out of tune. They're all atonal.
Yeah,
there's
the
noise.
a little off.
There's the engine sounds. And the manual says don't try to make music with it, because I looked up the documentation and it was like, this is not a digital synthesizer. It's out of tune. It's not for music. And I discovered there wasn't a lot of music for it. A few people had done things. I was like, right, that's it. I'm going to push as hard as I can and just fill up an entire 4K bank just full of like the fastest macros and things that are all like triggering off each other, and did it all just in like in OpenMPT, and then wrote this program that just converted the OpenMPT input to assembler, or that was bit banging basically straight to the the TIA chip. So yeah, that's how I ended up with these tunes that I'd spent hours cultivating every single fraction of a second with every tone, like, you know, jumping between noise and back and forth. And so I ended up with this Atari that I'd plugged into my speakers in the studio with the sub, and I was just like, whoa, this thing is like mind-bogglingly amazing. But it was a really hot input because it was I think it ended up with being 2 volts on the output, 2.5 volts. And because I'd stuffed up the resistor on the because you've got to take the like a resistor and put a filter on it to get the output out off the chip. And I'd undercompensated for the fact that the blast of noise you get out of the Atari are basically just huge. You know, they're maximized audio. So I was like, well, what have I got? I'm a bass player, so I've got my slap bass like pedal from my old bass days. So I just put that in line, and that gave me the option to shape the sound as an EQ. I was like, cool. I was like, I wonder what other pedals sound like. So I chucked a EQ, like a delay pedal, and I was noodling around with that. And I was like, because you run out of memory very quickly on the Atari. Like I found once I was doing these macros and things jumping around, I just needed some variation so I could like get in there with the delays and change things, and it sounded really cool. But then I ended up with the problem that I had an Atari, I had a delay pedal, I had a EQ pedal, and then I had all the power, and then I had the joystick to control and select and it was just a lot of stuff to have set up. And then Blip Festival, New York asked me to play, and I'm like, like I just need to have this so it's all on just a board. So me and my mate went to like actually build this board. And as you do with your friends, you just start, well, back in the day, just start drinking instead. And then it's like 3 PM and you're like, you're 5 or 6 drinks in. You're like, oh, shit. It's like the Atari. And I actually said, oh, the Guitari. And he was like, what did you say? Did you say Guitari? And we were laughing. He's like, what do you reckon? And I was like, do you reckon we'll make it a guitar? And I was like, oh, let's do it. And we looked at the back of the Atari, and it already had 2 holes in the back of it, or 1 hole, I think, that lined up pretty well. So I was like, let's do it. So we just literally walked to the hardware store that was around the corner from his place, and we just started buying bits. Like, oh, we'll mount it with this, we'll do this, we'll use these crappy L brackets, we'll use like Velcro, we'll Velcro all the pedals. And it was literally a single shopping set like that. And that was the Guitari. We just built it there and then, and we're just laughing the whole time. So all it meant was that instead of having to get on stage when you need to set up and take all of these bits and unpack a bag, you could just bring it up. But it became the Guitari. And it was just a joke. I was going to use it at one show. And then it didn't work when I went to play it because the DI box had gone flat. But the guy got it working after about 5 minutes of me just going. So the video footage wasn't good from it. So I was like, well, I'll do it one more time in Japan. Now I've rehearsed it. And that became the video that went up on YouTube. So that's how the Guitari happened.
Yeah, cool.
Yeah, that's a great story, man. When I saw that, I'm like, what in the world is going on there?
Yeah, well, it was like, what can you do with the Atari 2600? Because it's just
exactly
noise, right?
So much limitations on the Atari. And I never thought it sounded so good until I heard that video. I'm like, whoa, that sounds great. It's so raw and powerful.
Well, this is a theme, isn't it? This is why we do chip music shows. It's like, let's take the outputs of our systems that are designed to go through your Commodore monitor and actually plug them into like, some hi-fi gear and see what it sounds like, plug it into a couple of channels of a DJ mixer, add some filters, and what do you get, So I always love that surprise of plugging stuff in. And then sometimes you get disappointed. Like I had a PC Engine recently, which I've been doing stuff for, and it's just a bit fluffy and a bit muffly, and it's sort of not quite the sound I was hoping I was going to get, So it's funny, like different systems have different levels of impressiveness when you plug them in. But the Amiga and the Atari are probably my 2 favorite, I'd say.
What projects are you working on now currently? Music?
What have I got? Well, the PC Engine I've been working on a little bit. Really just, I suppose I've been exploring the ST with the MIDI control stuff because I've been doing a little series on YouTube about that. But in terms of old school, I've been mainly on the Mate tracker, which is like, do I have one here? Oh, I do have one here. I've got one under my desk, which is a little thing that Trash 80s made. It's a little thing, looks a bit like that.
Oh yeah, I've seen those online. Wow, those are neat. M8,
yeah.
Those are
and
cool.
So I've got a docking station that I've built for this that docks it out to. So this is a tracker, 8-channel tracker with all these synthesizers built in. Yeah, and I've got a little dock I 3D printed that breaks out all the mute buttons and a bunch of jump to positions and all the controls, so I can sort of jump around and do stuff on that controller. But I can also pick this out of the dock and go live if I want to as well. So just on the handheld unit. So yeah, no, I've been flat out on this. I played a show in London 8 weeks ago, just using the Mate, and that was pretty out there.
Yeah, I would say you were a physical artist. Watching you perform,
Oh, yeah.
You're jumping up and down in your seat just watching you perform.
Yeah, I don't know why that is. I think it's just from playing in bands and getting into tune. Even as a kid, I always used to jump around in music.
Yeah.
Yeah. So, but yeah.
You've got a demo party that you do coming up like in a couple of weeks, right? Can you talk about
we got
that?
syntax demo party. I think we're going to be streaming that as well, more than likely. So that'll be in November the 24th, I think it is, or is it 25th? Let's have a look. The 25th. So November the 25th and Sunday the 26th.
Awesome. How long you been doing these for?
2006, I think, or 2000.
Wow.
Yeah, 2006.
Wow. Awesome.
So, yeah, that's just, and we have a really good Commodore Pixel compo. That's like epic, that JazzCat has a lot to do with. Greets to JazzCat if they're out there. Yeah, and I don't know, it's just 2 days of mayhem. I mean, a lot of it is about just catching up and having a drink and hanging out. So we don't really we'll have the odd thing that's really high level, but it's mostly about getting together and watching things, and you know, and we have a wild compo that's really fun. A lot of people doing alternative platform stuff, like just random stuff. Like somebody made like a Vectrex printer at the last one.
Really?
Which was
How'd that work?
It took the Vectrex and then they bolted on a modification that sat on the beam controller on the back of the Vectrex and took in the vectors. So at any point in the vector, you could hit on this third party or this laptop that was like an old Core 2 Duo thing. You just hit a button and it would take where all the vectors were flying around and it'd find the point where it reached where it started again. It would call that the screen capture, but it captured it as vectors, and then it did all of the magnetron sort of reverse engineering, but then it used a Roland plotter to plot the vectors to give you a screen grab. So
that's great. It's amazing what the Vectrex community are doing with the Vectrex now.
Yeah, so that was a screen grab off the Vectrex. Yeah, that's
that's a cantina. The cantina.
It's a cantina
Yeah,
guy.
dude.
That's an animation someone had done on the Vectrex, and then they got it and screen grabbed it and then turned it into like the plotter output. But their thing was like, we're going to use a vector. It has to be vector output. At no point are we allowed to go to pixels.
Right.
So yeah, that's the kind of stuff people come up with. So it's a lot of humor in syntax as well. Like people just do some stuff. You're like, I can't believe you spent that long developing this, you know, just for a joke. But they won the combo, obviously. So
right.
Yeah.
Oh, that's cool.
Yeah.
That's really great.
I don't know. That's all of that. And how's it all been going? It's been a good weekend. It sounds like it's been epic times.
It's been good, but we're kind of sad. You're the last artist.
Oh well, so, I've got to bring it out then.
Yeah. Well, you bring it. That's for sure. I got to preview this. That's why I was saying you're an incredibly physical artist. That's what I have to say about you. Every time I see a video of yours, it's pretty amazing.
Yeah. I look pretty silly on the edge of frame. I shot it all on a 16 mil Sigma lens, but it's not designed for the camera that I'm using it for, so that it sort of vignettes the sides really hard. So yeah, if I look a really weird bendy shape on the side of the screen, that's what's going on.
Well, check this out. We actually had a technical problem. You want to talk about that, Jim?
Sure.
He was the one that was experiencing it. The video, remember the video playback?
Oh yeah. So we want to know, what codec did you use for encoding, because it works fine through VLC player or any kind of PC program, but for whatever reason, Zoom refuses to load.
Yeah, it would not play.
That's the latest build of the RTX 4070 H265 variable bitrate encoder. So it might have been because I used 265.
It could be. So I have a 3080 Ti card in this I'm using, and that's no problem. I can play it on VLC. I can play it on anything, work perfect. But Zoom does
Zoom
not.
did not like the video.
No, well, okay, yeah, Zoom lags a bit there a little bit.
Well, no, it actually pops up and says this file type is not supported.
Yeah, okay. So they're just a bit behind the times. I mean, everything else, I generally go, if I upload it onto Google Drive and I can see it, then it's using a standard library that should open it, but they obviously haven't supported 265. Which is weird because everything shoots 265, like, you know.
Yeah, we were testing all the videos and almost like last minute, Jim's like, hey, wait a minute, Ctrix video's not playing. We're running out of time. So we were
Did
like,
you re-encode it?
I re-encoded it. I tried different programs and we were still getting the error. I'm like, oh my God, there's got to be a. Luckily, I had Handbrake on the computer.
Oh, Handbrake would be the one to use.
Yeah, Handbrake did it. It was like
just need FFmpeg and it'll play it. Yeah.
Yeah, it played fine. So we were like, that was close. Because
otherwise, I would have had to do it live on the stream today.
After 2 hours sleep and then the zoo.
I know exactly. That's the punchline.
Well, I was telling Jim, I'm like, dude, we got to figure this out because Ctrix is in the zoo. We won't be able to reach him. So we got to figure this out.
Yeah. Lucky they let me out. Hey.
You want to introduce your video?
I mean, no. You'll get. It's got a joke on the start of it. That's all I'm going to say. And I'm doing but no. Apart from that, once we get into it, it's just a whole load of fun tunes. I was trying to play a whole bunch of stuff that I don't normally play or that was new. I even at one point just opened a work in progress and hit play to see what it was. I kept it pretty loose and pretty fun, and just stuff I wouldn't normally play. Hopefully it's a bit of fun. It's just that I break the filter button on the first tune on my mixer, my DJM 800. So occasionally I'm doing stuff and it's just still filtered, and I'm like, and that's why. But apart from that, it's just fun, silly bangers. Really, that's the category. So
awesome. All right, well, everybody, let's hang out on Discord, and we'll while we listen to the Ctrix set. All right,
apologies for the bad humor at the start. I had to do it.
Yeah, this is great. Check out this intro. It's so cool. All right, guys, see you in Discord.
Thanks, peeps.
Tuned into the 2023 Bitscape Commodore Chiptune Music Showcase at CRX. Up next we have Ctrix.
Hey everyone, how you going? Greets from Australia. Welcome to this inaugural ARX, the Atari Retro Expo. And I've got to say, I hadn't come across this one before, so I was pretty amazed when I saw my calendar reminder to say that I was doing this. But that's okay, we've got some bangers here. This wonderful computer with a sound chip from 1978, and this black and white monitor here. And of course, we have to use MIDI, so we've got this lovely Kawai that we've spent an absolute fortune on, and we're ready to rock some bangers. So here we go. Don't worry about the count-in, that goes in a minute. Yeah! All right, here we go. Oh yeah. Great for fitness routines, this one. Just wait one sec. I'll be back. This is, of course, CRX. This is an Amiga. This is a mixer, and I'm just going to drop a whole load of fun tunes for you. I hope you enjoy. This is a track from a very early demo I made. For me, anyway. I've been doing mods for a long time, since the early 90s, but
Yeah, I sort of dipped my toe in and did a demo at the very first Syntax demo party in 2006, and this was the soundtrack for that demo, which I think ended up at like 64K or 65K or something like that, so I was pretty proud of the size of this. So a whole lot of the tunes we're playing today are going to be across the board. Some are from demos, some are just for fun, some are collaborations, some are techno, some are synthwave. We're just going to let it roll. So hope you're enjoying CRX, and hope you enjoy this.
Well, sometimes you open the wrong version of a tune, and that was definitely well, I don't think it was an unfinished version. I think it was a version I finished for a show, but then I lost it. Obviously, it was in that folder wherever I copied it from, and I made a new version of it that had a different flow to it. So, yeah, I don't think that'll ever be played again, but that particular version, there's a lot of that kind of stuff here. So I just thought I'd play through a bunch of other stuff, especially some stuff I've just never played before. This is from a kind of like a BBS intro, I guess, track you'd say that I made. It's pretty small. It's something like 40k or something like that. And it's just a fun little jam, so enjoy. It's called Acid Step. It's not released, of course.
Yeah, that's a little bit of a Hoffman collaboration we did for a Spaceballs disc mag a while ago. Of course, it loops for that reason, but because we're dubbing it, we're not going to get the loop this time. Just quietly in the background there. Yeah, thanks for joining. This is CRX. My name is Ctrix, and I'm here rocking an Amiga and a DJM 800. Pretty old mixer this one now, but apart from being mono, it's still pretty fun. So let's see what else we can get happening tonight. I think we're going to listen to this track called Franco Bat, Not Finished, Work in Progress. Let's see what that is, hey? Could be anything. It sounds drum and bassy though. Oh, hello.
Well, there we go. That's actually a track from a Mega 65 demo for those of you who are on the Mega 65 platform that we did for Syntax last year. I collaborated with Onslaught and Defame. They asked me for a tune. I did troll them a little bit with it, but they didn't get the demo finished. So, well, they kind of did. They got a After Effects version running. They couldn't quite make the Mega 65 do the things they wanted, but apparently they've been working on it for a year. So you never know what we might see at the next Syntax, which is coming up soon on the 24th of November. A demo party in Australia, run by myself, Scotty, Abby and Chicken, and yeah, you'll be able to see all sorts of crazy stuff happen. That we have the Commodore 64 art competitions on the Sunday, which is very worth checking out. There's often some fantastic art there. So that's on the when's that? The Sunday the 25th, I think it is. But look up syntaxparty.org and that has a timetable with a whole load of stuff on it. Oh, I'm really dehydrated. So I'm going to get some water in a moment. But first, I'm going to play something a little old and fun. This is called Future Blue. I hope you enjoy. Much older tune. You'll be able to tell. I hope you're having fun out there. I'm having fun with a lot of these tunes. Just, the silly fun ones. It's what the Amiga's for, honestly. Some of the time.
Some old school fun stuff, why not?
Get stupid and rock the show, and yet you know that I will roll to the house get warm. Just from my glory, I was born with a dope affliction to write rhymes and rule the dictionary, so I make the whole crowd dance. Cause I've learned that rhymes sure do pay, and not time or pay larceny. Cause these rhymes will work for you and me. I'm on a chill tip, cold and lyrical, and at the two says, I believe in miracles. I'm on a chill tip, I'm on a chill tip, I'm on a chill tip, cold getting lyrical.
Look around you. Look around you. Just look around you. Have you worked out what we're looking for? Correct. The answer is what we're looking for? look around you. Just look around you. Have you worked out what we're looking for? Correct. The answer is
Well, there we go. That is it. That is my set for CRX 2023. I broke my filter button right at the start. See, it doesn't turn off, so that was kind of fun. Yeah, and I am really dehydrated, so I'm going to go get a cup of tea. And yeah, I hope you enjoy the rest of the show tonight. Thanks very much, of course, for having me on board. Especially the organisers and everyone who's kept the spirit alive. Hopefully, at some point, CRX is back in person. I'd love to come and check it out, maybe in the future. So, fingers crossed for that one. Maybe we can all
find a new place, a new home. I know it's been difficult for the peeps, but certainly the spirit lives on, and certainly with these live events, it means that people from Australia can join in. So thank you very much, and I will see you all at ARX. Just kidding. All right, see you all, peeps. Have fun.